Okay, so now I want to dive into calculated columns a little bit and show you how you can write DAX within them as well. Already we've gone through a number of different measures, just some quick examples around how you can write measures, right? Well, the thing is you can also create calculated columns which are utilize DAX as well, but are done within the tables themselves, okay? And if you're coming from an Excel background, this is generally your default, right? Because in Excel, you usually go to the end of a column, you write some specific formula, then you drag it down, and then that's how you get your calculations done. In a lot of cases on bigger data sets, right? You can do exactly the same thing inside of Power BI, right? Okay, you can do exactly the same thing. Now, before we go and do it, I'm going to go and do it, and I'm going to show you. But there is a lot of cases, right, where you don't even need to do this. And that is where measures are a much better way to run calculations. And so that's where it takes a bit of a mind shift, because historically it's just not what you're used to. You need to become more integrated with how to use, you need to really understand how to use measures more effectively, because that's predominantly where you're going to create your calculated columns. Your calculations, okay? But anyway, let's create a new column just to see how you would do it, okay? So I'm going to create a new column here just by clicking this button up in the ribbon, and I'm going to call this one costs, okay? Just simply costs, because we don't actually have the costs column inside of here, right? We don't have it. We've got total quantity sold and total unit cost, so we can just reference that. Now, the big difference about calculated columns is that they work at a row level here, right? So what I can do is I don't need to put a sum or any function in front of anything here. I can just go and reference columns directly. So I can go order quantity here, which is just this column, and I'm going to multiply that by the total unit cost. Okay, and then I'm just going to push enter. And so you see that this is going to work down every single row here, look at the specific order quantity and the total unit cost in that row, multiply them by our operator here, and then give us a result. Okay, then I could come in here and simply change it over to a currency, like so. And then I could also, check this out, I could go one more and I could say, okay, new column, and then I could go profits as well. If you think about it, I could go profits equal to total revenue. So I'm just going to reference that column minus the cost column, which we just created. Okay, and then I'm just adding that. Okay. So I would almost guarantee that this is what you would have initially done when starting out in Power BI, okay? Now, the great thing is you can do it, but the important thing to note is that you don't need to do this, okay? I'll even go as far to say is that calculated columns, you should never really need to do a calculated column inside of a fact table, like our sales table here, okay? It makes a lot more sense to do calculated columns up here in our lookup tables, because lookup tables enable us to create different filters, etc. Okay, so I just want to show you that quickly, and I'm going to come back and I'm going to delete this, and then later on down the track, you're going to see how we can actually calculate these particular things all virtually within measures, and it's a much more effective way to do it, okay? So, but what we could do here is, say for example, let's go to our products table, right? I could come to my products table, and I could create a new column here, like this, I can say, sales, okay? I know I've already got my total sales measure here, right? So I can actually place a measure inside of, use it sort of within my DAX function to get a column. And so I'm just going to go like that. And so that's giving me sales. And then what I could do from here is I could, for example, group my product. I could go product groups. And this is where this makes a lot of sense. Okay? And I could go and I could use a function called switch, and I could go true. And what this is going to enable me to do is I'm going to say, okay, well, if what switch true is, and we will cover this again. This is just me showing you examples, and I like to do this initially just to highlight a few things, and then we can dive back into the stuff later if you really want to, or we will, and so you can review that later on. But switch true is basically like nested if statements. And so what I'm going to do here is I'm going to say, okay, well, if say sales, so if the sales column here, right, is greater than 10 million, then I want to equal this to top, and then I'm going to go down to another one. I'm going to say if sales is less than or equal to 10 million, I want this to equal bottom. Okay, so this is where I'm just showing you some, and then we can put, go blank here like this. I'm just going to go enter. And so you see here that this is a perfect example of how to utilize calculated columns inside of Power BI, because it's where you can add to your data model. This is the way to think about it. You can add to your data model, and you can find a way to create different filters and dimensions in your data that could ultimately be filters in your reports. So for example, say for instance, we wanted to just look at the top and bottom results based on all of these measures we've calculated. Well, I can now use, you see this product groups column, right? I can then use this inside of here. And now we can create visualizations, just based on what are our top products and what are our bottom products. And this particular piece of analysis didn't exist before, okay? And so this is where I want you to utilize calculated columns. And then measures, I want you to utilize measures for all of the sort of big calculations that you want to do over your bigger tables, like your factor tables, okay? Because we can go and calculate these things all virtually rather than physically implementing them into a table. And that's what you want to aim for. The measures, your virtual calculations, enable you to do these sort of create these sort of insights far more effectively. And you've got to think, whenever you create a calculated column as well, it actually takes up room and memory in your model, because your fact tables could be a million rows long, right? And what you could be doing here, if you go and create a calculated column here, is you could be creating a million different data points in a particular column, which aren't required, because you can go and calculate that result virtually using a measure like these, and then just dragging that measure in. And measures only calculate when they are used in your report page that you're looking at. So you can have so many measures here, but they don't actually take up any room until you drag them in and use them. But calculated columns will recalculate every time you refresh your report. So if you push refresh here, a calculated column will go and recalculate every single result. And if you've got millions of results and you've got multiple calculated columns, you can see very quickly how that can mushroom and cause issues and slowness in your reports. Okay, so that's just a bit of a summary around the difference between calculated columns and measures, and when I want you to use one versus the other. And, as I said at the start, measures are going to be predominantly what you use, because that is where most of your calculating will happen. Calculated columns are just better to build out your data model, build out the insights in which you can showcase inside your reports. And that product groups example is just a really simple example of that. Okay, let's move on to the next video. Okay, in this video, we're going to really drill into context and what it is, okay? Now, I've mentioned this before, it's a really important concept to just understanding how DAX works and operates. Okay, so what I'm going to do, I'm going to clear these all out, and I'm going to reset my page and what I'm going to show. So I'm just going to bring in the date table here. I'm going to get rid of this hierarchy, which I don't really like, and I'm going to bring in my total sales measure here, just to show you. Just bring it down here. I'll also create a slicer up here. So I'll just create a simple date slicer like so. I also want to look at this as a table as well. Okay. Okay, and we'll add a couple other things here. Let's just have a quick look. We will add a product name, and we'll turn this into a slicer as well. And we'll add one more here. I'll just copy and paste this, and I'll add some customers as well. Okay, and we could turn this to a drop down. Maybe that works better for the product. Customers. Okay. The concept of context is not that easy, but it can be very quickly forgotten. And my recommendation to you is just to never forget it. Okay, you truly need to embed the thought of context into your mind. Like, you almost need to repeat it to yourself constantly as you are learning DAX. You need to go, what is the context in this calculation? Okay, so I'm just doing a few fix-ups here just to make things a bit clearer. Okay, so context is the environment in which a measure is calculating in. Okay, and context can come from a number of different places. Okay. The thing to think about initially is to think about every single result individually, okay? Because every single result in Power BI is calculated individually depending on the context. So let's just really drill into this specific result here, okay? So 139,152, okay? What is the context in this calculation? First of all, the easy thing to identify is that the initial context is this particular date, right? The reason why we're getting this particular result here is because of the 27th of the 9th, 2019. That is why we are getting this specific result. Okay, so that's one place that context can come from. Another place that context can come from is, say, this particular slicer, right? There is some dates that we are drilling into, and this slicer is giving us that range of dates, so it's creating some overarching context on our report page. But we can drill even further, right? We can create context from, say, our product. So let's just select on a product. So now this particular result doesn't even have a result on that particular day. So maybe we want to actually select, say, multiple of these. So I can just select multiple products now. Right, and this is again creating context for my results here. So you see this 27th of the 9th is now 64,000, but that's because we have a context from our date, but we also have context from our products. But then we can take that even further, and we can place context from our customer name column as well. So I'm just again placing some additional context, and you can see here that all of those results are changing. Now the one thing, a lot is changing in all these selections here, but what is the one thing that did not change? This measure never changed, right? So no matter what, all of these changes to the selections and context that I was creating within my report, my measure stayed exactly the same. And this is the true power with DAX inside Power BI, is that you can write really simple formulas, but due to the context you overlay to that formula, you can get an enormous amount of results very, very quickly just by making selections. Okay, so it's truly, truly powerful, in terms of the speed in which you can really drill into certain results due to, with very simple formula and just due to simple selections or changes to the context. That's what I want you to repeat to yourself. It's not just that you're putting a selection on a slicer, you're changing the context of an individual result. Okay. And then we could take things even further. Say, for instance, we want to have a look at the sales of our channels as well. And I'm going to turn this into, say, like a donut chart or something like that. Well, then I could also create context by selecting within a chart as well. So I've created context here by my selections here in the slicer, more selections here in the slicer, and then I've also selected inside the visualization. And then ultimately that's how I'm getting this new result of 40,000 on the 27th of the 9th, 2019. Okay. So what is happening behind the scenes? To round this area off, this section off, what is happening behind here? Okay, so whenever we make a selection, this is where the model really comes into its own. Whenever we make a selection here, a filter is being placed over a particular table, right? So, for example, we've selected some products. Well, this selection is being applied to this particular table here. Then those filters propagate, this is an actual term, filter propagation, they propagate down through this formula, because you see that we've set it up as a one-to-many with an arrow pointing down to a fact table, which is primarily what you want to use. Those filters are propagating down here and then placing a filter over the sales table. The same is occurring at exactly the same time from our customer table. And then we also have some filters coming from our date table, right? And so filters are also propagating down through this relationship where the arrow is pointing. We also have a filter coming from our sales table, from the channel column, right? So all of these filters are being placed on our report, or context is being placed on our report. They are flowing down into the sales table. They are filtering the correct results based on our selection. And you've got to think this particular table then reduces in size quite significantly from, say, an 8,000 row table to maybe a few hundred rows because of all of the different context that we've placed on these particular results. Then the particular formula is doing exactly the same thing, but it's only working over our a much more reduced table size, or a much smaller subset of our original data table. Okay, and then that is how we're then getting a result with the same formula. Okay, so that is the theory behind what's happening. That is the sort of image that I want you to really have a think about for every result. Especially if you're starting out with DAX. Like, this is how DAX calculates. It is exactly the same no matter what data scenario you're dealing with, no matter what report you're in. It will always the context and the filters always apply first, and then the formula then goes and does its work on a revised table. Okay, there's many ways that you can adjust this and do far more advanced things, and that can certainly start occurring when we look into virtual tables. But this is theoretically how it occurs in a very simple model like we have right now. Okay, let's move on and get even more specific around some of the types of context that you can have. Just to reiterate the point here around context, is there is actually a number of different ways that people talk about context. Okay, so I want to just refine how I want you to think about it from my perspective, because I try and really simplify it down quite significantly, because in my view it's been somewhat overcomplicated in other references. Okay, and I'm going to break it down into three different parts in this video, the next two. So evaluation is evaluation context or initial context, aggregations, and iterations. Okay, now in this video, evaluation context, just to highlight it once again, is most of the things that we are showcasing on this report, right? Okay, what we're looking at right now. So evaluation context is like the initial context which is placed on any particular result before DAX or your measure goes and does its work or goes and does its calculation. Okay, DAX usually works in two ways. You first of all have the initial context placed on your function or your measure or your formula, and then your formula can then work in two different ways. It can work as an aggregation or as an iteration. Okay, but the evaluation context is so crucial first up. Okay, and that's where it can come from, say, a slicer. It can come from a selection in a visual. It can come from something in a table or the access on a visual. Those are all the things that are like what your calculation is initially evaluating in. Okay, and that's the thing I want to stress, is that before this function goes and does anything, it goes and works out, okay, what am I calculating over? What table am I, or table or column of information am I working over before I then go and sum it up, or I then go and do my calculation? Okay, so it may sound simple to some. You might be thinking, well, this is easy. This is what pivot tables do, which is exactly what they do. It is exactly what they do. But the thing about in Power BI is that once you get past that evaluation stage, so that initial context stage, well, then you then have to work out, okay, well, what is your formula then doing inside of that initial context? Okay, and that's where it can slightly get a little bit more complex, and where it is totally unrelated to, say, a pivot table type analysis, because you can create very complex formulas within that initial context, and you have to first of all really understand the initial context, and then understand the way that calculation is being done. Is it being done as in an aggregation, or in a filter context? Is it being done as an iteration, or a row context? Okay, and that's where things can get a little bit tricky, and that's what we need to focus on in the next two videos, to really understand, okay, well, what type of context is a formula operating in? And as I said earlier, I've tried to simplify this down by more focusing on, say, aggregation logic or iteration logic, and that enables you to more easily think about things in your mind around how the calculation engine is actually working inside of Power BI. Okay, so let's dive into these two next. Okay, so as I said in the video before, I don't want you to get too confused by what filter context is and what row context is, okay? I want you to actually just think about these things far differently. That's if you've heard of these things before, okay? But what I want to really dive into here is basically two types of ways that measures themselves calculate, okay? Now, we've gone over the evaluation context now, quite in depth. Hopefully, you've got the hang of that. And that always happens first, okay? So always remember that the evaluation context does its work first. Then, when you write or place a formula into a visual or a table, the calculation engine, or the way that DAX calculates, can actually work in one of two ways. So there's actually like two calculation engines within DAX itself, okay? One is what is called an aggregation engine, and one is an iteration engine. And depending on which formula you use, the corresponding calculation engine will work, okay? So let's have a look at two of these. Okay, we're going to go through two simple examples, and then you'll get the hang of it, you'll understand it, and then we will go into, it can get more advanced, where you can have multiple type of, you can actually, in one formula, use aggregations and iterations in the same function, but getting a good grounding here is essential. So let's just dive into, first of all, what an aggregation is, okay? Now, an aggregation is really as simple as it sounds, okay? And you call it by using simple formulas that you are already used to inside of Excel, if you've come from that background, okay? So these are simple things like sum, okay? Sum is an aggregation formula, because we're just basically going to sum up what is in a particular column, okay? Another simple aggregation formula, it could be average, okay? So I'll just work, just create some measures and show you what I mean here. Okay, so we could go formula examples. So average is another aggregating function. So you see here, returns the average of all the numbers in a column. So I could just go average, and then it just tells me that I can put a column name in there. The same as min is one. This max is another aggregation. There's count. There's count A. There is count blank. And so I can go on and on. Basically, an aggregation works in a way where the initial context is placed on all of your results, right? So let me just get out of this. Let's just delete that. So you've got the initial context. But then, so once all of that initial context is applied to your data, the aggregation engine will just go and look at, okay, what remains in that particular column. So remember, your table is more likely very revised because of all of the additional filters and slices that you've placed over your initial table. So your initial table is going to be far more reduced, going to be much smaller. And then that sum is going to come to that particular column, the total revenue in our particular example, and it's just going to look at that entire column, and it's going to sum it up all at once. Okay, and that's what an aggregation does. And the same could be said for, say, like an average. It would just go look at that entire column and then say, okay, average smaller. For a min, it would look at that entire column and just return the min value. Okay, that is what I mean by an aggregation. Okay. And that is what is also referred to as filter context. Okay, so you'll see this filter context reference a lot, but I don't want you to think about it as filter context. I just want you to think in terms of aggregation, because that just simplifies it like enormously. So the sum here is just going to do a simple aggregation. It's going to just look at everything and do a calculation and aggregation all at once. Okay, and you might maybe think, well, this seems odd. This doesn't seem very difficult, but it is very important to differentiate between what this particular sum is doing here versus what an iterating function could do, which can calculate up to the same result, but can do so much more. Okay, and an iterating function works or the iterating engine, if you like, the calculation engine works in a very different way. Okay, and that's what we're going to cover next. And then you will very clearly see that there is quite a big difference. And there are certain situations where you should definitely use an aggregating function, and you should definitely use an iterating function. And that by the end of by the end of the section, I really want you to have a good understanding of that. Okay, so let's move on. Let's move on to iterating functions, and we'll run through an example of what an iterating function does. Okay, so we've gone over aggregations. Now I want to go over iterations. Now, iterations work is a different calculation engine, right? Okay, and it will calculate this way if you reference these specific formulas, which are basically iterating functions. Okay, what I'm going to do is I'm going to show you how I can calculate up this exact same result. Okay, exactly the same result, but I'm going to calculate it, and I'm going to use a different calculation engine. Okay, if we can have a look at our data, let's go and have a look at our data here in our sales in our sales table, okay? So you'll see here that we actually have this total revenue column, right? But we also have what makes up that particular column, that physical column. We have the order quantity and we have the total unit price. So what I'm going to do is I'm going to use an iterating function to calculate this result without even referencing this particular column, okay? I'm going to reference these columns here, and I'm going to show you how this calculation engine works in the process, okay? So I'm going to go new measure here, and I'm going to go total, I'm going to call it total sales iteration. Okay, I'm going to go down to a new line holding shift and enter, and I'm going to go sum x. Okay, now the key to iterating functions is they have an x on the end. Okay, so I'll just quickly show you. There's average x, so you see average x here. There's also min x. So a lot of the aggregation functions, they all have this iteration element to them. Okay, so in this particular case, I'm going to go sum x. Then I'm going to reference my table, which is the sales table. Okay, then within here, you probably, if you've watched some of the earlier videos, you'll see that I've done an example of this before with a total cost measure. But I just want to show you, I just want to highlight something here. Okay, so we're going to go sales table, then we're going to go order quantity, right? Order quantity times the total price, the total unit price. Okay, and then I'm going to go enter. Then I'm going to bring this over into my table, and you'll see that it's calculating exactly the same thing, right? Okay. Now, what's interesting to note here, though, okay, is it's calculating exactly the same thing, but it's calculating it in a slightly different way. The calculation engine is working differently, okay? As we reviewed just in the previous video, this worked as an aggregation. It looked at what column was left over, and it just did one quick sum of everything that was left over, okay? An iterating function works differently, though. It iterates through every single row and works out some sort of logic, okay? It iterates through every single row in the table that we reference individually. It goes one row, second row, third row, so on and so forth. It goes and does the calculation for us at every single row. So let's actually come over here to the table itself. It goes to the first row here, and it goes 11 times the total unit price, 3926. It then saves that result. It saves that result into memory, okay? It goes and saves that result into memory. Then it moves down to the next row. It goes and does the same thing, saves that result into memory. Then goes down to the next row. It goes and works out this logic and then saves it into memory. Once it's gone through every single row, it then has all of these calculations for every single row saved into memory. It then goes and does the sum. It goes and does the aggregation at the end, okay? And so you see how different that is? It's doing a lot more work from a computation perspective because it's having to look through every single row and go and do a calculation. Okay. Now, in this particular example, it doesn't matter so much because we have the total revenue column, so we could just calculate out the total revenue column. Okay. So that is an absolutely fine thing to do. This is just me showcasing what I mean by the iterating engine. One interesting thing to note is that if you really wanted to, and this is maybe what I would do, is I would maybe even delete this column. I would delete it in the query editor because I know that I can calculate it within my measure using an iterating function because I have the underlying factors that roll up into this particular calculation. And what this will do, it will actually save when I save my model, the actual size of my model will be smaller because I won't have all of these physical data points in my model anymore. I'll just have the virtual calculation, which will only do its work when it's called. Okay, so that's just something to think about as well in terms of how you can optimize things with iterating functions. But remember the example we went through earlier where we actually did need to use an iterating function because we don't have the total costs column here, right? We only have the order quantity and the total unit cost. Well, that again is that same sort of pattern, if you like, where every single row we are calculating up some logic. We're going order quantity times total unit cost. We're completing that logic at every single row, saving it into memory, and then doing a sum at the end of it. And the difference between the other iterating functions is that instead of doing a sum, we might do an average at the end of it. We might just go and work out the min result at the end of it, or max result. And what iterating functions enable you to do is some advanced logic at every single row, and then get your result from there. And this is the main reason why you should never really require calculated columns in your fact tables, because an iterating function can do all of that work for you. Okay. And that is a very key point that I just never want you to forget, because that's where you can really go wrong in your model, is thinking you need all these calculated columns when you don't. You can utilize iterating functions. Now, these are also referred to a lot as row context, okay, because an iterating function calls row context. But the way I think of it is I like to think, okay, an iterating function calls the iterating calculation engine. That's how I think about it, and I think that is a far more simpler and effective way to think about it in my personal view. Okay? Okay, so hopefully you're starting to get the hang of this. Let's review. Evaluation context, initial context always happens first, okay? Then the calculation engine can break off into two different parts. Okay, it depends on the function that you're using or the formula you're using. It can go into the aggregation engine, or it can go into the iterating engine or the iteration engine. Okay, and the calculation engine will work differently depending on if you just use a sum versus a sum x. So hopefully, okay, so that's what I wanted to cover there. Obviously, going through more examples, this will be highlighted more and more all the time. But a lot of the terminology that I'm using now, I'll reference a lot over the rest of the videos throughout the course. And so having a good fundamental understanding of this right now is crucial. Okay, let's finish this one off, and we'll move into understanding context and how it actually works within calculated columns. Okay, here we're going to briefly go over some of the nuances to context within calculated columns. Okay, now as you know, as I mentioned earlier in the section, you don't need to use calculated columns that often, and I basically say within your fact tables, I don't even recommend it at all, because you just don't need it. You don't need to if you utilize measures effectively. Okay, but what I do want to show you is what I mean by context and some of the things that might sort of trip you up a little bit. Okay, in essence, when you're talking about calculated columns, so let's just run an example, even though I don't really want you to do this. This is just for demonstration purposes. Okay, so I can call this one costs. Every context within a table, or when we're creating a new column, it always starts off with what's called a row context, because we can only reference columns in our formulas here. So I can go order quantity times the total cost, right? So the total unit cost. So you see here, I can only reference these columns. So how do we get the particular result that we, the particular correct result? Well, it's the initial row context that we are looking at, right? Because we're in this particular row, it then goes and picks up, okay, well, it's 11 and the total unit cost is this. And then the next row is 11 and the total unit cost is 1,579. Okay, so that's how initially things start out as in a calculated column. Okay, where things can get a little bit tricky though, okay, where things can get a little bit tricky is when you start using or trying to run calculations inside of other tables. Okay, so for example, you know how, so this is a fact table, right? So we don't want to be doing any calculated columns here. If we do want to do any calculated column, it makes more sense to build out our model or build out our analysis and filters and etc. within our lookup tables. Very similar to what we did earlier with the products table, right? Where we ran some sort of calculation and then grouped our products based on their results, okay? Those calculated results. Now, I want to show you something important though to recognize. I'm going to create a new column here, and I'm going to go and call it sales, or I'll call it customer sales actually, customer sales, okay? If I try to do this, go sum of the revenue column, okay? If I try and do this, check out the results we get, okay? What happens is that because of the model that we have, or because of the initial context that we have in this particular results, the row context does not actually, can't actually work with filters here, okay? It doesn't actually enable me to utilize this filter that I have in place in my model, okay? Row context basically just has no relationship to filters. This doesn't work at all with filters. And so for us to get this to work inside of a table like this, is we need to utilize what is called a technique called context transition. We need to transition from a row context here, which doesn't work with filters, to a filter context, which will enable us to work with filters. Okay. Now the way that you can do that inside of here is using a function called calculate. This is just one of the many ways that you can use calculate. Calculate, in essence, enables you to change the context of a calculation. That's the way to think of it. There's many different ways that you can do that. But this is just one of those examples where we're changing from a row context to a filter context. And so if I add calculate around there like that, then now I have the calculations of all of the sales for my customers. Okay. One thing that's interesting to note though is that context transition happens automatically when you reference a measure inside of here. Okay. So we can utilize we can write it in this particular way, but my recommendation is to create the measure first and then reference the measure, because the measure is essentially doing that calculate around the sum already, okay? And so when I push total sales like that as a measure, you'll see the results are exactly the same. If we come and have a look at the underlying total sales measure, it is simply that sum of total revenue. What you got to think or visualize is when it's in this particular table here, it's referenced as a measure, that calculate is automatically being placed on there. Okay, and that context transition from a row context, which doesn't enable us to work through this relationship to go and figure out what is in this table, is then able to work now because we've changed it from a row context to a filter context. Okay, and then we can go on and do whatever calculation we want after that. Utilizing just this measure by itself inside of this table is pretty pointless, because we can calculate this, we can visualize it much better within our report page just by utilizing this measure, right? But this is what I mean by building out your model. Very similar to what we've done here, is that we can say create some additional dimensions based on these calculations we might do. One interesting thing to note just to add here is that you could ultimately do this too in this particular formula. Instead of having that intermediary column here, you could just have this and you would get exactly the same results. But this is again just an important thing to just review though and understand how this particular thing operates. But if I was doing this myself, I wouldn't have this intermediary step. Same in the example we just covered. I wouldn't have this. I would actually just integrate this measure into some sort of calculation that I was doing to create that additional dimension. That would be my preference. Okay, but we obviously have to step through things so that you understand how things actually operate and work. And hopefully now you have a much better grasp about this concept of context transition, why you need to use it, and when it's appropriate to use. The most important area where you need to use it is mainly in here with these calculated columns. But it can also occur, you might also need to do it sometimes within a measure, and that's where it can get a little bit tricky, but I'm smiling as I said because it's so fascinating how it actually works within measures. So I look forward to covering that in a bit more detail in some of the more advanced sections later on. Okay, so let's move on. I'm almost at the end of the section. Just one more video to go. Okay, this video is just merely a summary of what we've gone over before, and just an opportunity just to reiterate a few things. Okay, so I'm just going to set things up here. So we've got our total sales and we've got our total costs here, right? Okay, now the key thing to note though is with these two particular formulas, right, or these two particular results and insights that we're seeing in this particular table, is the evaluation part of it, the evaluation context, the initial context, the environment in which these formulas are doing the work is the same. Okay, the initial context is coming from here, it's coming from here, it's coming from here. It could also be coming from here. You know, if we select something inside of here, all of that is the same, regardless of what these formulas are individually doing. But once we get past that point, once we get past the evaluation point, then these two particular formulas are doing very different things. The aggregation engine inside of our total sales is doing its simple aggregations. The iterating engine that is working inside of total sales function is again working in a different way. It's iterating through every single row. But the thing to remember here is what they are doing the iteration and the aggregation over. It is over exactly the same table, which has all of these different filters applied to it based on our model. Okay, and you generally, as I mentioned, you generally want your model set up this way with one-to-many relationships, just to keep things simple. Look up tables at the top, fact tables down the bottom, and then that enables you to visualize what this end table, what this filtered table looks like, right? All of the filters have propagated down to this particular table. Now this table is a far different shape. And let's have a look, where are we? This table is now a totally different shape based on all of those filters on customer, on channel, on product, right? It's now a far different shape, and then the aggregation is just doing one big aggregation. The iteration is working over only those rows that remain after all of that context is in place, and then it's doing its iteration of that. Okay, and then that's how we ultimately get these results, and how we can also switch between or get different results based on different context that we overlay. The formulas themselves, regardless of what engine we're using, do not change for every single result here. They're exactly the same. The results just change because of all of the different context that we have on each of those individual results. Okay, so I've reiterated myself a number of times there, but I just cannot stress enough how important this stuff is. So hopefully some of that explanation is really starting to sink in. Now, one last thing that I highly recommend is that when you are trying to understand formula and trying to understand context and trying to understand why you're getting results that you're getting, put your results in a table. Okay, just like I have done here, because it really enables you to see what is actually going on for each individual result, and that is absolutely crucial to your thorough understanding of DAX and how it is actually operating. Okay, so I think that's enough for this particular section. Hopefully you've got a really good fundamental understanding of these very important concepts, and I think now we're ready to move on. Okay, let's dive into some more function-specific things and specific formulas that we could be using. Okay, so here I want to introduce you to the DEX formula reference guide. Okay, so this is in the resource pack that you have with this particular course. And whilst I'm not going to just focus in on or go through any of the details per se in this very detailed guide, it's about 60 pages long. It has basically every single DEX function you could think of is listed in here. I just want to show you how DEX formulas are broken down. Okay, and so by doing that, you'll see here this is all the table of contents. But within DEX itself, there's lots of different types of function types. Okay. And here are just a few. So we've got date and time functions, time intelligence functions, which we'll be going over in depth. I mean, we'll be going over every section here, but this just breaks it down. Filter functions, information functions, logical functions, math and trig, other functions, parent and child functions, statistical functions, and text functions. Okay, some of these you're going to use far more than others. Okay, but there is the function set that covers nearly everything that you could possibly want to do, obviously, inside of Power BI, and it's being added to all the time as well. A lot of new functions have come out ever since Power BI was released that have handy little uses. But in all seriousness, though, the core functions that you'll use over and over and over again are have been baked into the platform, into Power BI ever since the beginning. Okay, and those are the functions that we will be focusing, really drilling into for the rest of this particular course. Okay, so look, what I want to show you here is to just introduce you to this particular document, and then also to show you how things are broken down. In terms of navigating your way around, you can actually click on the specific areas in the contents, and it will actually take you down to specific functions that you can obviously review and try and understand in a bit more detail. And then obviously you've also got the and then you've got the detailed resources within Enterprise DNA Online, which you can then reference and go and search for certain things as well. In terms of how you can specifically do that, if you want to search for specific content, I think there's a good sort of segue into how you would do that. Well, what you can do is you can go how to search for content. You just say click on here, and then that enables you to type in a particular search on a function, etc. And then it will take you to all of it. It will show you all the videos that you need or that you can review on that specific area of Power BI that you want to focus in on. Okay. But in terms of this particular section, we're just going to get started with DEX, and this is just a good document to review for in terms of learning how to break out the certain segments of DEX and the DEX function types, and then ultimately you want to be able to figure out, okay, well, what DEX function should I be using for the particular answer that I need. And that's part of the thing, right? This is what I mentioned this right at the start. It's one thing understanding DEX, but it's then how do you apply it? How do you know what function to use in which situation to get the answer that you want? And that's where having that's a really good fundamental understanding of how things actually work, how things actually operate with the calculation engine is just absolutely key, absolutely essential to utilizing DEX well in Power BI. Okay, let's jump back into our model, and we'll start working away at some simple DEX formula. Okay, quick bit of revision here. We will go through relatively quickly the things I think we've already covered a little bit, but I just want to actually create some measures and flow through creating measures so you can start doing it yourself, but also at the same time see how quickly you can do all of this. Create all of these measures. It can happen very quickly if you just get in and start doing it. Okay, so I'm just going to rearrange things here a little bit. Okay, I'm just going to get rid of a few of these things. Okay, and I'm going to come in here. I'm just going to tidy up. I'm going to go and grab my customer name column. Okay, I'm going to bring it in here. Okay. Then what I'm going to do is I'm going to bring in my simple sum. Okay, so we already have created a measure that is an aggregation measure, right, which is just summing up a column. Really, really simple. Okay, I'm going to bring this into my table here. I'm actually also going to delete the things that I don't want in here because I want to keep things really, really focused. So I don't want that. We don't need this total sales iteration anymore because remember it's already calculating. So that was just an example. Okay, but let's have a look at some other ones. Okay, let's have a look at creating an average. Okay, so let's go new measure, and then I'm going to just call this one average sales, right? And I'm just going to use average. So simple as that. Simple as that. Just select it, go tab, and then I'm going to go and grab the revenue column here, and then I'm going to push it in there. Okay, and let's drag this in here. Okay, so we get a very different result. Now, how do we think about this? We think, okay, what is the initial context of this particular result? Well, there's some evaluation context happening here. With initial context from our date table, so we're only looking at the dates between these very specific dates that we have in our range. Then we have some other context coming from this specific customer, 21st Limited. Then after that point, the aggregation engine is called because of the average. And then what we're doing is we are averaging up all of the revenue that is left over in this date range and for this customer, and then we're getting an average of all of those revenues within those columns. Okay. Then the same is happening here. Same is happening here. Okay. Let's go and use another aggregation function. Right. So let's just go new measure again. And then I'm just going to go min sales, and then I can go min, and then again, I'm just going to reference that particular column. In a lot of cases, you only, initially when you're starting simple, you only need to reference a few columns here, right? Okay, you don't need to do anything complex. It's usually like, say, a quantity column or one or two columns that you might want to aggregate up, and then from there you can do a lot more things, post like time intelligence, grouping, averaging, all that type of stuff. Okay, so I've got min sales here, and then I'm going to drag that in. And then I'm going to again create another one. So now it's the initial context of doing this work, and then we're working out, okay, what is the sale which had the min amount to it, and then I can go here and go max sales. And I'm going to use another one like that goes like this, using max, and then just referencing that. You see how quick I can do it? I'm just very quickly creating these formulas, and then that is the max sale that I have. So the total sales for this particular customer in this date range is that, the average sales is that, the min sale is that, and the max sale is that. And all of these results are all being generated by exactly the same formula, just the context in which that formula is calculating and the environment is changing. And that's how we're getting different results at every different row in this particular table here. Okay, so that's some very simple aggregation functions and very easy things to get started with. Okay, you don't need to do any. I say this all the time. You always want to start simple with DEX. Okay, start with really simple calculations, and then once you do that, you can branch out into more complex ones, which you'll see very soon. Okay, so that's enough for that. Let's move on to some other examples of aggregating functions. so let's just go over some more aggregating functions here. One thing I just realized earlier is that my total quantity measure where I use count rows, it should have actually been total transactions instead of total quantity. Total quantity would be this. So if I actually go, I want to work out total quantity sold, right? Total quantity sold, I would just go sum of the quantity column, right? Of the order quantity column, which is a number, and then I would just push enter, and then I would drag that in like that, and that's giving me the total quantity sold. Now, say for example, I want to calculate up how many transactions we had. Well, there's a couple of ways you can do that. One is you can actually use a function just count, right? So you could say total count of transactions. I can just go count, and I could actually use a number of different rows here. I could say counts the numbers in a column. Well, I could actually use the order quantity column. I could use the revenue column. I could use any numeric column basically would work. So I could go count like that, order quantity, and this is giving me how many transactions I've actually made. Okay. I could also do this. I could also figure it out another way. I could say total count alternative, where I could say count A. So instead of counting up the values, I'm actually counting up, say, some text value. Well, I could actually utilize like a reference number. So the order number is like the reference code for every transaction. I could just use count A for that, and it should in theory give me the same results, which it does. Another way that you can do it as well is using count rows, which is one that I quite like using a lot. Where it's basically, this to me makes a little bit more sense, where you can actually count the rows that are left over after all the initial context is put in place. And so I'll just drag this one in, and you'll see again that it's exactly the same result here as well. Okay. So these are some simple aggregations. There's others. Let's have another look. And there's another one called distinct count that I want to review. Okay. Now there's also count blank, which is as it explains, sort of counts how many blank rows there are. There isn't. I don't actually have. So I don't actually have any blanks in this particular data set, I don't believe. But count blank. So counts the number of blanks in a column. So look, it's pretty self-explanatory. If you did want to count up how many blanks, sometimes from just like an auditing perspective, this is a good idea. If I go and do this now, so how many blanks in the revenue column? I doubt it would actually return anything. I don't think it will. Total blanks, nothing. So there is no blanks in that particular data set. Okay, but hopefully also just see how many formulas we're creating here, all these really simple functions. They're creating quite a lot of insights for us very quickly. And the thing is that these are reusable. We could just change the context from customer to products to regions to dates, and all of these functions would still apply, right? And we would just have to understand the adjustment in the context we're making. I'm going to create another function here called using distinct count. So total, and what I'm going to do is I'm going to work out how many total products were bought. Okay, I want to work out how many products were bought by each individual customer. Okay, the way I can do that is I can use distinct count. Okay, and then I can go product index like this, sales product index. And check out what happens here. It's just my measures landed down here, so I'm just going to move it. I'm going to come into my measure tools, and I'm going to move this to my key measures table. You'll also notice how I'm formatting all of my measures. As I say, naming conventions are key, all in the proper format. Now, if I drag this into this particular table now, check out the results I'm getting. So what is happening here, and this is where, again, context is very, very important. What is the initial context of this calculation? The initial context is coming from dates here, but we also have some context from the customer name. Okay, the customer name is filtering at every single row of that table. It has a different context at every single row here. In the very first row, we have this particular customer, 21st Limited. If we visualize what's happening here, 21st Limited is flowing down this particular relationship. It's hitting the sales table. The sales table is being filtered for just that particular client. Okay. Then what's happening with this particular total products bought is we are trying to work out how many distinct product description indexes are left when all those filters are propagated down to the sales table, depending on what context we initially have in this table. Okay, and that's how we get different results for this total products bought. Okay, so those are just some more examples, some more aggregating examples that you can utilize inside of Power BI. You can hopefully see how quickly you can start creating these now, and how quickly you should create them if these are the types of insights that you want to see initially. These are some of the great things that you want to showcase. Next, we're going to go over and review iterating functions and just how you could quickly get these going in your models as well. Okay, now we've gone over some aggregating functions. Now we're going to go over some iterating functions. Okay, so what I'm going to do is I'm just going to copy and paste this table down here, and I'm just going to get rid of some of these columns inside of here, and we'll start from scratch again. Okay, so remember that the iterating calculation engine works in a slightly different way. We've already calculated up total costs, and we've gone through how that works, right? So I'm going to bring that in. Okay, what if I wanted to work out average cost per customer, right? How would I do that? Well, I can create another new measure here, and I'm going to go average costs. Okay, and then I'm going to go average x, and I find my average x function. I'm going to do something similar to what we had in total costs. I'm going to go sales, and then I'm going to go total quantity. Let's find the quantity. We can just probably type in quantity column. Yep, the quantity column tab times by the total unit cost, right? And then I push enter, and very quickly I have my average costs now, utilizing an iterating function. Okay, so first of all, the evaluation context happens first. That gives us for each different customer at each different row here that particular context, and then it's working its magic with the iterating engine after that. Okay, going through every single row in the table that we reference here, doing some logic, saving it into memory, and then doing an average of all of those results saved into memory. Okay, then let's just have a look at some of the other ones. So we can go, okay, what is the min cost, right? So min costs, I can quickly just go min x here. I can find the x, and then I can reference my sales table and do exactly the same thing. Go order quantity times by the total unit cost and push enter. Now the main difference here with these min costs, right, is that instead of, after I've gone through every single row here, it's basically just finding the min result that has been saved into memory. It's going to look through all of those results that have been saved into memory with all the logic that was done at every single row, that we iterated through every single row. Then it's only just going to go and find the min value and then return that. Okay. Then just to show you something quite cool is I'm just going to copy this formula, right? Then I'm going to go new measure, and I'm going to paste it in. Okay. And then all I'm going to do is I'm going to go max, and then change this to max. This is how you can quickly create formulas really, really quickly if you need to when they're of a similar pattern or similar logic. And then I can drag in my max cost, and now this is returning the sale which had the max cost associated to it. It's very likely that the max sale here also reflected the max cost here. So this was probably the very same sale, actually. Okay, it was actually the very, very same sale. Probably, likely. We can test it if we really wanted to. But in this particular case, I just wanted to show you some iterating functions, how you can create them very, very quickly. This is how it always starts, by the way. You always want to start, even with iterating functions, just start really, really simple, and then you can branch out, which is what we're going to cover next. You can branch out into more complex calculations very, very quickly. This is all going to come together really, really fast, right? Once you truly understand what's happening here with these fundamental things and these fundamental formulas, these what I would deem easier formulas, to understand when you combine them with understanding of the context, very quickly with this measure branching methodology, and then some more complex formula combinations that we're going to go to later, like time intelligence, you can start getting some really great and interesting analysis going inside of your Power BI reports. Okay, so let's finish off this one. This is just some simple stuff, and next I'm going to show you a bit more about this measure branching, which is a essential learning to utilize DAX as effectively as you can. Okay, let's move on. Okay, so now I want to cover this absolutely key methodology called measure branching. Okay. Now, the great thing about measures is that you can reference measures within measures. Okay, and I'm going to show you an example of what I mean by that. Okay, so I'm just going to come back to this particular table here, and I'm going to just reset it a little bit. Okay, so I've got in this particular table, I've got my total sales by customer. Okay, so by customer over this date range, obviously. Okay, what I can do though is I'm also going to reference my total cost measure against that. Right, so remember this is an iterating function, and it's calculating our total cost. Now, what I can do instead of having to write out these formulas again or do anything complex inside of calculated columns, what I can do is I can branch out. Okay, I can branch out from initial measures, and I'm going to do that to calculate my total profits. Okay, so I can go total sales. I can reference my measure, right? Total sales minus total costs. You see, the measures actually come up in the IntelliSense as well, and this is why IntelliSense is incredible here. Is my measures quickly can be referenced. I don't even have to type in the whole measure. I can just think of the name intuitively. And that's again naming conventions, so key. I can think of the name, start typing it in, locate it in IntelliSense, go tab, and then push tab, and then I have it in my formula bar here. So it just enables you to quickly create these things, okay? And then I'm just going to push enter. Oh, and I realize it's landed here again, so I'm just going to make sure I select my key measures group before I go and do any of this stuff. So I'm just going to move it to my key measures group, and now it's sitting inside of here, okay? So now I have my total profits inside of my key measures table, or my key measures group, and I can bring that in, okay? So that's just measure branching in essence. Okay, that's how simple it is. But the thing about measure branching is that you can go multiple measures, branches of measures. Okay, you can go to your fifth or sixth branch. Okay, so here's another example. Let's create another new measure here. Now let's go into the table again. So I'm just going to escape first. I'm going to click in here. Then I'm going to go new measure. Right. I'm going to call this one profit margin. How about that? Okay. Then I'm going to branch again. I'm going to go divide by total profits. Right. I'm going to go and find total profits divided by my total sales. Okay. Then I'm just going to go 0. Now, the reason why I use divide is because it is a far more effective way to write out division instead of using the operator. And so I really recommend just utilizing this format if this is the type of thing you need to do. And you'll see now that I'm branching out again. Initially, I branched first to total profits. Now I'm branching that measure again into my profit margins. Okay. And so hopefully this is really, really clearing up as well why you do not need to create calculated columns. You can do all of this stuff inside of measures. Okay. And then I can come down here and add in here. Now, if I just quickly change this to, let's change it to a percentage, right? And now you'll see that I have my profit margin for each individual customer. Okay. The other great thing about measure branching, right, is you don't actually have to reference any of those other measures within your table. You can still get the result, right? You can still get the result in a table or in a visual without any of those intermediary steps. The measures themselves will reach back into the initial measure you have created and remember it and then bring it through to this visual based on what you've referenced in that particular measure. So DAX is extremely intelligent in terms of remembering what calculations precede the one that you are calculating. And so you've got to think about all of these different layers, right? If I'll turn this into a visualization as well. You got to remember that, okay, so there's some initial context, right? Initial context on dates here. There's also some initial context on customers, but then also it's also reaching back doing this particular formula as well. First, it's doing the total sales measure by itself. It's then also within the same measure doing the total cost measure. So it's going and working through all of this particular logic inside this iterating function. It's bringing both those results back into this measure and then creating another calculation of total profits by subtracting costs from sales. And then it's then producing those results for all of the different customers. And I can do exactly the same thing. Say for instance, I wanted to work out the profit margins of my products. Well, I don't have to do anything different other than change the context of the calculation based on the measures. And I'm just going to change the context and then place the appropriate measures in the right locations, right? And so you'll see here that now very quickly I can see the profit margins of my product. And I can see that product 10 has the highest one of 41%. Then we go to product 14 at 40.73%, etc., etc. Okay. And so when you start combining these things very, very quickly, you can start extracting great insight fast, but seriously fast. But the thing to reiterate with measure branching is it all starts simple, really, really simple. It starts with those simple measures, and then you can branch out into these slightly more complex ones. And to be honest, we haven't even got started. Wait till you start getting into more advanced patterns of formula or time intelligence. We're going to be branching out into those as well, because not only do we want to maybe see our total profits, right? We might want to see our total profits cumulatively versus our profits cumulatively from last year. And so again, we're going to branch out once again from these initial calcs into those, and they can all be done within measures, and it all just flows in with this measure branching, or it comes under this measure branching methodology. Okay, so this methodology is very unique to myself and to Enterprise DNA. I sort of just created it, and it's just a way of thinking. It's a way of thinking about developing your Power BI models and finding good insight. Okay, and so I really want you to start utilizing it, to start thinking about things this way, because it will make your development so much more effective inside of Power BI. Okay, so let's finish off here. Let's wrap this up. Hopefully you've got that, and let's move into the next section. Now, the trick to getting advanced in Power BI or to finding out more unique things with DAX is one, measure branching, but then also how to combine functions together, okay? That's where things can really start becoming interesting, or the insights that you start generating become really high quality. And so what I'll do here is I thought, why don't we just go through a few examples of how you can combine functions? Basically, the rest of the course as we get more advanced is about, more of the sort of advanced examples we do later on are all about combining functions, but I thought I might give you just a bit of a heads up around what I mean by this, because this is how you can find those interesting insights that are really going to make a difference, right, in your reports, okay? So I'm just going to, what I'm going to do is I'm going to just calculate something quite unique here, okay? So what I want to do here is I want to calculate up my total sales, but only for customers, or only for sales that have margins above a certain level, okay? So above, say, 35, let's just say like above a 35% margin, I want to calculate up those sales, okay? So something quite unique, right? Something quite interesting. So I'm going to show you how we can do this. I know we probably haven't gone through all of these functions at all, but this is just to show you. I want to give you as much exposure to this as I possibly can, and then we'll fill in the blanks later on when we go over these specific functions, okay? So sales segment, okay? Let's call sales segment. I'm going to go down to new line by pushing shift and enter. I'm going to go calculate, because I want to calculate my total sales, calculate what it does. We'll go over this in more detail later, but it enables me to change the context of the calculation. I'm going to go calculate. I'm going to use a function called filter. And within that, I'm going to go and put my sales table, and then I'm going to go and have a look at where my product, I'm going to put in my product margin is greater than 0.35, so greater than that 30%. So you see here how I'm starting to combine functions together, and I'm branching out. I'm utilizing measure branching as well, okay? And so if I go into like this, and I drag this into my report here, you'll see that I have a much different sales. And you might think, well, how come I'm getting sales even though the profit margin here is 32%? Well, the key thing here is that this is iterating through, and that's what filter enables you to do in this particular instance. It enables you to iterate through every single row. So we're now looking at individual sales or transactions that have occurred for each of these different customers. So even though the average profit margin per se was 32%, there was sales that were made with a profit margin on the transaction was higher than 35%, and so I'm getting the sales for that particular those particular sales aggregated up utilizing calculate, okay? And so I could put this to 40 as well. I could do it that way, and I could get a similar result. Here's another way that's quite interesting. You could actually calculate this very same thing in a slightly different way. Okay, check this out. I'm going to go and calculate this again, and I'm going to show you how I can calculate in a slightly different way using iterating functions, okay? And again, combining things within iterating functions. Okay, so I'm going to go sales segment 2 here. Now, instead of using calculate, I'm going to use a function called SUMX, okay, the iterating function. Instead of a table inside here, what I'm going to do is I'm going to put, instead of a physical table, I'm going to put a virtual table, which we're going to cover in more detail in the next section. And then I'm going to go profit margins is greater than 0.4, and then within here I'm going to go total sales. Okay, so what this is going to do, think about what the iterating engine does, is it's going to take the initial context, so for each different customer, it's then going to have a look at all the transactions in the sales table, which are above 40%, and then it's going to work out what rows they were in the sales table. It's going to calculate the total sales in those particular rows, then those are going to all be saved into memory, and then sum is going to sum up all of those sales that are evaluated to above that 40%. Okay, so I'm just going to calculate exactly the same thing by a different combination of formula, and I've included measure branching in there as well. Okay, so this is where you can get to, and you can get to here very, very quickly. And all of these things, like everything we've discussed up to this point, it flows into this, okay? And everything post this point in the course flow, we'll fill in the things you probably don't understand just yet in these particular examples, okay? But the real power becomes when you start combining measure branching and combinations of formula, and then you can just find basically any insight you can dream of or dream up. You can find it with DAX. I'm almost 100% confident of that. There's basically been nothing I've decided to look for in Power BI that I haven't been able to work out with DAX. It does obviously, you can't, but it works though. So you have a good model. Okay, so it doesn't take away from the key pillars of developing good reports. You need all of the parts working together, but then when you do those set up well then DAX is sort of that final layer that allows you to produce that amazing analytical insight. And this is just the start. This is just the start of what we could do here. There's so many ways we can just change around the formulas and manipulate our formulas to achieve really good insights. Okay, let's move on to some more examples. Hopefully you've really got the hang of this. The key concepts here. I just want to focus in on some what I call error handling techniques here. So I'm just going to show you when you might need to use these in your own models. So I'm going to grab my date column here. I'm going to turn this into a table, and then just get the date. Okay, and then I'm going to bring in my total sales here. Okay, like this. What I'm going to do is I'm going to quickly create. I'm going to show you. I'm going to quickly create some time intelligence, just to show you what you might run into and how you can solve it with this. Okay, so I'm just going to call this one sales last year. I know I'm jumping around a little bit here, but some of these examples it's important just to get the setup right. And just don't worry, we will obviously fully go into some of this stuff later on. Everything is covered around DAX in this particular course. There should be nothing that is missing, in terms of fundamental understanding. So basically, I'm just doing a really quick and easy time intelligence calculation here, where I'm just going and looking at my sales last year. And so I'm just going to bring this in. And what I want to show you is, say I wanted to calculate up the difference. Say I wanted to calculate up the difference between these two, right? So year on year sales difference. Okay, I could go total sales minus sales last year. Okay, so I'll just quickly whip that up for us in here, and you'll see that when I bring this in, say I bring this in to here, you'll see that these results don't really make sense because there isn't actually sales last year, for example. And so if I turn this into a visualization, you'll see what I mean. Let's get rid of that. And say I got rid of this and this. So you see here that this here is the actual difference day to day, right? But then you see here that the difference is all positive year on year sales, because there is only sales in the current year versus sales in a prior year, right? Okay. And so what we need to do is we need to use some error handling here. This is what this is getting at. Okay. And so what we can do is we can use, say, blank or is blank or if error or is error within some formulas. Okay. So I can go if, say, sales last year. So if I could go, so sales last year is equal to blank, right? Then I want this to be blank. If not, I want total sales minus total sales last year. Okay, so if I go enter here, you'll see now that this is now blank for data for data points that are are meaningless, and then the data only starts. It only starts when there is actually results from the year before, right? So what does this date? It starts on the 14th of the 8th. Okay, that was the first day that we have data basically in our data set is the 14th of the 8th, 2019, and it's been dragged into this year, and that's how we get the difference. And you see, when you make things blank, they then don't appear in your visualization. Okay, you could also write this slightly differently using another error formula, and you could go is blank. So I actually quite like writing it this way. I go is blank. If that result is blank, then equal to blank. Otherwise, equal to total sales minus sales last year. Okay. And then say, for instance, you have errors, you can also use a function called if error. I don't have any in this particular case, but you could also use if error. That's another another way that you could use it. And as always, the information around functions is really good inside of Power BI. So you always know what you're using. It gives you, I really like this. There are some errors that Power BI throws up which are just hopeless, but in terms of the information around functions, they actually do a really good job, and it makes complete sense. Checks whether a value is blank and returns true or false. Well, this is where we need to return the true and false with an if statement. With an if function, and then it enables us to put a true value in and a false value in. And maybe you want to format things a little bit here as well. This is something that I might do too, just for some simple formatting of an if function, so it's easy to read. And then obviously, as I shown earlier, we can also write comments and say checking to see if here is last year results. Something like that. So that's the way that you can start developing these functions. And remember that we're measure branching here. We're only referencing measures within this particular measure, if you think about it. Okay. So we did rush through some time intelligence here. Don't worry, we'll come back to it. But this is just to show you some ways that you can handle these simple errors when they make sense. Okay. And how you can put them in a format like an if statement formula to work with them. Okay. Right, okay, let's move on, and I'm going to show you this really cool function called switch next. Okay, so now we're just going to go through a couple of examples, and I'm going to show you if function, again, it's a variation, and the switch function. And the switch function is a great function which is unique to Power BI, and basically it enables you to it's a much more effective way to create nested if functions. Okay, so first of all, I'm going to show you just a really interesting technique using if, and then we'll use switch, and I'll show you when you can use switch instead. Okay, so what I thought I would do here is, you see here we've got year-on-year sales difference, but you'll see here that it's the same color, positive and negative. Okay, so I'm going to show you what you could very quickly do if you wanted to create a visualization which showcased an insight slightly better. Okay, so what I could do here is I could say I'm going to create a new measure, and I'm going to call this positive year-on-year difference. Sales. Okay, and I'm going to go if my year-on-year sales difference is less than 0, then I want to see the year. Actually greater than or equal to 0. I want to see the year-on-year sales difference. If not, I want to see blank. Okay, then I'm going to copy this before I push enter. Right, so I've got that, and I'm going to create another measure. I'm just going to paste it in. Oh, it didn't copy for me, so let's just go negative year-on-year sales, and then I'm going to go if the year-on-year sales difference is less than 0, then equal to the year-on-year sales difference, if not equal blank. Okay, so hopefully you know where I'm going with this, but let's have a look at what this looks like in our table first of all. Okay, so you'll see now that I've only got the positive ones there, and then I've got the negative ones in a measure. And think about the branching we're doing here, right? This is the sort of the fifth or sixth branch, remember? Because year-on-year sales difference flows down into this particular formula. Then sales last year is derived from our sales formula. And this is our sales formula. So we're on a maybe fourth or fifth branch, and hopefully you can see how this can start coming together within measures quite effectively. Okay, and then let's check this out. So what we can do now is, now we've got these into separate measures and we're branched out. What we can do is we can then say change this around, and we can put our negative and positive sales inside of here, like that. And then everything, we have our title, we have our legend, and then what we could do is then, for example, we could select this particular visualization, come down here and change the negative into more sort of a red color, right? And oh no, that's the positive. I'm sorry. So we want this to be probably like a more positive color, and we've got a red color for the negative. Okay, and so that's how we can create a bit more insight into our visualizations by utilizing the if statement effectively, right? Okay. Now, what if though we had a scenario where we wanted to we had multiple sort of if layers of if that we might want it to do, we might want it within one formula, right? And so what I'm thinking here is, say for instance, I might want to create a table that sort of says, well, if the year-on-year sales was positive, I actually want a text value saying positive. If it's negative, I want it to be negative. Okay, and so in theory, if you were using if statements, you would do nested if statements in that particular example. So what I'm going to do here is year-on-year info. Okay, I'm going to use a function called switch, which is just a far superior way to write these nested if statements. Okay, and it's sort of like a pattern. So switch true is how you want to do it, and then down here I'm going to say, okay, well, if the year-on-year sales is less than or equal to 0, then I want a text value that says negative. Okay, we'll just put negative values, something like that. Then I'm going to come down to the new line. If the year-on-year sales difference is greater than 0, then I want this to be positive value. Okay. And so you see here that we could layer many of these on top of each other. You could even branch out even further. You could say, okay, here was an average day, here was a really poor day, here was a good day, here was an exceptional day, and you could layer these all on with different values. And then what we're going to do is just round it off with a blank down the bottom, just in case there is no values. So anything above, say here, we want it to be blank. We want to make sure it's blank, and then I push enter. And then if I drag this in here, we should now have a text value which is sort of adding value to our results. Well, it's actually, so you see here that it's not actually doing exactly what we need. Probably what we need to do here is, see, it's actually probably working out that these are all less than. So that blank isn't doing what it should. So what we could potentially do here is we could do this. We could say if is blank, very similar to what we did before. We could say if sales last year is blank, then we want to equal to blank, right? And then if not, we want to equal the switch function. So you see here, I'm just going to do some simple formatting. like so. This I think makes it look all right. So actually combine things, and then we can hopefully that should improve it. Okay, and now we have positive value like that. Okay, so this is just one example. There's so many different ways that you can take this, the great thing about this as well, just as another example, is you can embed these into your iterating functions as well. So why don't we do an example of that? So say for instance, okay. Say for instance, we have our total costs, right? We have our total costs. What I want to do is I want to, within here, I only want to look at my total costs where the order quantity was greater than 3, okay? So check this out. I can do this. This is where you can start getting really fancy within iterating functions. Total costs, high quantity, right? So this is a bit of a random example, but it's a good one. Okay, so I'm going to go sum x, and I'm going to go, I want to iterate through my sales table, and then I want to say, and then I only want to calculate up. So I want to go if total quantity, if my quantity column, my order quantity column is less than or equal to 3, right? If it's less than or equal to 3, then I want this to equal to 0. If not, I want it to equal the order quantity column. So I'm just putting some logic inside there, and then I want to times that by the total unit price, total unit cost, sorry. So you can see this is going to work. This logic is going to work at every single row within this particular function. So if I just enter that, and then I'm going to bring this into my table here. And so you'll see here that this is showing my total costs, but it's only showing my costs for those high quantity sales that we made. So if I compare it to my costs here, let's have a look at just like what our total costs are. That's actually equal to the same result. So that's not what we want. Let's have a look. I know what I think we want to do. Instead of if sales order quantity less than 3 equal to 0, if not, we want to go order quantity times total unit cost. I think that's going to give us the result we want instead. Actually, you know what? Let's just have a quick look. I have a feeling that the order quantities are all high. So that's why I was waiting. So for example, let's just change this around. So if I say put this to 10, right? Say the order quantity was less than 10 equal to 0, and then now you'll see, okay, well these are the costs now of those orders, those orders which had a high quantity associated to them. Okay, so this is a slightly longer video, but I'm just showing you the nuances of using these particular formulas and how you can use them and how you can utilize if logic, switch logic, and then where you can use it as well. Iterating functions enable you to do this advanced logic or implement logic within a measure at every single row to work out specific calculations that you need. Okay, and so hopefully just by working through this example, you can see how or a few of these examples you can see how it all works. Okay, let's move on. Hopefully you've got the hang of these two logical functions. Okay, quick review here because we have gone through the divide function before when we calculated our margins. Okay, so I'm just going to clean things up here. I just want to show you another example of how you could use the divide function, okay, and why it's better to actually use it. If you're doing some sort of division, I just highly recommend doing it this way because it prevents any errors from occurring, basically. Okay, and so you see here we've got sales. What do we want to work out? Well, what is the change, right? What's the percentage change from one year to the next? Okay, so what I'm going to do is I'm going to go new measure here, and I'm going to say year on year percentage difference. Okay. And we've got all the makings of what we need. I'm just going to go divide, and then I'm going to go by the year on year. We've already calculated the sales difference, right? So I'm going to go sales difference divided by the denominator, which would be sales last year, right? So this is going to show us the sales growth. We could also actually call the sales growth. Maybe that's a better way to describe it. I actually like that as a way of describing this particular result. Sales growth, right? You can have positive or negative growth. And then if I drag this in, remember this is a percentage, so we want to change this to a percentage, right? And so now, as if we come down here, you'll see that this is showing the difference between one year to the next. Okay. And you'll see positive and negatives. And you could branch out even more from this if you think about it. You could then say, okay, well, I want to show this in a visualization like this, for example, and I want to show the positives and negatives, exactly like how we've done here with the two measures, signifying and with different colors. You can do exactly the same thing with these as well. It's just again from branching out into something more complex. I'm really hoping you're starting to see with all these examples, even these simple examples, how intuitive and simple DEX can actually be. It doesn't actually have to be that complex because if you just harness this methodology around measure branching, right? None of this is very difficult. Sales growth. Well, if you're just looking at your raw tables and you're trying to think, oh man, how am I going to calculate sales growth from this? It's not hard. It's not hard if you just start simple and then just slowly branch out to it, because this isn't hard, right? I'm dividing my year-on-year sales difference from my sales last year. Well, my year-on-year sales difference is literally just this, total sales minus sales last year. Well, my sales formula is crazily, just ridiculously simple. It's just summing the total revenue. So all you really needed to know from a DEX perspective here is a little bit of time intelligence, and this is the easiest time intelligence function you could ever imagine. It's just adding, the data add function, which is a very versatile and effective function, with the calculate statement. So once we get into those sections and you really truly understand calculated time intelligence, well then getting up to this sort of analysis is not hard. It is seriously easy. It's just about following this methodology, and that's what simplifies it. Okay, so look, a bit of a I've gone off and discussed a few other things other than divide, but divide is simple. You don't need to spend too much more time on it. It's just a better way to do division. So I highly recommend using this function. Okay, let's round things off with the next video and just go over a few other function types that you can use in Power BI. Okay, just a quick review here. What I've done is I've jumped back into the DEX formula reference guide just to show you a few things here. Okay, I'm not going to dive into recreating all of these things inside of Power BI because it's just not necessary. I know a lot of you have got some sort of Excel ability, and a lot of these things, they're exactly the same as Excel. That's why it's so great. The move over to learning DEX sometimes can, it doesn't have to be that significant because a lot of these functions do a lot of the same work as they did in Excel. Okay, so the first one I wanted to drill into was information functions. There's also text functions, conversion functions, date and time functions, Boolean functions. So what you can do is you can very easily and quickly navigate yourself around in this reference guide if you need these. You very rarely do, honestly. And if you do, this is just the perfect reference guide for that. So I can just say click on one of these, and this is error checks whether a value is an error and returns a true or false. Okay, is number checks whether a value is a number and returns a true or false. So these are enabling, allowing us to find information on our data that we might be working with, right? Okay, and then we also have let's have a look at some other ones. So we have some text functions as well. So a lot of these, pretty simple, blank find. So again, these are things, we sort of covered them already, but also finders you can use that in Excel as well. We have what else we got that would be worthwhile. Logical functions like if error, switch, true. So we've touched on all those already actually. We have some simple date and time ones which aren't sort of classified as time intelligence. Where are those ones? Those ones are probably within the date and time functions one here. So things like today, so you see here time value, date function. So if I click on that, this just shows you what date it is. Again, it's very similar to Excel, so I don't really need to dive into this with any detail. You see here it's a very short and easy explanation. So nothing too difficult, right? So look, there's really not a huge amount I need to cover here. In terms of these particular functions, it's sort of just like I'm sort of just giving you an outline of what to expect really. There's other functions hidden within here, like the row function. What else have we got? A lot of these functions are slightly different, and we'll be covering them shortly. But nothing too. These are more simple ones that you can easily get your mind around and don't really have to worry about. So yeah, look, that's really about it. I think I have really focused in on some of the main functions here. There's probably not a list of every single function there is in DAX. So look, if you need these, you'll find them. Okay, you'll find them online, just Google, and you'll find them. Don't need to reinvent the wheel anywhere. Reinvent the wheel. In many respects, it's just a matter of figuring out what you need and then going and working it out, going and finding it and implementing it in the correct location inside your reports. But definitely as a bit of a review of this, of this section, this is a good place to reference over. As long as you're working in Power BI, really, this enables. Or facilitates a lot of learning and revision around specific functions. But as I say, there's also good stuff online. You can just Google it, and you'll find what you need there. Okay, so we've really covered now up to this point all of the beginner stuff with DAX. Now from here on out, for the rest of the course, we're really starting to get into some slightly more advanced things around, especially around table functions, the calculate function, and a whole variety of functions that you can use in combination with each other. Okay, and so. Having a really good sound fundamental understanding of what we've gone through so far is without doubt just essential. You can't get away from that. But here is when we're going to start introducing some other aspects to your formula capabilities, which are going to enable really outstanding analysis, okay, and insight generation within Power BI. Cool. Okay, so let's round off this section and move into the next one. We'll be diving into what are called table functions. Okay, so now in this section we're going to dive into table functions, and there's a few key table functions that you need to understand. But before I just go through them quickly, and we'll be covering them throughout this section, is that the way to think about tables or table functions is they generate virtual tables within your formula. Okay, that's the way to think of it. As I've definitely found over time, as I've really tried to master all the different aspects of Power BI, thinking about these virtually is how you can effectively visualize what's going on. Okay, so these functions that we could call within a measure is things like filter. We've got the all family, which is like all selected, all except. We have a function called values, a function called distinct, and also a function called use relationship that we might go into. Okay, so these are the key ones. There are some others, and we'll be covering those later on. But these are the key ones that I want you to get your mind across early on, as they're what you'll generally use most when you're just starting out. Okay, but the key is to just think that these are going to generate virtual tables inside of our measures. Okay. When and where to use table functions. Table functions can be used in any function where you can place a filter or table. So in other words, in any measure where you can place a filter or a table. So if it's asking for a filter or if it's asking for a table, this is exactly where you're going to put these functions. Table functions allow you to dictate what the underlying table looks like before a calculation takes place. So this all flows in together with what we've covered so far. Initially, you might have some context, some evaluation context. Then the table function can dictate what that table looks like even after that context has been put in place. Okay, so you might have some evaluation context, and then a table function within your measure might change the shape of that table again. It might add to it, it might subtract from it. Okay, and then it just depends how you combine these table functions with other functions. Okay, the only way to really understand this is through many examples and testing results as you try new inputs into formulas. Okay, so table functions are somewhat more difficult to learn inside of Power BI because you can't even see these virtual tables when you're generating them within a measure. There's no way to actually look inside your measure and see what virtual table has been created by what you reference. You just have to intuitively know, and that is why these functions are where it can slightly get a bit trickier inside of DAX. But look, it's essential. You have to learn it. There's no way around it. You have to understand how these work in collaboration with other functions that you might be calling inside of a measure, but also in a specific context in which you are using it. Once you know all this stuff, though, that's when you can really get into some exciting insights and analysis with your Power BI reports. Okay, so that's just a bit of an intro, and from here we're going to dive into all of these specific functions and learn a bit more about them. Okay. Okay, let's dive into the filter function first, okay? And as we do this, I am going to show you a little bit of a trick around how you can try and understand what table functions are doing, even though you can't see it within a measure. There's a little bit of a trick in terms of utilizing Power BI to actually work these things out. Okay, so what I'm going to do, I'm just going to clean this up a little bit. And I'm going to get us back to just the data and total sales. Okay, what you can do inside of Power BI is you can actually create what are called what's called a new table via DAX. So check this out. Check what it says. Write a DAX expression to create a new table. Okay, so you generally want to be in this view first. Okay, and then we want to go new table. Okay, so I'm going to go new table. what this actually enables me to do, even though I told you just before in the last video that you can't visualize what tables are doing within your measures, what you can do though is you can break out your table functions into a table and try and see what that table function might be doing within Power BI. Okay? You just can't do it in the measure, but you can do it by itself in the Power BI software. Okay. So for example, say I wanted to test something. I wanted to test what filter can do for me, right? Okay. So what I'm going to do here is I'm going to say, okay, and this is where you can only use table functions here. You couldn't just use a simple sum or a sum x. You need to use either filter or values or all things of this nature. This is what you can use in here. So we're going to use filter. So what I'm going to do is I'm going to filter my sales table by and we have used filter before, I know, so some of you will be aware of how we can use it because I've utilized it in a few examples so far, but I'm just showing you some other tips here, some other techniques around nuances to filter. So I'm going to filter through the sales table. Another thing with filter is it's a table function, but it actually iterates through every single row in the table which you specify here, right? So I'm iterating through every single sale from the sales table, and I want to only have the sales with an order quantity greater than, say, 12, okay? So if I go and go enter here, it's going to give me none because it doesn't look like we made any sales over 12, so what if I go 10? Okay, so the original table that we had was about 8,000 rows. So this table now is only 1,980. So this is a very similar, the table is exactly the same, right? The table is exactly the same as it was before, but it's a far more reduced table because we're only looking at those where the order quantity is greater than 10, right? We could also make this even smaller by going greater than 11. So this is what filter is essentially doing. This is what it's going to be doing virtually within our measures. Okay, this is just enabling us to see it. Okay, this is just enabling us to visually see it in a table. I'm going to delete this table soon because we don't need it. But this is just me showcasing a way that you can attempt. You can't. This isn't possible with all the things we're going to do, but this is sort of just to give you an idea of what you're actually doing in the background. Okay. We could also take this further, right? We could say, okay, we want this greater than 11 and where the channel is equal to, what are the ones we've got here? Are they all wholesale? So the channel is equal to export, okay? So I'm just adding another layer there, and you'll see that this table will be even smaller now because now we've just filtered also by export there. Okay, so this is the idea. This is what we're going to be doing with table functions. As I say, we don't actually need this because what I'm going to do is I'm going to go and calculate the exact same result in a measure. You'll see that this table has appeared here. You'll see that this filter example is over here now. I don't need this though. I'm just going to delete it. This will just be testing it out, right? Okay, so let's delete it now. Okay, so if I wanted to calculate that here though, I'm just going to go and create a new measure first of all, and then I'm going to go high export sales. Okay, I really want to drill into my high export sales. What I'm going to do is I'm going to use a function called calculate first, which enables me to change the context of the calculation. I'll be reiterating this even more later on, but it enables me to change the context of the calculation. I'm then going to reference filter inside of here, right? I'm going to go filter sales, okay? Then within filter, I'm going to do exactly what I just did in that physical table, utilizing DAX. I'm going to go is greater than 10, and the channel is equal to export. Okay. So I'm going to push enter, and then if I bring this measure into my table now, you'll see that I'm now only looking at the export sales which are of a high quantity. Okay, and now I have that in my table, and I've generated that by placing this additional filter over my data. Okay. You might also think that it's okay, and this is honestly okay. This is honestly okay. You probably don't even need filter here. Like you could just actually have comma sales order quantity greater than 10, and then channel is equal to export. You could do that as well. But you can actually use these in slightly different ways as well. So filter is just far more versatile. That's why I personally always use filter. I never don't use any sort of like filter function within Calculate. Just as a best practice, I always use filter because there's a lot more versatility that you can have by doing that, and you'll certainly learn that more and more as you work through a number of these examples. So I would just do that. So I'm just going to paste that in here, and I'm going to say I'm going to go high revenue sales, okay? So what I'm going to do here instead of all of this, I'm going to say I only want to have a look at the sales where the total sales of any particular sale, because I can always also reference measures in here, was greater than 20,000, okay? So I want to calculate, so what this is doing is I want to calculate the total sales of all of the sales which had a sale greater than 20,000, okay? So a filter enables me to generate this virtual table now, which just like we saw before, this virtual table of only looking at the sales which had greater than 20,000. And I can test this again by coming into here, then going new table. Let's go new table in here. Filter test, right, and I can just copy this in here if I want to see exactly what's actually going on within that particular measure. Well, then this is coming over here, and it's now looking at this theoretically is looking at this particular column here, and everything over 20,000 is remaining. So out of the 8,000 particular transactions, we've got 2,995. I can see that down the bottom, which are over that $20,000 threshold. Okay, and so that's what that particular function or table function is doing with filter. So hopefully you're getting the idea here about what filter does. It generates this additional filter, as the name suggests, but really in behind the scenes, what it's doing is it's creating a virtual table. It's creating a virtual table of the all of the all of the sales table, okay? And then once, and then this is, remember this is after all of the initial context is in place, okay? So the initial context, just like every other situation, is applied. So we're for this particular result, we're only looking at the 11th of 6, 2020. This is demo data, right? And we're saying, okay, on that day, after all those filters are put in place in our model, we then want to go and we want to create basically another filter, or only look at a subset of that a virtual table of that subset, which is left over on that particular day, and we're going to create that additional filter in our measure by only looking at the sales which are above 20,000. And if they evaluate to true, then we're going to calculate out the total sales for those results. Okay. So a bit of a deep dive here. There's even more great things that you can do here, and I might show, and I'll definitely go through a few of those as we expand on how you can combine filter with values and filter with all selected, because you've got to then start learning how to combine all of these different things. Okay, so this is just the start. This is how we can initially manipulate our virtual table, but we can take things even further later on, and that's quite exciting. Okay, so let's move on, and we'll dive into the values function. Okay, so now we're going to jump into the values function. Now, this can sometimes take a little while to get your mind around, okay? But it is a crucial function. I'm going to utilize a technique here to showcase values too, which I think will make it a lot clearer. And we'll run through a few examples, okay? The first thing that I want you to do, if you're not familiar with the values function, is to utilize the new table feature here that I showcased to you in the last video, okay? Really utilize this early on when you're trying to understand and visualize what these functions are doing. It's quite important, because you do need to visualize these things. Trust me. You might think, well, I can just intuitively know how this works, but no, you do require. I mean, even to this day, when I'm trying to work out something, I'm literally visualizing what is that function doing in this particular context to give me this result. This is what I'm doing, okay? And so this is just a really good way to start. So I'm going to go new table here, and I'm going to go values example, okay? I'm going to show you what values does in the background. Because you've got to remember, this is going to happen virtually within a measure, and you're not going to be able to see what it is actually doing. And so this is where that visualization piece is really important. Okay, values essentially gives you a one-column list, unique list, a one-column unique list from something that you reference, like a table or a column. Generally, it's going to be a column. Okay, and again, the information box is very good here. It returns a one-column table or a table that contains the distinct, unique values in a column. Okay, so what does this mean? What does this mean? Okay, so what we might want to do, right, is in our sales table, we sell through to a number of different warehouses, right? Or we sell to a number of different, through a number of different channels. Well, say we wanted to just see a one column list of unique values for that particular column. This is how we could do it, okay? So what I'm going to do is I'm going to say, okay, I'm going to type in the warehouse code column here. I just started typing in warehouse and then went tab, and then I'm going to push enter, okay? And from quite a significant table, remember the sales table has about 8,000 rows in it, I've now got a table, a physical table at the moment, of every different warehouse code, unique warehouse code. Okay, say in one warehouse code, say I wanted to look at channel. I could do that by utilizing the same technique, right? I could also do a similar thing for, say, unit price, if this was something I wanted to do. So what this is going to do is going to give me a unique list of all of the different prices in which we sell products. I know that there's no information next to the price, but this is just to show you what values is actually doing, okay? Now, in it by itself, this particular function doesn't do too much, but in combination with other functions, it can achieve a lot, okay? It can really achieve some quite unique calculations very, very easily. Another good one is say we wanted just a list of months, right? Or just a list of months and years. So what I could do is I could come to my date table and I could say, okay, give me a unique list of month and years, okay? Because you've got to remember, in the actual date table itself, month and year is referenced many, many times because we have a granularity of date here. But say, for example, we wanted a table, and this is all going to happen virtually eventually, we wanted a table which was just for unique values for the month and year. Well, values enables us to do that very, very quick and easy, okay? Right, now, so that's the visual part of understanding what's going on, okay? And then how do we actually use it? How can we actually use it in our model? Okay, so here's a scenario for you. Say I wanted to, on each of these days that we have sales, right? Every day we have sales. I want to work out, well, what is the average amount of sales that goes out of each of our warehouses? Okay, so we have our initial evaluation context, right, for dates, and we have this slicer here as well. But I want to basically work out, okay, what's the average though through our warehouses? So all of our warehouses are selling things, right? And I want to know, okay, what's the average? So how do I do that? I can utilize this values function within an iterating function to do it. Okay, so let's walk through it. I'm going to go new measure here, and I'm going to go average warehouse sales. Okay, so basically going to give us the average warehouse sales per day, if you think about it, because this is at a daily, our table here is a daily granularity. I'm going to go and use average x, an iterating function. And I'm going to show you, this is some really cool stuff that you can do with iterating functions, right? You may think, based on what we've done so far, that you have to actually reference a physical table here. But now with these virtual tables, you can actually reference table functions in this table here. This table here doesn't mean it just can only be a physical table. It can also be a virtual table via a table function. Okay, so I'm going to go and create a one-column list of unique values of my warehouses. Okay, then I'm going to and this is for every single day. So you're going to think, okay, what's the initial context, right? I'm going to drag this in. I'm going to drag this in so we can have a look. Okay, what is the initial context? The initial context is 17th of February 2020. Okay, then within that particular context, I'm going to iterate through a table. Now that table is not the sales table. It's a one-column table of each unique warehouse code, right? So there's only 4 warehouses. So on most days, we're going to see 4 warehouses. So we're going to iterate through 4 different warehouse codes, work out the sales, save those sales into memory. Then at the end of all of that calculation on every single day, we're going to average it up, okay? And so that's how on the specific day we get 53,000 is the average warehouse sales, right? We could also do this. We could go instead of average, what we could do is we could come here, create a new measure, and we could go min warehouse sales, right? And instead of this, we could just change this to min. So you see how iterating functions are starting to come into play in a lot more interesting ways when we start adding table functions to them, right? So on that same day, where the average was 53, the warehouse with the lowest sales on that particular day had 25,000 in sales, right? And then you've got to remember as well that we don't have to use total sales here. And this is where you can just start getting really, really fancy, really, really quickly, right? We could start branching out into lots of different variations here. And so instead of min warehouse sales, what I could do is I could say min profit margins, min warehouse profit margins, right? And I'm just playing around with things that I've already calculated, right? And I'm just layering on all these different techniques. So I'm going through here. So what I'm going to do here is, let's have a look. See how many measures we're generating. I mean, not all of these. A lot of these are examples, right? But interesting nonetheless. So what we're doing is, let's just change this to a %. So let's have a look at what we're doing here. Okay, so on any specific day, so we've got, let's go back to the same day, 17th of February 2020, and the min. So total sales was 214,000. We had our average warehouse sales was 53,000. The min warehouse sales was 25,000. The min warehouse profit margins. So the warehouse with the lowest profit margins on that day, the margins were 27.25%. Okay. And how we work it out? Well, very similar to how iterating functions work out anything. We just manipulated a table into a one-column table of unique values of warehouse code. We've worked out the profit margins of each of those warehouses on each different day, and then we've just gone and calculated what the min was. Okay. And so this in essence is a way that you can use this in many, you can use this in many different ways. I want to show you before we run off one more way that you can use it, and I'm going to go and create a different table with a totally different context, right? Okay. So I'm going to, and this is where context really comes into play a lot, very quickly, having a good understanding. You'll see, hopefully, seeing now why I spend so much time going through context because of how crucial it is now becoming. Okay. we should probably clean up this measure group pretty soon as well because it's getting a little bit messy. Okay. So what I want to do now is I want to work out my average monthly sales. Okay. Right, per customer. Okay, so how am I going to do this? I'm going to use exactly the same techniques, average X, right? But think about what table we can put inside of here. If we want to calculate up the average monthly sales, well, what I'm going to do is I'm going to bring in my month and year column here, okay? I'm going to go values month and year. Remember, I can't just put the dates column in here. That's not going to work. It might work if I was going for average daily sales because that's the granularity of the date table, but I want to look at average monthly sales, okay? And then I'm going to go and put my total sales function in here. Okay, so then when I drag this in here, you'll see, I'll compare it to total sales as well. So now, instead of looking at all my sales, I'm actually looking at the average monthly sales. Now, the important thing to note as well, though, is that we have this particular context as well. So this month and year here, for this particular result, this is only looking at the dates in which we have selected or which are in our evaluation context of our report page, because that date filter is already in place. And then so this particular date, month and year, is only looking at through those specific dates. It's not going any further out. It's not going any days back into the future based on what we have selected here. Okay. So those are a few examples. That's going to get you started, okay? I've shown you the trick to really understand what values are doing because I know initially it can be quite confusing. And through these examples, I'm hoping you can see, okay, this is how you would use values. Now, the key for you is maybe to apply it to some question you might have or some scenario you're dealing with, and then just seeing how you might be able to, use it as well, okay? So let's move on. We're going to now just compare values to a couple of other functions and how you can use it in combination with a few other functions. Okay, so now we're going to look at another table function called distinct, which is actually very similar to the values function. There's just one slight difference, and I might not be able to show it exactly in this example, but I'm going to tell it to you anyway, and hopefully you can just practice it yourself and see how it might apply in your own models. Okay, but basically distinct and values do very similar things, and the way we're going to test that is we're going to come across to once again creating a table function. Okay. Inside of a physical table. Okay, so values, dates, month, and year. Let's shorten this up a little bit. Let's just have a look at the channels, right? Okay, so let's go values channel. So it gives me a 3 row list, right? Distinct will do exactly the same. Okay, it will do exactly the same and return to me exactly the same results. It will do exactly the same if I say put anything in here. I'll do warehouse code like this. The only difference between these two particular functions is if there are blank values, or if there is a relationship mismatch, right? So what I mean by blank values is that a blank value would be picked up if you use the values function, right? So if you use the values function and there was one row that didn't have the correct warehouse code in there, it was just a blank value, that blank would actually appear in this particular table. But if you use distinct in the same example, if you use distinct, it wouldn't appear, okay? It wouldn't show. It would only show you the values that actually had values in it, okay? And this can change up your results just a little bit. I did also mention about where you have a relationship mismatch just before. And what that means is that, say, for example, you have some results in your fact table, and say some new customers came in, right, and they were showcasing sales in your fact table, but they weren't actually in the customer's table, right? The actual customer hadn't actually made it to your customer database, for example, right? What would happen then is that with the values function, if you were looking over your customers, the values function would work out how many sales were made to those customers that were blank, whilst the distinct would only iterate over customers who actually existed in your table at that point in time. Okay, so that's just a key learning or a key understanding between values and distinct. Okay, and personally, it is so essential to get your data sorted out correctly, right? I always use values. So I spend a lot of time getting my data and my models just so correct that I don't have to really worry about using the values or distinct. And that's why I normally use values. I'm just more used to using values. And the other thing is that values will always highlight the error if there is an error, whilst if you're using distinct, right, it won't actually highlight it, so you will never know that there's a problem. So in my particular opinion, I use values for those particular reasons, and I think that it is more logical when I start combining it with a lot of the other functions I use as well. What you will also find is that values is a far more used function across everyone who's using Power BI. So a lot of the examples that you see online, they'll generally be using values rather than distinct. So that's why it is really easier to use values in this case. Okay, so sorry I don't have a specific example for you, but hopefully that makes sense in terms of dealing with blank rows, because you will actually find this, or mismatches in your data between your two tables. You will find this occasionally, and then I guess my recommendation at the end of it all is using values is probably a better option. Okay, so just having it also sort of lessens the amount of times the amount of functions you need to learn as well. So values is just a more consistent option that I would use across all my different reports if I was requiring that sort of logic in my formulas. Okay, let's move on. Now I just want to quickly show you a different way that you could use values, okay? And how you historically would have used values quite a lot, but they've introduced a new function called selected value, which is a much better way to do this. But I just want to show you it just as a bit of a revision around what Power BI initially used to look like. So I'm just going to go values example, because what you can do with values as well is, if, say, for instance, your table of values only contained one row. So based on the context in which you place this table function, it only contained one row. Then you can actually place this in as using just values, which is basically not a possibility with table functions. You can use values as a measure, just values. Okay. So what I can do is I can go and write values. Say let's go, for example, I'm going to show you what's incorrect first of all, just to reiterate the point. So I'm going to go values sales channel here, right? Okay. So in theory, if you remember back to our example before, what values does is returns a column of unique values, right? So for every single customer here, depending on which channels they bought through, this would actually bring a list, right? It'd actually bring a list of values. So if I brought this into my table here, it's going to error out because measures don't allow you to return lists. They only allow you to return singular values, what is technically termed a scalar value. So the values within this particular table up here, each individual result equals a scalar value. This here is producing a list, so it's not going to work for us, okay? So what I can do though, I'm going to just take this out of the table, I'm going to delete it. What I can do though is, if for example, I could return a list of values at each different context there, which was only one row, like customers, like customer name, for example. So I wanted to just return in a measure the name of the customer, okay? I could go enter like that. I can drag this in. Initially, you might think, oh, no, this doesn't work as well. It does, but what is causing this error is actually the total. It's actually the total value, because in the total, again, you need a scalar value, but this values function is returning a list of all of the different customers in the total, even though at each different row in this particular table, it's going to just return the one customer. Okay, so what you need to do, what you used to need to do, is you need to go if has one value, utilize this function called has one value, it's going to return a true and false, some true and false logic. If the customer name column only has one value, then I want to return the actual name. If not, I want it to be blank, okay? Then I'm just going to go okay. And so you'll see now that this is actually returning a text value as a scalar value, and I'm returning it by utilizing the values function, okay? But there's a much better way to do this now. Again, it's with a function called selected value. Now, selected value just didn't exist initially. It's quite a recent function, but there's so many different better ways you can use it. So instead of using values, what I would do here now, selected value, this enables me to return or retrieve text values far easier. So I could go selected value example, then I'll just type in selected value, and just find it there, tab, and I'm going to type in customer name like that, and I can just go blank like that. As easy as that. That's all I need to do. I can go enter, and it's just fallen down into this one here, so I'm going to move this up here, and I'm going to drag it in. Okay, so it returns exactly the same thing. It is a much better way to do it, okay? So there are a couple of ways you can do it, and it's just a good learning of like another way that you can utilize values if, in some very unique cases now. But if you just wanted to return a text value, and that's all you needed to return, then selected value is a much better way to do that. Where this comes into play a little bit more is here. I'll show you what we might want to do is create a new parameter. So I'm going to create it, and I'm going to call this example parameter. I'll probably delete this straight after, but just to show you, I'm going to create a whole number with a minimum to a maximum with an increment of 1, add slicer to the page. So I'm just going to go OK. Right, and if we have a look down here, what it does is it first of all creates a table of my parameter, like so, okay? But then it also uses that selected value function as well, and so it can tell me what value is selected in another way. So this is just a number, but it's using selected value in a slightly different way, where, say for instance, I want to put it into a card like so, and I want to see visually in a much clearer way. I can utilize it like that. I could also utilize it in a measure here. Say I wanted to increase the sales here by 7%. Well, I could go total sales times 1.07, 1 plus this, whatever, this divided by 100. So that would be a way for you again to use selected value in a slightly different way. So obviously this is a much better way to use it rather than using the values there, but it can produce similar things. That's what I really wanted to showcase here. Okay, let's move on to the next example. Okay, now we're going to cover the all function, okay? And I'm just going to work through a few examples here because I think this is by far the best way to truly understand this function, okay? Just like we have with values and filter, I'll just showcase a few examples so you can get a much better idea of how it works. The first thing we're going to do is we'll jump over to our table feature here, right? And we'll write a table function, okay? So instead of values, I'm going to call this all example. Now, all the best way to think about all actually is that it's the remove filters function, okay? Now, if I use it in here though, it's quite interesting. It returns exactly the same result. The reason the reason why this is actually different to values though is that it removes filters of the current context of the calculation. And so this is where it can get a little bit confusing because there is no context here, remember, okay? Because it does return a list of values just like the values function does, but it removes all of the context that is being applied to the measure when we put this into a measure. So it will usually return all of the values instead of just the values which are being manipulated by the current context of that calculation. Okay, so that's why it's called the remove filters, because no matter what sort of context you have, you will always get a list of all of the values, not just the values which remain. Okay, and so I can, obviously I can change this to lots of different things. So I can actually change it to tables as well. It doesn't have to just be a column. I could say, okay, return everything from the customer's table, and we'll just return the customer's table just like that. You got to remember that this is all going to be happening virtually, right? This is just me showcasing what the all function will ultimately do when we put it in a measure, and it will do it all virtually. So this is the type of thing you've got to visualize when you're looking at this. So I can go customer. I could also go customer's name like that. So that will just return a run row list. I could also jump down to say the sales table, and I could say, okay, well, return me every product description index, every unique value, and iterate through that. Okay, so we could also do it that way as well. Okay, so let's jump into a few measures and look at different ways we could use all. Okay, a really good one to example here is, say I wanted to work out the percent of total, so the percent of a customer's sales to the total. Okay, so let's think logically what we need to do there. What we need to do is we need to essentially go this amount here divided by this, and we need to go this amount divided by this. That's what's going to give us the percent of the total for each individual customer. So what we have to do really in the formula is we need to somehow drag this result up into every single row here, right? We need to change the context of this particular result and place it here. Okay, so I'm going to show you how you can do that in a formula using all. Okay, so let's go to a new measure, and I'm going to call this one percent of total. Okay, I'm going to come to a new line with holding shift and enter, and then I'm going to go calculate again, because all usually it's not always, but a lot of times is used in combination with calculate. Then I'm going to go total sales, because calculate changes the context of the calculation, and go total sales, and then I'm going to go all customer name. Okay, I'm going to remove the context from customer name. I could also go to the customer's table here. It doesn't actually matter, but I'll go customer name in the system because I see that the customer names column is in the current context, and then I'm going to go okay. So remember that all is going to remove filters from whatever we place inside of here. It's going to remove the context, right? And so we can change the context inside of Calculate. That's what Calculate enables us to do, and we're going to remove, and we're going to use all, which is going to remove the context entirely. Okay, so if I drag this inside of here, check out now what values we have in every single row here. We have that total, okay? And then if we ultimately wanted to create the percent of total, well, then all we would need to do is this, is go total sales divided by that, and then just round it off with a zeros and alternative result. And then now you'll see that we have a percentage here, and if I actually change it to a percentage, you'll see that now it all equals and adds up to 100%. Okay, so that's a really easy example to just understand what remove filters actually means. It's basically removing context, right? So if you've really understood that concept of context now, you'll start to notice that we can start manipulating that context, usually with Calculate and these table functions that we're going through, okay? Now, I just want to show you just a couple of other examples or ways that you can just see how all works, because and test it as well, okay? Because a lot of the times you're starting out Power BI, these things won't just come to you straight off, right? You need to just do a little bit of testing, really understanding the context, seeing how all interacts with that context, and that's how you're going to become more familiar with how it's going to operate in a more complex formula, okay? So what I'll do is I'll just show you this, okay? I'll show you this little trick that I use quite a bit just to test things out. Okay, so what I'm going to do is I'm just going to type a random formula here called testing context, okay? A good thing to do to test things is use a function called count rows, okay? You see here that count rows actually asks you for a table. It says counts the number of rows in a table. Okay, so say you wanted to test what sort of virtual table you might have in here, you can place it inside this as this parameter. You don't need to use like you're not only restricted to say a physical table. What you can do is you can use these functions like what we're going through. You can use values, product description index, okay, something like that. So what this is going to show me here is this is going to count up how many products each customer has bought, right? Because I'm going to get a one column list of all of the products in the current context. Remember, values only returns a unique column of values, so it's going to just list all of the product descriptions indexes that each customer has bought, right? Okay, and then I'm going to go enter, and I'm going to drag this in. And so you see here that this now is showing that this customer bought 10 products and this customer bought 14 products in this particular time frame, because you remember this is the overarching context that we, or overarching filter that we have on our page, right? So if I change this, you'll see that these results will actually change as well, right? Now, the reason why I've referenced, and I went through this before as well, but the reason I referenced this particular table and index here is because you've got to remember that the customer name filter or context is coming from the customer's table, right? And it's filtering this table here. So if we wanted to do some sort of count up of how many products they bought and we reference this particular table here, it wouldn't reflect the correct amount because there's no way for this filter or that context to flow down here and then flow all the way back up here. It just doesn't happen. So you need to reference the filtered table to then get the correct result for how much they've actually bought. But say for instance you actually wanted to iterate through every single product instead of just the products that someone bought. Okay, well then you would just use all. That's what you would do. That's what you would use all for, because all would disregard any context that has been applied from whatever context is in. So in this particular case, we're going to disregard that this customer name filter has been put in place and flowed down to the sales table, because we're saying remove it, any filters that are now on that sales product description index. So if I just go and push enter now, you'll see that it is now returning all of the products for every single row, because we've just disregarded any filters that are in place. Okay, so hopefully now you're getting a fairly good idea of what all actually does. This is a crucial function and is used in many situations, many types of analysis, etc. So you've really got to truly understand this. And hopefully just by going through a few of these sort of tricks that I use to understand it and play around and test it, that you can start seeing how this might work in your own models. Okay, and hopefully also you just, we're covering a few things, in all these videos. It's not just about a specific topic. I'm just giving you a few insights into how the model interacts with these particular functions and things like that. And all that stuff is very important. So hopefully you are really getting you're taking all of that in and hopefully I'm enabling you to apply this in your own environments, in your own models as well, because that's the key. You've got to do it. You've got to ultimately do this on stuff you're familiar with, because it will make a lot more sense. Okay, let's move on. Let's compare some other functions in the all family. Okay, so now we're going to go over a function called all except. Okay, I'm just going to just tidy things up a little bit here. You've got to remember with anything from the all family, that all is about removing filters, but all except allows you to remove filters except for something else. So you can keep filters or leave filters for some elements of your context, right? And so this can get a little bit tricky to understand. So don't get me wrong here. This is quite a complex function, a table function. But I think once you see it in action, you will understand it a lot clearer. The key concept to remember though is that all removes filters. Okay, so you want to remove context, but except allows you to leave some there or bring some back. Okay, and so that's the I guess in simple terms what is theoretically happening. Okay, so what I'm going to do, I'm going to change up this table just slightly. Okay, to show you a couple of things. I'm going to bring in here not only my customer name, I'm going to also bring in my channel. Okay, and so now the initial context of the calculation is every single is customer and channel, and you'll see that my total sales is changing based on that new context. This percent of total, by the way, actually isn't working properly anymore because of the new context. Okay, this new context is not calculating the result as it should, and that is because the all is not working as it should, because it's only removing context from customer name. It's not removing any context from the channel. Okay, but I want to show you a couple of things around all except, and we'll try and fix that one up shortly. Okay, so what I'm going to do, I'm going to create a new measure here, and I'm going to call this one all except example. Okay, I'm going to go calculate here, total sales. Then I'm just going to do all. I'm going to show you what all does by itself in this particular context. Okay, because you've got to remember what does all do? It removes filters. Okay, so I'm going to just push enter. And it returns this huge value, right? Now, what it is essentially doing, if you go all sales, you've got to remember that the sales table is down here, right? So if you go all sales, you're basically disregarding any filters or any context that could be coming from anything in your model, because anything from here, 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 and here will be removed, okay? And so what this is basically calculating up is calculating up the total amount from the beginning of time to the end of time, to the end of our data. So it's basically counting up everything, regardless of any context or filters that we have in place, okay? So this obviously is giving us an answer for a particular reason. You may or may not need it, right? Because, say for instance, you wanted to work out the percent of total for all of the data you have and not caring about whatever time frame, this will be fine. Okay, but what we want to do here, and what I want to show you case study to here, is how we can manipulate the context here within the formula to get something quite unique. What I want to figure out is what per customer the percent of sales through each channel. So each customer should have percentages that add up to 100, right? They add up to 100%, because I want to see how much of this amount is through distributor, how much of this amount is through export, how much of that is through wholesale. So if you think what we need to do logically, we need to go this number here divided by all of these numbers added up, right? And so somehow within this particular context, we need to adjust our formula to get a total of, it looks like around sort of 900, right? Around sort of 900,000 we need it to be here. And then for the this particular customer here, it looks like maybe 700, okay? And so we need to get that in this context, and then we can do similar to what we did before. We can go and we can call it percent of sales through different channels, okay, per customer. So how do we do that? Okay, so what we can do is we can use a function called allAccept to do that, because we do want to remove any filters coming from the sales table, okay, but we want to leave some in place. Okay, we want to leave some in place. So what I'm going to do is I'm going to add back my customer context. Okay, I don't want the customer context to be removed. I want to keep it. Okay, so then I'm going to go enter. Actually, no, this is not sales. We want this to be custom. We want to add back the customer name, because this is the context which is in our particular table. Okay, so that's the context that we actually want to leave in place. Sorry about that. Okay, so now you see that we have here change those amounts, and you see that they're actually changing per customer now, right? So each different customer now has these specific amounts allocated to them. So we're close. But if you just eyeball it, you think, well, 3 million, that's a lot, right? That doesn't sound right to us. It doesn't sound right because this looks like it's about 900. And then the one thing you've got to realize is that this all sales, right, is actually removing any filters from this particular filter we have here as well. And so these amounts are all just looking at data, every single data point we have. It's not accounting for the selection that we have here. So what I can do inside of allAccept is I can actually retain the date context as well by adding it back inside of here. So I'm still going to remove all the context on the sales table, but I'm just going to leave it for this one because I want to leave it for that, and then I want to leave it for the date as well. Okay, then if I go enter, you'll see that this now is equal to the total of these. So I haven't added back the channel context, right? Because I do want to keep the channel context removed, because I want to ultimately go this divided by this, because I want to see all of the sales that this customer has made through all of these different channels in a specific time frame. Okay. So now if I wanted to work out the percent of total for each channel, for each customer, I could then go like this. I could go divide total sales by that number, right? Very similar to what we did earlier. And so now I would have a really interesting visualization with these percentages. And then what I could do is I could format this measure as a percentage, like so. And then what I could also do, because that in itself doesn't really add a huge amount of value, what I could do, that number's a bit, it doesn't highlight the inside as well as you might want. So what you could do potentially is you could add some data bars here, which I think would look quite good. And then you could just choose a good color, and then you would see per customer, a breakdown per customer, and see, okay, where are the things that stick out. So these are the types of really interesting insights that you could ultimately get to with allAccept. Okay. So hopefully now you've got a good idea of what allAccept does. allAccept honestly just takes a lot of practice and using it within different contexts that you might have and playing around to see what answer, if you can get the answers that you need. Okay. But if you can understand this one, you can enable insights that would have been usually very difficult to achieve, and you can do it very simply. Because if you think about how long this would take to write if you knew exactly what you needed, I mean, you can do it so quickly, can't you? It's incredible, and you can get these really interesting insights that are totally dynamic as well. Because you can change the filters here, and that formula is going to work. It's because you're going to retain that particular context in the calculation, no matter what filters you place here. Okay, so it's pretty powerful stuff. Okay, I think we'll round it off there. Recommendation: have a play around with this function. You really want to understand how it works and how it differs from what the all function does. Okay, let's move on, and we'll round off this section by reviewing the all selected function. Okay, let's do a quick review of the all selected function. Now, after going through the last two, I'm hoping that you almost have a good idea of what all selected does already. Basically, all selected removes context from your calculation, but it only removes the contexts within your selections of your report page. Okay, let's go through a few examples to showcase that a little bit more. Okay, so I'm just going to clean things up here a little bit. Okay, and I'm going to take this out here. So if I wanted to, I'm just going to create a new measure here. All selected example. Okay, I could go calculate total sales. Right, I could go all like this. Okay, I could go all dates like this. Okay. Usually, the most usual time I would use this, usually when I would use this function is with dates. Okay, this is the most common example of where you would use dates. You would use all selected, sorry. And I'll show you why. Got to remember, we have some dates selected here. Right? I've got some dates filtered. If I bring this into here, in this particular context, you will see that the amounts are different. Total sales is being naturally filtered by this particular selection here. In all selected, we're just using the all function to remove any filters that could be coming from the date table. Okay. And you know that the date column is coming from the date table, obviously. Okay, so we've removed all filters, so we're now looking at, you see that, remember this result from the last video, 154 million? Well, that's just looking across every single time frame, okay, regardless of what we have selected here. Okay. Well, basically what all selected does is it will remove context from something you reference inside of here, but only for the overarching context you have on your report page. Okay, and so it will actually it will remove context, but we'll remember that we have this particular overarching context from our slicer. Okay, and so what I could do is I could go all selected here, and this will remember that this particular context is on our report page, and so we'll bring back that it will only remove the context within here, not outside of here. Okay, like all would. Okay, let's have a look at one more example, but we'll switch over to a brand new table here. Okay, I'm going to create a table of my dates. This is where you would generally use this. Okay, I use this quite a lot when I'm working with dates. And you'll also see that you do this within a cumulative total. Okay, the cumulative total pattern utilizes this really, really effectively. Okay, and that's what I'm going to go through now. Okay, so let's create actually a brand new function here called cumulative sales. Okay, I'm going to just type it out here. I'm going to go calculate total sales. Then I'm going to come down to a new line. I'm going to use the filter function. First of all, I'm going to go all dates here. Okay, then I'm going to go date is less than or equal to min date. Max date actually, that should be. Okay, so I'll drag this in here. I'm just going to show my total sales, and then I'm also going to show my cumulative sales here. Okay, let's have a look at this example. We here want to calculate, let's just drag this down a little bit. We here want to calculate what our sales are, but what we want to do is we want to calculate them up in a cumulative fashion. Okay, so what we can do with all is we can place a table inside, inside a filter. Inside a filter we can place a table, and in this particular case what I've decided to do is I've decided to use a table function rather than a physical table. And I've said, return me a table of every single date listed from the beginning of time, right? And then go and work out if the current date in the, or if any date is less than or equal to the current date in a particular context. What max date does is it returns each date on its specific day. So the max date here will be the 17th of the 10th, this will be the 18th of the 10th, this will be the 19th of the 10th. But what we do here within filter is we iterate through every single day, and this is iterating through every single date, every single row here, okay? What all is doing though is that we're removing all context from everything on the date table. So it's basically disregarding what this filter is here. It's saying go back and look at the very first data point that we have and start accumulating from that point. What all selected enables us to do is to remember that we have a filter here. We have this overarching filter on our report page, and we do want to remove filter. We do want to remove context within each different row here, but we just want to remember what we have selected within our report. Okay, and that's what all selected enables us to do. It enables us to look within here and say remove the context of the date from here. Right? We don't want to be filtered on this particular date because then we're only going to return this value here. I want to remove this filter, but I only want to remove it not to the beginning of time, to the beginning of our data set. I only want to remove it to the beginning of this particular time selection that we've made. Okay. And that is the big difference. That is a big difference between all and all selected. Okay, and inadvertently here I've just shown you also how to create a cumulative total, by the way. You can reuse, this is the very same formula pattern that you can use across any cumulative calculation that you could ever want to do. Okay, it's the same thing. It's just important to understand the difference between what all would do in counting up your cumulative total versus all selected. You got to remember that all selected will always remember the selection that you have within a slicer or within a sort of like a report page or report filter. Okay, it will always remember that. Okay. I think that's enough for table functions, for some introduction to some table functions. I think what we'll do now is we'll move on to the next section and really dive into more around the context and some nuances there, and then we've really got to dive more into calculating how that actually works. We've gone through it a little bit, we've gone through a few examples, but I want to spend a lot more time in this course going through exactly what it does, exactly how it works, because it's just so essential. Okay, let's move on. Okay, let's expand on context a little bit. I'm just going to work through a few examples here and just talk you through it, okay? I want to make you aware of some nuances to context in particular and how it works within formulas, okay? And how it works in combination, how formulas work in combination with the evaluation context that you have on your particular results, okay? Let's first of all, I just want to jump back into this part, into the area here where I did an example much earlier on in regards to this result here, okay? Remember that in a calculated column, you always start in a row context. That's basically the way measures will be evaluated initially. And that's the engine that will be called upon when you write a measure inside of here. And you have to remember that row context does not work with relationships. It doesn't understand relationships. Okay. So if I go like this, I go sum of the revenue column, right? You would maybe think that this should return the result for each different customer because we have our model set up correctly, we have our relationship set up correctly. The issue is that the calculated column is calculating in a row context initially. Okay. And that row context doesn't allow us to work with those relationships. So what we ultimately need to do, I showed you this before, is we need to change it into a filter context by adding calculate around it. That's one way you can do it, and that's called context transition. Or you could specifically reference a measure, which is basically exactly that. A measure is basically the same thing as wrapping a calculator around the, say, the aggregation measure that we're using. Okay, so this is returning the same results. Okay, so now I want to show you what this looks like inside of here, and just give you a few examples of how you might get tripped up, okay, and how you have to understand when we're in row context and when we're in what is termed filter context. Okay, so let's have a look at our total sales measure here. Okay, so you'll see here that I am currently within a measure, we always start off we always start at a filter context, and then we then go to either aggregation or an iteration context, and we can go into the iterating engine by, as you well know now, calling an iterating function. Okay, so we've got total sales here. Now I want to start off with this context here of date, but what I want to do is I want to go into an iterating or row context. Okay, and I'm going to call an iterating function. Okay, and I'm going to call this iterating function example. Okay. So I'm going to go and get a row context by calling an iterating function. I'm going to reference the sales table, and then I'm going to just reference the revenue column. Okay, I'm only going to reference the revenue column here. I'm not going to use any sort of sum or any aggregation because the row context allows me to work through every single row, and so I only have to reference the column. Okay, if I drag this in here, you'll see that we're getting exactly the same result as expected. Okay, one thing that's interesting to note here is check this out. I can iterating function example 2. I can call an iterating function like SUMX, go sales, then place a formula in here for this total sales formula inside of here, right? Okay, so we start off with our evaluation context. We then call an iterating function. We iterate through every single row in the sales table after the initial context is in place, and we are referencing what a measure inside of here. And so basically, we're looking at evaluating the sales at every single row here, and then at the end of it, we're going to sum it up. Okay, so I'll just press enter, and we'll see what we get for this result. We get exactly the same result, which is as expected. Okay, I want to give you one more example to show you something. Okay, say for instance, in a measure, we go like this: iterating function example 3. Okay, I'm gonna go SUMX here, and I'm gonna go sales, because you've got to remember with SUMX we are calling a row context. If I go sum of the revenue column here, right, check out what happens to our results. We now get incorrect results, really incorrect results. It's saying the total is 74 billion. Okay. Now what's happening here is basically exactly the same as what is happening when we go like this, right? Exactly the same. Sorry. The row context that we have generated using the iterating function SUMX is not enabling the relationships to create the correct filters in our model. Okay, so what's happening here is that we have a filter coming from dates here, right? But it's not working because we're working within a row context and we're trying to do some aggregation. Okay, what we could ultimately do is exactly what we did in that calculated column. We could put a calculator around it like this. That would return us to the correct result, or as we did in the previous function, we could just put total sales, or we could just reference the revenue column directly. Okay, so hopefully by working through these examples, you have a little bit more of an idea around some of these nuances that you have to be really conscious of when you are using particular functions in certain contexts. Okay, and where you can really get sort of tripped up is you can get tripped up with iterating functions. Okay, my best practice, and I'll tell you how I don't really ever fall into this trap very often, is it's all to do with measure branching. Okay, don't try and get too tricky with what you do inside of iterating functions. All you want to do inside of iterating functions is reference things at every single row of a particular table. Okay, you don't need to go inside of here and do any type of additional aggregation or I wouldn't even be referencing. We could reference measures. That's fine. I wouldn't be writing out any sort of aggregation here. I would be referencing measures directly because the measures, like total sales, for example, total sales, right? The measures always take care of the of transferring things to the correct context. Okay, so that would be my big recommendation for you on that. Okay, let's move on. This is an interesting topic, and we're just going to work through some of these additional functions that you could maybe use to work with a specific context or specific examples that you might have in your models. Okay, I just want to review here a couple of things around working with many tables versus just one table. Okay, and what I mean by that is just basically working with the model. Okay, it's important to really understand this model and how context is applied within it. Okay, so I'll set something up here where we'll have a look at our customer name. We'll have a look at our customers, right? We'll have a look at all of our customers. Now, depending on the context here, your formulas can operate very, very differently. Okay, so I'm going to go back to this using count rows, which is a really good way to just test things out really quickly. Okay, so I'm just going to create a simple measure here, testing with count rows. Okay. What I'm going to do is I'm going to show you how a similar formula can, with some slightly different inputs, can change quite remarkably based on just what you place in there. Okay, so if I go count rows values, remember values returns us a one column table of unique values. Okay, so what I'm going to do here is I'm going to add, okay, how many cities? I'm going to add, actually, I'm going to go to the sales table and I want to find my delivery region index. Okay, so basically what this is going to tell me is how many cities I have, each customer has bought something in. Okay, and this could be anything. It could be stores. I know it's cities because the relationship in my model between my regions table here, right, is it is by city. The granularity of my regions table is by city because every single index is for each individual city. Okay. So if I bring this in here, based on how I've done that, and you'll see this is a very demo data set, obviously, this is calculating up how many cities each customer has bought in within this time frame, remember? Okay, so if I change my filters here, this is also going to change the results that we have inside of here. Okay, but what if instead of delivery region index, I actually placed, instead of going and using the sales table, which would have been filtered via the context in our calculation there, because you've got to remember that our sales table here would have been filtered because it's in the lower part of our model. We have our relationships, which are placing a filter from the customer table in this particular case, right? What if instead of referencing something up here, I reference something up here in the regions table, which might make a bit more sense to you logically, right? Because you could say, okay, well, why don't we actually just create a one column list of all of our cities, because that's what we're actually trying to do. So if I do that right, check out what happens to the results. The results are totally different. And this is just the one key, really key thing that I want you just to remember with your models here, okay? And having to utilize multiple tables is that filters can't go up the hill. They can't go up what I call up the waterfall, because I like to call this like a waterfall, right? We want a waterfall of filters. The filters flow down the waterfall. They don't flow back up. They can't go back up where an arrow is pointing down. And you don't want any other type of relationship. You don't want a multi-direction relationship here, or anything different to what you have set up here. You just have to recognize what the particular context is doing, or what the filtering, you have to recognize the filtering that is occurring in your model based on what context you're placing inside of your visualizations or your tables, etc. Okay, and I know that with the initial context is coming from my customer name here, right? So if I want to work out exactly how many cities that each customer is born in, well, then I really need to be referencing something in the sales table, because I know the filter actually flows down to the sales table, and I know within my sales table that my delivery region index is in there, and I can just test it out by going and putting it inside this count rows and going values, and then I can actually now see exactly how many cities. The same could be said here for products, right? So say for instance I want to work out how many products did my customers buy. Well, I can come in here and I can find product description index, and I can go okay, and that's going to say how many products they bought of us. If I wanted to actually reference the actual product name here, you'll see again that this won't work because of the ways that the filtering is set up in our model, how the waterfall of filters just flows down to the sales table rather than any other direction like up. Okay, so just something to be really aware of with context, and look, it takes a little bit of practice. It doesn't come to anyone naturally. It's just a matter of practicing it and really recognizing how things operate with context. Now, it all does come down to, and I would another huge recommendation is you have to set up your models in an intuitive way. Okay, I cannot tell you how many current members of Enterprise DNA get confused in the model here because they don't set it up effectively. You've got to practice you've got to input some best practices here so that you can truly visualize what's going on, and then it really simplifies what you're doing here. It really enables you to understand what's going on here so much more. Okay, let's move on and check out some additional functions that can shed some light on what context we are in and enable us to run some logic in any particular context. Okay, now I'm going to go over is filtered and is cross-filtered. I'm going to show you what these actually denote for us. Okay, so let's just do a bit of setup here. Okay, so when you would use is filtered or is cross-filtered is when you maybe wanted to just work out, okay, well, what context am I in? It could just be like a fact-finding mission. It could also, you might want to include this in an if statement or a switch statement to run some sort of true-false logic that would allow you to show some values in some context and then not show them in other values. Okay, so how you would use it? Let's just run through a few examples and the big difference between them. Okay, so I've got is filtered. Say for instance I want to work out is my customer name. Is my customer table or is my customer name column filtered? Okay, what I could do is I could just put in customers here. Actually, so it can allow me to do that. Let's have a look. Just drag this in. Yeah. Okay. So that is correct. That's odd that it's doing that. That doesn't seem right to me. But you'll see here that what we're doing is we're enabling us to find true or false results, right? So basically I'm saying, is the customer's table in any way filtered in this current context? And it's returning true because the customer name's table, column is in the customer's table. Okay. What I could also do is I could drill into specific columns here and check, is the customer name column specifically filtered? You'll see that it is all evaluating to true. Interestingly enough, you'll see that the total is false, and that's because the total is not actually filtered by anything at the moment. The totals are generally you've got to think the totals have no context because it's returning. If you look at total sales, it's actually returning the total, so it's not being filtered at all by anything in the customer's name column. It's actually just returning the total, and that's the same by is filtered. And so just to test that this isn't crazy, say for instance we wanted to go and look at the regions table. So are we filtered by the regions city? It is false, which is correct, right? Let's say for instance we want to go down to the sales table. Is anything in the sales table filtered? So like, is the customer name index from the sales table filtered? And it is not, because it is not directly filtered here. Okay, so you see here that it is not directly filtered by customer name because the customer name column is coming from here, and I just referenced something that was in here. Okay, this is where is cross-filtered comes into play. Okay, so I'm going to go is cross-filtered example. Okay, and then I'm going to go is cross-filtered, and here I'm going to reference exactly that same one I just referenced, sales customer name index. Okay, and I'm going to drag this in here and have a look. And you'll see that yes, it is cross-filtered, even though it's not directly filtered by this context. It is cross-filtered because it is in our relationships we have these two tables linked up. So it is actually filtered by whatever context is coming from here. Okay, and you could say exactly the same thing for sales channel. Is sales channel cross-filtered? Yes, it is, because even though we're not referencing say the customer name, the sales table is being filtered because of this relationship here in our model. Okay, say for example I went and did something like this, and I actually went to the product table. Is this cross-filtered? False. It's not cross-filtered because there's no way for the filter to come from customer name, which is in our table, down here and then all the way back up again. It doesn't work that way. Okay. So is filtered and is cross-filtered just enable you to create true-false logic that could ultimately be used inside of an if function. So you could go something like this. You could say, is the let's just say, is the channel filtered, cross-filtered? Yes, it is. And then I could go, if it's filtered like that, I could go, yes, I want to see I want to see my total profits. If not, I want it equal to blank. Okay. And so then that is going to return a result for you, based on the logic that you placed inside of there. Okay, so easy enough, nothing too complicated here, but this just, again, is part of just understanding your model, understanding how context works within your model, and how you can work out certain things when depending on what you have in your visualizations and your tables, etc. Okay, let's move on, and we'll have a look at some other functions that kind of interact with different setups in your model and in your visualizations and tables. Now I just want to briefly go over the related function, and I'm going to jump to the model here just to show you what I mean by what related can do. Utilizing the related function enables you to go across relationships or jump up to different layers of our model. Okay, so this is why I really want you to set things up like this in the model, because what related, it's easier to understand how these more advanced functions work, right? So related allows you to do some sort of calculations within, say, the sales table, but go and retrieve values that might be in one of your lookup tables at the same time. Okay, so you can jump across, you can basically reverse a relationship within a measure, within a calculation. Okay, so let's have a look at our products table first. So you see here we've got our products table and we have some information in it. Just for demonstration purposes, what I'm going to do is I'm going to show you how I can retrieve this particular value here and place it inside the sales table using the related function. Okay, so I'm just going to come here. I mean, honestly, you probably never need to do this, like you shouldn't need to do this, but I'm just going to show you this example first and then show you a specific scenario where this is, it's likely you would use related. But I just want to show you the retrieval of information from different tables first. Okay, so I'm just going to go related example here. Okay, and I'm just going to go related, so I can use the related function, and I'm going to go and grab the products group, the product groups that each individual, I guess, product is in, right? Okay, so you got to remember that the granularity of the sales table is every single transaction. So what it's going to do is it's going to recognize what product was sold in that transaction and then go and retrieve the overall group that particular product was in. So it's basically just going to work in the reverse of that relationship. Okay, so we see here it's all top, then you start coming down here. This is the bottom one, this is the bottom product, so product 12 is the bottom product. So if we jump back to the products table, you'll see that product 12 here is in the bottom product group. Okay, so basically what we've done is we have, even though there is relationships only pointing down this way, we have from here we've basically reversed this relationship and retrieved something from up here. Okay, so now I'm going to show you how this works within a measure. Okay, and to example this as well, I'm going to create a new column in here. Okay, what is quite common within, say, data models or databases, etc., is your pricing, your product pricing, or details about your products would more likely be in the products table versus in, say, the sales table. So the current pricing of your product might be in this table here. And so I'm going to, even though we don't have this in our raw data, I'm just going to generate it with formula here in a calculated column just so we can work with it. Okay. And what I'm going to do is I'm going to go average the unit price, the total unit price, like that. Okay. I'm going to push enter. Hopefully you would have known that was not going to work, because remember, we are currently in a row context here, in a calculated column, and row context does not work with relationships. So what we need to do to actually get this to work is we could create a measure and put it in here, but we could also just wrap a calculator around it to create that context transition so then it can work with relationships. Okay, so now I'm just going to change the format of this to a currency. Okay, so now we have, you see, I've done this to basically generate a price that we can have in the products table, okay? And then what I'm going to show you is, say for instance, this was like your raw data, how we could ultimately calculate our sales, our total revenue from the sales table without referencing this price here. I'm going to go and reference the price that was in our product table, okay? And I'm going to do it using the related function, okay? So I'm going to come in here, I'm going to create a new measure. Think about what type of measure we would probably need to use here, okay? Because we can't, because we don't have the pricing information, we're not going to reference the revenue column here. We need to use an iterating function, right? Because we have to work out some logic at every single row and then do an aggregation at the end. Okay, so I'm going to say related, iterating example related. Okay, so I'm going to use SumX here. I'm going to go SumX. I'm going to reference the sales table again. Now, I do have the order quantity already in that sales table, right? I have the order quantity here, and at every single row, I need to times the order quantity times the price. Now, I've mentioned I'm going to retrieve the price from the products table. Now, I don't want to retrieve the price from my sales table, so I can do that by using the related function. I can go related and then column name, and all I need to do is go and reference that average pricing column, right? And then push enter, and then we'll see what this brings up for our sales. It actually brings up different results, right? Because instead of the pricing being individualized for each different product at each different row, so product prices might change, right? It's now just going and grabbing the average price and timesing it by the order quantity at every single row and then doing a sum at the end, okay? So hopefully you can see where you can get some slight differences in your results here depending on how you calculate things. Now, it is a little bit confusing in terms of how this has been generated. The other thing to note, because it wasn't in our raw data, the other thing to note is that this average price here, right? This average price is calculated from all of the data that we have, whilst in here, and then we're working out what the sales are based on the average price. But here, the total sales, and while this is probably quite different, the total sales here is actually working over this very specific time frame. And so you have to know the underlying context of all of the individual results that are being worked out, right? You know, in reality, you wouldn't do this because this would already be embedded into your report, your raw data, right? I just generated this as an example to show you how I could then go and work with my model too. Even though I was doing an iteration through here, I could go and retrieve information dynamically up in my lookup table. I could go against the grain of this relationship by utilizing the related function, because the related function is just working out, well, these tables are somewhat related. It doesn't care about the direction of the relationship per se. It is just caring that they are related, and it is enabling me to jump up and retrieve and basically bring it down into my iterating, which is happening at every single row here based on the formula I have written. Okay, so that's all I want to cover here. There is also a function called related table. I'm not going to cover it here because, to be honest with you, I hardly ever use the function. I don't think I've ever used it in a real world scenario. Okay, so I don't want to spend too much time delving into things that you aren't going to use so much. Or really at all. Okay, but the related function is one that you will use a lot depending on how your data is structured. Okay, so that's why I spend a bit of time here, and I want you to have a really good understanding of how it actually works. Okay, so let's move on. We're almost finished this particular section. Just one more video on the earlier function. So let's dive into that. Okay, I'm going to quickly go over the earlier function here and just tell you a little bit about it, what it actually does. And then I'm not going to spend too much time on it because there honestly is a better way than using the earlier function. So you will find that you will hardly ever use this function. So I just don't want to spend too much time on it because of the way that variables enable you to create similar calculations in a much more intuitive way now. Okay, but what earlier essentially does, let's work through an example and I'll show you. It essentially enables you to jump between context within a formula. Okay, so what does it even mean? Okay, so let's have a look at this. Let's have a look at cumulative product sales. Let's try and calculate a cumulative total of all of our sales based on our products. Okay, so I'm just going to go calculate here. I'm going to go total sales. Then I'm going to go filter products, and then I'm going to go index is less than or equal to earlier in the index column. Okay, I'm just going to push enter. And I'll just change this over to a currency so we can actually see it a bit better. I'll change this one as well. Okay, so you see here that this is just an accumulation of these numbers here, like this, right? Okay. This is pretty meaningless, I understand, but that's not the important thing. The important thing here is just understanding what earlier enables us to do. Okay, so you got to think what we are literally trying to do here in an intuitive sense. We are trying to, at every single row here, work out what the index number is and then count up all of the sales that are that number and below. Okay, and by placing total sales inside calculate, that enables us to calculate our sales, but change the context in which we are evaluating those sales in. So in this line here, where we've got product 7, we are actually counting out this number and all of these numbers prior to that, because we're saying go and work out and work through each different index and work out what indexes are below the current index. Now, where this can get a little bit tricky is that in a calculated column, you have to really understand, okay, well, what context am I in? Am I in a row context or am I in a filter context? In this particular case, calculated columns, you always start in a row context. And what is happening here is that we then, with this filter function, we actually have another row context layered on top of that row context, because filter creates a row context within a formula, okay? And so what we need to do is we need to jump out of this particular row context and go to the row context before to go and retrieve these numbers at every single row. What you will find, and those familiar with maybe say the cumulative total pattern, is you might think, well, why can't I put max here? If I put max here, what will occur is that it will get caught up in the initial inside of the row context of the row context, and it won't go and work out what the particular, won't be able to go and figure out, well, what is the max particular product or row that we're in. Okay, and what earlier does is it enables you to jump out of that context into the earlier row context to go and retrieve that value in say a calculated column. Okay. Now, the reason why I don't want to spend too much time on it, because it is actually really complicated. It is a really complicated function. And honestly, I hardly ever use it because since variables arrived inside Power BI, they didn't exist before. That's why this earlier function was something that you needed to know a little bit more about. But there's just so much, there's such an easy way to actually figure these things out now. Instead of using earlier, what you can do is you can just go var and you can say index column, right? And all you have to do here is literally just type in index and then just do a little bit of formatting. And instead of using earlier, well, you can go and calculate the index column, because what the variable is basically doing is what that earlier function did. It is retrieving the value from the earlier row context rather than this particular context in the formula, because variables evaluate first before any evaluation is done below return. So the current row context here is being created by the calculated column, because we always start in a row context. We're then going and retrieving that product index, so then we know at every single row here inside this formula that we are actually inserting the correct index number. And if I push enter, we'll get exactly the same results as we should. Okay, so that's all I want to really talk about here. I want you to use variables instead. They're just so much better from an understanding perspective, just so much easier to implement, and they just relieve you of having to actually understand and really truly know how earlier works. If you really want to dive into earlier, I would just play around, test it out more inside a calculated column, then see what it does within a measure. But honestly, you really need to use it. That's just what it comes down to. Okay, let's round off this section and move into the next one, where we will be covering a lot more about the calculate function. Okay. Okay, so I know that we have actually utilized the calculate function in a range of different examples up until now, but in this particular section, I really just want to refocus in on it and reiterate why it is just such a crucial function in Power BI to understand. Okay, it will become your most used function in Power BI without a doubt. Anything advanced inside of Power BI somewhat incorporates the calculate function in it. Okay, so having a thorough understanding is crucial. What does it do? The calculate function allows you to override or add to the current context before an expression is calculated. Okay, you can sub in the word measure where expression is, right? Because we're utilizing the measure branching methodology, so it can change the context in which a measure is calculated. Okay, that's the essential thing to know and just embed in your mind. And the thing that I like to do when I am working through this in my reports is I always like to think, okay, what is the current context of my calculation? We've talked about this before in quite a lot of detail. What is the current context? And then what context do I want to actually turn that into by using calculate? Okay, by using the filters or the filter parameters or the table functions within calculate. Things like values, all except, etc. Or filter. All of those different functions are what are going to enable me to manipulate the context of the calculation. Okay, so just a quick intro there, overview of what calculate is. As I say, you've got to really understand this well, because it is just a huge part of great analytical work inside Power BI. The question I get a lot from beginners who are getting into Power BI is, why do you even need to use calculate? Okay, the big reason you need to use calculate is because you need to manipulate the relationships or the context which is being created from the relationships in your model to get any number of calculations. Okay, and what calculate enables you to do is it allows you to create a variety of different filters in your calculations that can't be created in any other way, because there's always this natural filtering that occurs from your model. And so to alter that natural filtering, the only way that you can do that is by utilizing the calculate function, because that's what its sole purpose enables. That's what its sole purpose is. It enables you to change the context of the calculation. Using additional DAX functions like filter, all, and all selected, and values, and distinct can alter the context and filtering on the underlying tables before any calculations take place. Okay, I know we have covered some of these before, but I'm just going over it because I just want, through repetition, I just want this to be one of your key takeaways from this entire course, basically, because I just know how crucial this function is for anything post this. Any type of formula pattern you want to use, any type of high advanced analytics that you want to create inside of Power BI, calculate is the beginnings of all of this. Because within formulas, within measures, and within specific environments and context in your reports and your visualizations, you need to be able to create some sort of manipulation of the underlying table of data to create different filters or different virtual tables, like we've discussed, to go and find out these calculations or to get the calculated results that you might need for some sort of insight that you're after. Okay, so hopefully just by reiterating this again here, it's really starting to become a familiar concept, because that's what we need as we go through more examples later on. Okay, let's move on to the next one. Okay, remember what we can do with calculate. We've already gone through a few examples of this. Okay, so what I'm going to do is just go over a few more and just reiterate what and how calculate operates. Okay, so for example, what I'm going to do here is to show you how we can use it with the all function again. So I'm going to go calculate examples here. And as I've said many times, just doing lots of examples here is so crucial, right? So just me showing you some here, but then I definitely want you to go away and play around with how you might want to utilize it as well. First of all, it comes down to understanding what the current context is. Okay, what is the current context in this particular table? Well, the current context is my date here and also my customer name in this particular table, because every single row is a different customer. Okay, well, say for instance, I want to calculate up the total sales of my customers, but I don't actually want to have, and this is where these table functions come into play, and they're very, very important. All, remember, is a remove filters function. Say for instance, I want to remove all of the filters from the dates table, right? So what's happening here first is we've got to evaluate, okay, what is the initial context? The initial context is customer name and dates. But what I want to do is I want to calculate up, I still want to calculate up total sales, right? But I want to calculate it in a different context, because that's what calculate enables me to do. And I'm going to manipulate that context by removing any filters which are coming from dates, okay? So basically I'm just going to disregard all of the filters coming from here. Okay, so let's have a look. Oh, it's fallen into this one here, so let's just quickly move it. Okay, if I drag this in, you'll see now we're getting very different results, because it's totally disregarding what filters I have here. And I can move these filters around, etc., and I'll get different results here, but nothing changes here because it just doesn't even care about the filters that are coming from the slice. Okay? And so that's one way to think about how calculators operate. Let's look at it another way. Okay, let's actually set up our table slightly differently here. And I'm going to bring in my date, and I'm going to show you how calculate can work with time, with a very, very simple time intelligence function. Okay, so I'm going to bring in my initial simple measure, my core measure, which is my total sales, and I'm going to change this. I'm going to change, instead of worrying about dates, right? I don't really care about removing filters from my dates. What I want to do is I actually want to change my filters, or change the context of the calculation using a time intelligence function called same period last year. Okay, and then I'm just going to input the last for the dates column. So I'm just going to input the dates column like so, and then I'm going to bring that inside here. Okay, and so what this is doing is let's go and find the first result down here. Well, the first result we have in our particular data set will be shown by whatever first result appears here, actually. So look. So the very first date we have in our data set looks to be the 14th of the 8th, 2019, right? Because it's 108. And let's have a look. You see here, 14th of the 8th, 2019. Even if I drag this further back, you'll see that this is the very first result. And so what Calculate is doing here instead is it's enabling us to ultimately compare our sales on 1 year versus our sales in a different time period. In this particular case, because of the function we placed inside of here, it takes us to the same period last year. And so this is where, once again, what you place inside of Calculate becomes very, very important. You've got any number of ways that you can do it. The main ones we've covered so far already: filter, all selected values, all accept, etc. But there's a whole range of other ones like time intelligence functions and other table functions like cross join, summarize, so on and so forth. Okay, so there's so many different ways that you can manipulate things in behind the scenes from the natural filtering which is occurring from your model. Okay, and hopefully you're starting to see and you're starting to become aware of how doing that manipulation inside of measures just brings that immense scale to your analytical work, because Calculate simplifies the form, it really simplifies the measures that you ultimately have to write to create really high level and great analysis within Power BI. Okay. And these are just two really, really simple examples. I know we've actually gone over a few others already, and we'll go over way more. Things like cumulative totals, dynamic grouping techniques, percent of total calculations, different ways that we might want to manipulate our context for different calculations, like how we worked out the percent of total sales per channel for all of our customers. So there's just so many different ways that you could ultimately use Calculate to discover some unique insight, which doesn't appear naturally within your raw data and naturally with any of the filtering that is taking place with the relationships that you have in your model. Okay, so that's all I want to cover here. Just again a bit of a recap around some simple ways to use Calculate. The next one, I just want to again reiterate how Calculate actually operates. I know I've been hammering it into you and talking about it all the time when we've been running through examples of Calculate, but I just again want to go through it to specifically drill into the computational aspects of the Calculate function. Okay, let's really drill into this here, okay? I want to evaluate exactly what Calculate is doing. We're going to just do a couple of other examples to work it out, okay? Remember, with any result inside of Power BI, it is always, the way to think of it is always calculated individually. Okay, so let's really drill into this 108,466, okay? What is the current context, or what is the initial context of this particular result? The initial context is basically this date here, 14th of the 8th, 2020, okay? That is the initial context of the calculation. That is why when we use the total sales formula, the total sales measure, we get 220,000 odd, okay? But what if within this particular context, we want to show what we actually made from a sales perspective the year before, the prior year, okay? So for us to do that so that we could ultimately compare these two, because say for instance we might want to work out what's the difference and what was the change, for example, the growth, what was the change in growth from day to this day in the current context of the same day in last year. And this isn't just for days, right? You can have it for months as well. This is just because the current context is a daily granularity. Okay, but for this particular result, what I want to do is I still want to calculate up total sales. This is my measure, this is my expression, right? I still want to calculate it up, but all I want to do is I want to change the context in which I counted up. Okay, so what I'm going to do here, utilizing this particular function, which is specifically designed to allow me to jump back to exactly 1 year prior, right? So let's have a look at another one. Let's create another example, okay? And go through that again. So instead of going back 1 year, let's say I want to go back, I'm going to use date add. I have used this once before, I know in this course, but I'm going to jump back 1 quarter instead, okay? I'm going to jump back 1 quarter, and date add enables me to do that. Date add is a much more versatile date comparison function than same period last year, because same period last year only enables you to jump back 1 year, but date add enables you to jump back any number of time periods, right? So what I'm going to do here is I'm going to drag this in now, and let's have a look at this particular result here. This particular result is counting up total sales, but instead of going back 1 entire year that we had here, I'm only going back 1 quarter. To make it easy on us, why don't we actually just go back 1 day, so we can actually see what the prior day was, right? So let's have a look at this result now. This 110, instead of it being in the natural context in the day that it did actually occur, what I've done is utilizing this additional filter or time intelligence function within Calculate. Calculate has enabled me to change the context in which to calculate total sales, and it has changed it to this new one which I've specified, which is the day before, okay? It has enabled me to adjust it for this particular singular result here, and it does exactly the same thing for this result here, for this result here, for this result here, or individually. It does it all individually. Okay, and then we could ultimately branch out again, and then this is where we can do our comparison. We could say, okay, what was our sales today versus yesterday? What was our sales today versus last quarter? These are the types of things that are enabled by Calculate. And we can get far more complicated, obviously. We can, or complex. It doesn't have to be complicated. It doesn't have to be complex, sorry, and complicated, but you might think it is initially. But we could say, okay, well, instead of using a time intelligence function, well, we could actually use filter. And we could say, well, go and so I'll just run through an example. So go and look through all days, right? So I'm going to go filter all dates, right? Go and look through all dates, and if the date is greater than the max date, which will be the current date in the context, minus 7, and the date is less than or equal to the max date, right? What does this return us? Again, we're placing this inside of Calculate, right? So basically what this is doing is it's almost like a moving average. It's counting, it's not a moving average. It's on every single day we're manipulating the context to count up. It's like a rolling average, actually. We're counting up how many sales have we made in the prior 7 days, basically. How many sales have we made in the prior 7 days? And so it's doing a very similar thing. We are still counting up total sales, but again, we are changing the context of the calculation in which we are calculating that total sales in, okay? The natural filtering is coming from, say, the context here, which is the 14th of the 8th, but instead of just looking at the 14th of the 8th total sales, we've decided to look at that and 7 days prior. And then the same thing for this day, this day, this day, and this day. Okay, I think I've reiterated this enough. Hopefully you're starting to get the hang of it, and you can start applying Calculate very quickly to your own work. Okay, let's move on, and we'll go over some other examples of how and when you might use Calculate. Okay, so here I want to show you the use relationship function and how you can use it in combination with Calculate. Okay, now what we have here, and I'm going to run through an example that will be very common to something that you might have to deal with. Within our sales table, so this is our sales table, right? Got to remember our sales table is our fact table. We have more than one date. Currently, our relationship is on the order date here. Okay, so if we have a look, here, if we have a look at this relationship, you'll see that the date is linked up to our order date. Okay, and because of that, all of the natural filtering which is occurring in our model via those relationships, all of this information is via our order date. So these are the total sales on our order date. But what do we have multiple dates here? We actually also have a ship date, right? We could also have an invoice date, which might be more relevant if we're trying to showcase when revenue was recognized, for example, okay? Because revenue isn't always recognized on the order date in a lot of businesses. Revenue is actually recognized on the invoice date. And so this is a really real world scenario where you might need to change the filtering which is occurring in your particular model. You might need to do it physically with a relationship like this, but you could also do it virtually via a formula. Okay, and that's where this use relationship function comes in. It's really, really handy. Okay, one of the key things to note inside of your model here is you can only ever have one active relationship, what's called active relationships, okay? But you can also have what are called inactive relationships, okay? And they're like this. Okay, so I'm going to grab my date and I'm going to drag it down to my ship date. So now we do have a relationship, but it is inactive, and that is shown here by this dotted line, okay? So this dotted line, whilst it is showing some connection, is really quite meaningless unless we turn it on within our measure using use relationship, the use relationship function, okay? So what we can do is we can actually disregard a active relationship and only care about an inactive relationship if we structure our formula correctly. And then that is going to be reflected in results that we might get in our report page. Okay. So what I'm going to do here is I'm going to create a new measure. And we have to use Calculate for this because remember, Calculate enables us to change the context of the calculation. So I'm going to calculate a total sales by shipped date. Okay. I'm going to use Calculate. I'm also actually going to use total sales here, right? I'm still going to use total sales because remember what sits underneath total sales. It's just a simple core measure, a sum of the revenue column. Okay. Then what I'm going to do is I'm going to use the use relationship function. Okay. Check out what it says here. It specifies an existing relationship to be used in the evaluation of a DAX expression. So again, a very good information tooltip there. The relationship is defined by naming as arguments the two columns that serve as endpoints. Okay. So basically the two columns that we want to join up virtually. Okay. So what I'm going to do is I'm going to go and join up my dates column to my ship date. column, okay? And then just round it off, okay? So this is a key use of calculate, obviously, because we need to change the context of this calculation. And instead of using any of the other examples we've used so far, we're going to use another function called use relationship. And this specifically enables us to, I can even write a comment here, remember, 2 forward slashes, use relationship allows us to turn on an inactive relationship, okay? Virtually. Okay, so some good commenting can never go wrong inside of the measures. And then what I'm going to do is I'm going to drag this in now and see what values I get. And so you'll see now that all of these values are different, even though we are still really counting up total sales, but now the context has changed, because within calculate we've said, okay, I don't care about that natural context coming from the active relationship. I want to actually turn this one on here so that my values are now reporting via ship date or any alternate date that you might have in your model, like invoice date as discussed before. Okay, so that is really the 95, maybe 100% of the time, that's the location or the scenario where you're going to really use the use relationship function. I've found. I haven't really ever found a situation where I'd use that in different ways. You may, but have a solid understanding of what it's doing first before you then go and venture out into something a little bit more advanced, because this is a really logical and practical usage of this particular technique. Okay, let's round it off here. I think that's all we need to cover here. I'm sure you are now starting to really get how calculate can be used in many different ways. Okay, to finish off the calculate area, or calculate section rather, let's just go over some more examples. I just want to continue to showcase lots of different ways that you can use calculate and use it in combination with other functions, because by itself calculate doesn't really do that much. You do want to, it's about using it in combination with all of the other great functions that you have inside of Power BI or inside of DAX to really harness its power. Okay, so let's just start with some simple ones. Say for example, I want to calculate my sales of only products which I consider good, okay, like my top products. As you know, we have inside of here, we have our in our products, we did this earlier in the course, we have our product groups here, right? These are totally arbitrary groups, but say for instance, we only want to look at sales from our top products, right? Well, this is something that we can very, very easily do with the calculate function, right? I can just go sales of top products, right? And I can say, okay, well, I want to calculate total sales. So this is the way to think about it. I still want to calculate total sales, but I want to manipulate the context in which it is calculated. So I'm just going to go filter here, and I'm going to go products. I don't have to worry about using all or values or anything here, because remember, the context here is coming from date. It is not impacting the products table, okay? And then I can go product groups here. I can go equals to top, right? So as I say, still counting up sales, but now we're only going to be looking at the top sales, okay? So I can drag this in now. And you'll see that these amounts now are all different to what we have here, because we're only looking at the top sales, okay? We could then do something different. Like we could say, okay, well, I want to look at only the customers. I want to look at all of my sales of all of the customers that have a total sales or have a profit margin greater than X. Okay, so let's work out that one. So I'm going to say, and what do we just, instead of sales, I'm going to use profits, and just to show you that it doesn't really matter what, the measure itself doesn't matter. So I'm going to say profits for high margin customers, right? This is, again, where measure branching is crucial. So I want to calculate up my total profits, right? Remember how we got the profits? Profits doesn't even exist in our table, right? In our raw data, we've generated it from some branching of our measures. So I want to calculate my total profits, but I only care about customers who have profit margins, because remember we calculated profit margins, right? Greater than 32%. Okay. Again, I'm calculating out my profits, but I'm manipulating the context in which it is being calculated. I'm adding some additional filters to it. Okay, so I'm then going to where did that land? Profits for high margin customers. Right? So now I'm just looking at a really my strongest subset of customers, and then I'm evaluating what their particular profits are. I obviously could change this to sales. I could change it to whatever. Okay. So but let's stick with profits. Like so, total profits, like so, okay? But then let's also now take this even further, okay? So what if I want to, so now I've calculated up this profits for high margin customers, right? I've got it in a measure by itself. What if I wanted to create a cumulative total of this particular measure here, okay? Well, I could then branch out once again, utilizing the similar technique we've discussed previously with a cumulative total. So I could say cumulative sales for high margin customers. Okay, so it's a bit of a long title. Probably want to maybe you want to make it a bit smaller, but you do want to be descriptive. So I'm going to go calculate. I'm going to go profit for high margin customers. Then within here, I'm going to go filter, because I still want to remember. I still want to calculate the same logic applies here. I still want to calculate up the margin, the profits for high margin customers, but I want to calculate it in a slightly different context, right? I want to calculate it in a new context for every single row in this particular table. Okay, and then I'm going to go and dates here. And this is where these patterns or formula combinations can be used over and over again. Some of you might recognize this. We have already gone through the cumulative total pattern in a previous example. But now if I drag this into here, you will see, if I come up the top, you'll see that we are now creating a cumulative total of this particular result here. So once again, calculate has enabled me to move from so one branch of a measure to another branch. And think about how many layers this goes down. This is how you just, I mean, I just love talking about this stuff. This is just where, I told you earlier in the course, we haven't even got started yet, but look at this, look how far you can take things so quickly if you just start implementing things with calculate. We first of all calculated our profits by some measure branching, then we've then even drilled into a more specific part of our products, and then we're creating a different visualization that we can use based on that new result, and we're branching out again, utilizing the calculate function. Okay, and we haven't really even got started with time intelligence functions and how far you can take those, and that's what we're covering in the next section, because then you can take things even further. Say you wanted to compare your profits for high margin customers one year versus the prior quarter or the prior year, well, you could then jump to that. Then you could compare those cumulatively in a visualization, and you can just get incredible insight so quickly. It's really phenomenal. So hopefully, just by again going through some more examples here, I've sort of just whetted your appetite around what's possible. Okay, because we're just scratching the surface. There's just so many different ways you can slice and dice these things, utilizing obviously the model and the actual filtering that goes in the model, but then also manipulating it now with your knowledge of calculate and creating additional filters and additional logic that can produce any number of great insights. Okay, let's round off this section and we'll move on to the next one, where we're going to really dive into some time intelligence functions. Okay, so now we're going to review some time intelligence functions. Okay, I know we have gone into a couple. I know I've referenced date add, same period last year in the previous section, but let's go into it in more depth, okay? Because time intelligence functions are a really great place to start utilizing a lot of the things we've already discussed, like context, measure branching, calculate function. You can really bring all of these things together quite quickly when you do some time comparison analysis or time intelligence type work, okay? Now, I'm here on the DEX formula reference guide because I just want to show you how detailed time intelligence functions are, like how many there actually are. You'll see here in section 1, date and time functions. Not all of these would be classified as time intelligence functions, but a lot of them would. So if we just really drill down in here, we've got date diff, we've got closing balances, we've got date add, dates between, dates in period, dates months to date. There's honestly about 30 to maybe 40 time intelligence functions that could be used to create any type of time-related analysis you could ever want, you could ever imagine. There's nothing I've found that cannot be discovered with time intelligence functions or with a combination of calculate and filter. Okay, there's any type of anything, any time intelligence you could dream up can be analyzed in some way utilizing the functions available. Okay, these time intelligence functions were created to really simplify how you go and work out any analysis over dates or over time. Okay, they were specifically created for this. A lot of this type of work inside of Power BI historically was very not Power BI. In say Excel, for example, any time comparison analysis was very, very difficult. I mean, I remember just having to work almost slave away in Excel, creating ridiculously complex formulas just to go and work out something simple like what is the comparison between this year and last year, or this month and this and last month. Whilst it is so easy inside of Power BI, it's almost crazy. It's like so easy and do it so quickly and it's so scalable. And that's definitely what I want to dive into further and deeper in this particular section. Okay, so in summary, time intelligence functions are just the most tailored solutions inside, the most tailored formulas to use inside of Power BI that enable this great time analytics. Okay, let's move on. I'm just going to really focus in on probably the most important table in your model next. Okay, one thing to note with time intelligence functions is you have to have a date table. Okay, a date table, if you're doing any time work or time analysis, a date table is essential. There's no other way around it. You do not want to be using time intelligence functions utilizing the dates inside of your fact tables or any other date for that matter. You always want to have a structured date table, just like the one that we created, which has a date column in it that you can reference in all of your functions, okay, all of your time intelligence functions, okay? So when we created this much earlier on in this particular course, we went to the query editor, the Power Query Editor, right? And we generated it with some code, which is in the resource pack for this particular course. And that's how I personally still create date tables like this every model I build. You can create date tables in lots of other different ways, so I'm not going to stop say don't do that if you've got a better way or an easier way. But this is the way that I do it, and because I know that I'm always going to get the output that I need to create all of the great time type analysis I'll probably want in any model where that is applicable, okay? And so I still see this a lot, even though I reiterate this anytime I do this type of work or tutorials around time-based analysis. I still see a lot, especially in the Enterprise DNA Support forum, I still see a lot where people are referencing date columns inside of their fact tables, and they're wondering why things aren't working. It's because time intelligence functions have been specifically developed to work over a date table just like the one that we have in this particular model. Okay, so hopefully I've made it really, really clear here. You probably will hear me say it again because it is just a must. It is so essential to any model to have it set up exactly like this. Okay, there are many, even though this may seem really simple just by looking at the model structure, there's so many small nuances for me to recommend you develop your model like this. And making sure you can truly understand how the date table interacts with your fact table when you're using time intelligence functions is a big reason for this. Okay? It's just one of those big, small things that might not be clear right now, but they'll become so much clearer once you start working away at these time intelligence functions. Okay, so that's it. Also, just a reminder. So hopefully, if you haven't got this now and you haven't got that idea in your mind about date tables, hopefully this will highlight it even more for you. Okay, so let's dive more into some of these time intelligence functions. I know we have covered some of them, but I think it's good to review, and I'll quickly show you how versatile they can actually be. Okay, so what I'm first of all going to do, I'm going to create a brand new measure group so we can just focus in on just these particular functions. So I'm going to call this one time intelligence. Okay, and I'm going to, I think we probably already, actually I'll recreate some of these measures because I'm going to show you here what is probably my favorite time intelligence function, date add. Okay, so what I'm going to do is I'm going to create a new measure inside of that new table, and I'm going to call this one sales last year. Okay, I'm going to go calculate total sales, right? I know I've gone through this before, so apologies if it's repetitive, but I'm going to go date add, and I'm going to go date -1 year. Okay, so that quickly I can work out what my sales last year. Okay, so that's my first bit of time intelligence that we are using date add. Okay, I'm just going to confirm this as a measure group, and then flip that in and out. Okay, so now I've got our time intelligence measure group. Okay, then what I can do, and I really recommend this, I'm just going to copy and paste, right? And I'm going to go new measure. And then I'm going to paste it in, and I'm going to say last month instead here, and instead of year, I'm going to change it over to month, just like that. So you'll see here that you have lots of different options in terms of how far you can jump forward or you can jump back, okay? So I'm going to go sales last month, right? And then I could say drag that in here, and you're going to quickly see how fast we can actually make these things or create these things, right? So you see here that the first data point was 108, and it was the 14th of the 8th, right? And now it's landed. We've changed the context of the calculation by using calculate and a time intelligence function. You can also do this, so I'm just going to copy it again, and And check this out. I could say sales next month. I could actually go forward. I could go plus as well if I really wanted to. And even though, this is going to be quite rare occurrences where you might actually use this, but this has enabled me to jump forward, or at least sort of drag this particular result back 1 month. So the sale, so what we're evaluating here is saying on the 14th to the 7th, the sale the next month on that day is 108, and you'll see here it's 108. So you can see how here you can start just like really manipulating things around quite quickly by utilizing these functions. It's really quite interesting, right? Really, really an interesting way to do analysis and quickly do it. And as I was saying earlier, you can just create this analysis so quickly. It's just incredible. And then what you could also do is you can utilize this pattern a number of different ways. So for example, why don't I just go, so I want to say work out my day on day growth, right? So what was the difference between our daily results? So what I can do here is I can say, okay, well, divide the current total sales by the sales from 1 day ago, right? And then make that equal to 0. And I can drag this into my report, into my table here, change it to a percentage, and we can compare and see if this is looking correct, right? Okay, so from yesterday to today, we grew by 211%, right? Because yesterday we were 108 and today we were 229. And so you see here how I'm quickly, I'm not only just utilizing time intelligence, I'm utilizing it in combination with other formulas that we're referencing in other functions, okay? And we can start getting some really, really interesting results. And this doesn't have to just be a daily granularity as well. This is where utilizing your date table is so key here, right? Because time intelligence functions enable you to quickly calculate the same results, but just in a different context, okay? So what I might want to do here is I'm going to change, instead of the date, I'm going to go month and year. And quickly here you'll recognize, well, this is actually an alphabetical order. So I do need to fix this up, and I can with my date table inside of here. So I'm just going to go and find my month and year. And then I'm going to select the sort by, I have a specific column here, which is month in year, which allows me to sort that particular column by a numeric column here. And so now you'll see that this is now by month and year rather than by singular days. Now, some of these don't really make sense in this particular context, like this day on day growth doesn't really make sense because we're not at the daily granularity anymore. So I might delete it out of this one. But say, for instance, we want to do something like this. So this sales this month versus sales last month. Now I can actually compare my month on month sales. And I could then say, copy this here, and I could go new measure like this. And I could have a look at what my month on month sales are. And all I would need to do is change that from day to month, bring this in, and then all of a sudden I have my month on month sales. And so the scalability of this, I mean, I'm hoping you can realize it. I mean, it just blows me away at how quickly I can generate all of these time comparison results. It's pretty incredible. It's pretty amazing. I think this actually probably isn't right. We need to do something else here. We need to work out, okay, what is the difference? So maybe if we went like this, right? Let's have a look here. This should actually produce a similar result for a better, more realistic result. So growth is, yeah, okay, got it. So growth is increased by 45%. Yeah, sounds about right. And then by 33%. Yeah. So that's one way you can do it. You could also do it like this as well. Just a good bit of revision. Last month sales, and I could use a variable. I could, instead of putting this in here, I could put it out here and just set it up like this. And this is obviously going to look a lot cleaner, right? It's going to look a lot cleaner from a, just an analysis perspective. Last month sales. And once you get the hang of it, you can do this. You can do these so quickly, because that was, you don't want to repeat formulas like this if you don't need to, and it just makes your so much easier to read, basically. Okay. And then you might want to put some error handling around this as well, because you see here that month-on-month growth doesn't mean anything. Also, that this total here is quite meaningless. So that's where you can start using the techniques we've already gone over, like is blank or is filtered, etc. They're the ones that are going to enable you to play around with whatever results you want to see inside your visualization or your table in this particular example. Okay, so I think we've covered enough of data. Highly recommend having a play around with this as well. It is by far the best function from a time comparison perspective. Just being able to jump back and forward any time frames and then do comparisons and measure branch from there. So definitely check it out and apply it to your own models, because I can almost guarantee you'll find a way to use it if you're doing some time related work. Okay, let's move on to the next one. Okay, just want to compare the date add function here to same period last year. Really, the reality is that there's no real difference if you're looking to find a similar thing. So you see here, we've gone and worked out what our sales were last year, right? By utilizing the date add function. There is, though, a function called same period last year, which enables you to calculate the exact same thing. So if you're just looking at yearly results, you could use it. Sales, same period last year. It's totally up to you. Okay? I personally prefer using the date add function, but I could just go total sales here, and I could go same period last year, and all I have to do is input the dates like this, okay? And then I can then drag this into my tables here. So if you have a look at the results here, you'll see already that I'll actually drag it up next to it. So you see that they're going to produce exactly the same results. Okay, so there's really no difference. It's just the data is so much more flexible, so much more versatile, as I was saying in the last video. Okay, I could also drag these both down here as well if we wanted to compare here. And again, very, very similar. One thing you could potentially do with the same period last year, but you can also do it with data just by changing this to 2, for example. Here's another little trick. What you can do is you could say, okay, well, instead of sales last year, what if I want to have a look at my sales 2 years ago? Okay, so I could go sales 2 years ago, and what you could do here is you go calculate around like this, and then you could go same period last year again. You see here, I'm just tab by just tab instead of having to type anything out. It's just much quicker to do it that way. And I could then drag this into the report here, and you'll see it's not even showing up because we don't even have this date in our filter, right? Because the first, if we were looking at 2 years ago, the first date would be August 2021. So it doesn't even allow us to do that. It doesn't even allow us to look back 2 years. But that's essentially a trick you can do if you want. But as I was saying, you could honestly, this way data is better, because you could just change this to 2, and that's all you need to do, minus 2 years, and then that gives you the same result. Okay, so just a bit of a comparison there. I used to use same period last year a little bit. It's good for demonstrations, but once you understand and start using the data add, you'll find that you'll just use that all the time. Okay, let's move on to some different types of time intelligence functions. Okay, let's just dive into different ways, other time intelligence functions you might use quite a bit. Okay, so I'm just going to get rid of a few things here. Let's simplify down these tables, and I'm going to keep up my date table and my month and year, my date column, sorry, and my month and year column here, because I'm going to show you how versatile these functions can be when you start creating them and utilizing them with a date table. Okay, because if you try and if you want to analyze your results over different time frames, right? You don't want to have to, this is why date tables are just a non-negotiable, right? You don't want to have to be placing like a month and year column inside of here. You want to be doing all of that aggregating up in a smaller table with your date table, which is very far more detailed around just date specific information. Okay. Right, okay, so let's go over year to date, quarter to date, month to date, and ways that you can actually calculate this, and how I would do it inside of here. Okay, so say for instance we just want to calculate like year to date results. Okay, so I'm just going to go sales YTD, and then I'm going to go to a new line, just tab and enter, and I'm going to go calculate again, calculate coming in. So I'm going to say calculate my total sales, but calculate it. So I'm going to go dates year to date returns a set of dates in the year up to the current date, right? Okay, so I'm going to go dates year to date, and then all I need to do is put in my dates table. That's literally all I need to do. That's why the dates column actually, and then if I drag this into my report, what I'm going to find is I'm going to get this aggregating up on a yearly basis. And this is much easier to explore when I turn this into a visualization, which I will do. So let's turn this into a line chart. So you'll see here that our data only starts in like halfway through 2019, and so we don't have as much there, but then it drops to in January, and then we get a year-to-date result for January as well. Okay, I can also drop this into my month and year column as well, and that's going to create a similar shaped visualization, but just not as much granular detail because it's only looking at monthly rather than daily results. And so you'll see the visualizations are going to be a lot different, depending on what you have in the axes. Okay. So it's going to be a similar shape, but slightly different. Okay, it doesn't really make sense also to overlay with the total sales, but that's just what I have in this particular visualization at the moment. Okay, then say we want to calculate our quarter to date. Okay, check out how easy this is. All we have to do here is copy what we've done there, right? Go to new measure, and it's basically replicating the same pattern. What I'm going to do is I'm going to go quarter to date like this. Okay, and then push enter, and then I can drag this into my table here again, and then you can see what this is doing here if I drag it in here as well. Okay, so that's now calculating things on a quarterly basis. So we're calculating things from January to March to April to June, etc., etc. Then what we could also do is we could go monthly year to date. So I could literally do this again, sales month to date, and use exactly the same pattern if I wanted to. But hopefully you're realizing here that this only really makes sense to do here, because a month to date figure here is really actually going to not produce anything that interesting because of the context of the calculation. Okay, so I'm going to bring in my sales month to date here. Okay, so it makes a bit of sense here. I can show that on the visual. You see here that it's doing a month to date calculation. But then when I drag it into here, because of the context of the calculation, you'll see here that it's actually equaling total sales. It's actually equaling exactly the same amount. So if I just bring this down here as well, you'll see that it just overlaid that sales amount. And that's purely because of the context. The initial context here is the month. And so if we're accumulating up just that monthly information, well, then we're just going to get what the monthly result is. Again, that's where context again is really, really key in understanding it. But it's good to see how you can reuse these formulas, right? And they are not difficult. There is nothing hard at all with this particular formula, right? It's just about knowing when to use it. It's knowing that it's available to you, and then when you can actually use it. There are also some other functions that enable exactly the same calculations. And you might have seen, but they are total year to date. And I'll just create another formula just to show. Now, basically, they do exactly the same thing. Other time functions. They do exactly the same thing. Total year to date. See if I can find it. See here, total month to date, total quarter to date, and total year to date. They do exactly the same thing. It's a slightly different syntax, slightly different parameters that you put inside of them. My recommendation is to stick with the formulas that use calculate, because what they have inside here is they have embedded the calculate function into this function. And personally, I prefer to use calculate to keep consistency across my model, and because calculate reminds me what we are actually doing to generate that particular result. I've mentioned before to you that calculate's your most important function to learn and understand and use, right? And so what you need to do and what you need to prepare yourself for and others who are utilizing your model is that you want people to really understand very quickly what is actually going on. And if they can get familiar with calculate, well, then they'll be able to see you've used it throughout your entire model and can easily understand, okay, well, he or she is changing the context here of the calculation. And that's how we're getting this particular result in this particular context. Okay, so that's basically all I wanted to show you. Some simple stuff, right? Like you might have originally thought, oh, time intelligence, that sounds tricky. Well, it's not. Okay, it's definitely not. There's nothing difficult about it. Hopefully I'm starting to show you that. Okay, let's move on. Let's have a look at some other time intelligence calculations that you could work on and could produce insights that you need. Okay, let's review some more time comparison functions. Okay, we've already gone over some date add and same period last year time comparison functions, but let's go over some other ones that you can use. And specifically, we're going to cover previous month and parallel period and see how they interact with different contexts in which we can place them into. Okay, so I'm going to create a new measure here, and I'm going to go and calculate our previous months. Actually, sales previous month. Okay, I'm going to go calculate total sales. So I'm just going to put my measure here, and then I'm going to go previous month, right? So you see we actually have a range of different examples. I'm just going to focus on one because you can work out how to use the others. It's exactly the same sort of logic, it's just a different time frame, right? So I'm going to go previous month, and then all I have to do is put in the dates column, okay, as per usual. They make time intelligence super easy, but let's drag it in and see what results we get, right? You see what's quite interesting here is that it's not a pure time comparison like for like what date add gives us, right? You see here that it's actually giving us the previous month's total result in a brand new context. Okay, so say for instance we'll come to say this month here. This is what we have in September. We have a full month of data, right? So you'll see here that the total for September was 4.25245 million. Okay, and then we can compare, okay, well, how did we go on this particular day, for example, versus the total from the previous month? Okay, and can you see how if we instead used, say, the previous quarter or the previous year, then you can imagine what sort of numbers we would get here. We're getting totals versus individual results at a daily granularity. You'll see here though, when we put it into a monthly granularity, because you see here we're month and year, it's making a little bit more sense. It's actually returning exactly what date add would return, right? So you see here, because of the different context, you see that this is actually just jumping back 1 month. Well, the aggregation is occurring in the previous month function instead now, and we're getting exactly the same results. Okay, so there's usually many ways you can get a similar result, but this one is quite interesting. Okay, because what you could potentially do is you could run some different type of analysis based on not the current month's total, but the previous month's total, and you wouldn't, and instead of having to do some fancy formula to get that particular total, all you would do is reference that inside a calculator. Okay. Now, let's have a look at parallel period and see what that enables us to do, okay? What parallel period enables us to do is it actually enables us to do similar things to this, but it gives us more versatility, kind of like a date add feature, okay? So let's create a new measure, and what I'm going to do, so it's very similar to the contrast between same period last year and date add, right? Date add gives you a lot more flexibility. Well, parallel period gives you a bit more flexibility than these specific formulas, okay? So sales last quarter. Sales total, let's go sales totals last quarter. I'll just go LQ for short. Okay, so I'm going to go calculate my total sales, okay? But I'm going to go parallel period here, and then I'm going to put my dates column, and I'm going to go minus 1, and then my interval is going to be quarter. So you see here I have all of the options inside of the formula, and then I can just go okay. Okay, I like to put spaces just to make things clearer. Right, and then if I drag this into here, you'll see that we're getting slightly different results, okay? So you'll see that instead of, from a monthly perspective, we're now getting the quarterly totals, right? So you see here, this is the start of the quarter, and you'll see that we're now getting the total of all of the data up to that point, right? The totals all up to that point. Okay, and then if I come all the way to, say, January, let's go to January, up here, you'll see that the totals now are 14 million. So 14 million was what was the total in the last quarter. Okay, and then you can see here it's aggregating up slightly differently. You see here, well, it's doing a similar thing, but it's just being manipulated in a different context. It's being manipulated in the monthly context. So now we can compare, our total sales versus the total quarterly sales of the last quarter, okay? And then if we wanted to, obviously we could change this up, very easily to different quarters, to different months, different years, etc. Okay? And so this is just another way for us to utilize our data or look at our sales and compare our sales in a variety of different ways. It's almost unlimited. I mean, I'm hoping you can really see that. Okay, so that's what I wanted to cover here. Now we've really literally covered all the different variations of time comparison. You've got date add, same period last year, all of the previous quarters, previous months, etc., and parallel period. But if you think about it, the two really, really good ones there are date add and parallel period. Okay, those are two really good ones that you can use. Okay, let's move on to the next one. Okay, let's look at some information functions now. We're going to go over opening balance month function, start of month function, and end of year function. Okay, and we'll have a look at what they return for us. Okay, they all return really unique values for specific pieces of analysis you might want to do. Okay, personally, I don't use these a huge amount, but it totally depends. It totally depends on the environment that you are potentially working in. Okay, so I'm going to call this opening sales balance, and monthly sales balance. Okay, and I'm just going to go calculate total sales. So I can do this as you get more and more used to it. You can start doing this very, very quickly, right? And then time intelligence functions, I'm hoping you are realizing are not difficult at all. So I've got opening balance of the month, right? And I can just go enter. Okay, and then I'm just going to put my total sales here. Oh, actually, I don't even think I need calculating. Just give me a second. So I can just go total sales like this. Right, it could be anything, and then put my dates column, and I don't even need a filter. And this should, so look at what this returns. Okay, so basically what it's doing, so I don't even need calculating in that instance. That's how easy these formulas are to use. You'll see here that the very first value, right, on a particular day, it looks like it's actually taken from the day before, or the opening balance, sorry. So it's taking basically from the last result on the previous day, right? So this is really relevant, say, for like inventory balances, or some sort of financial analysis that you might be doing. And so it's retrieving the value from the last result on the previous month, and it's bringing it forward, and it's bringing it as the value in every single context of that month, okay? And then as we come down to the next month, you'll see that the ending value here, which would theoretically be the opening balance, is now being brought down to here. And you can utilize this, say you wanted to see growth from, you had some values where you want, it's not actually totally relevant from a sales perspective here, but hopefully saying like, say it was like an inventory value, and you wanted to then compare, okay, what is the value from the opening balance, and what is the change from the opening balance? Well, then you could, if you had some values here, well, then you could just quickly compare that to the opening month sales balance or the opening monthly balance, right? So inventory is sticking out of my mind in terms of a good way to utilize that. Okay, so let's try start of month and see what that comes up with. So start of month balance, right? And so I can go start of month. Actually, I'll need to use calculate here. So we go total sales, just as an example, and then I can go start of month. And then all I have to do is bring my dates column again. So easy. Right, and then I can bring that into my date context here, and you'll see all it's done here is instead of grabbing the theoretical open balance, it's literally grabbed the first value of the month, right? It's grabbed the first value of the month, and then it placed that down at every single day of that month, every single context of that particular month, and then we get to, say, January here, and same again, okay? If we bring it down here, similar sort of thing, right? We have different balances here depending on what is the opening balance in a particular month, okay? And you'll see here, so what we've got here, December 2019, 174. So depending on the context, so this is a really interesting one. It depends on the context in which you put it. It will represent in a slightly different way. Okay, let's have a look at another one you could potentially use. And it's just another way to bring certain values from one location to another inside of Power BI. And so end of year balance, right? And then I can go calculate total sales. Then end of year. See here, I've got lots of options, end of month, end of quarter, but I can just go end of year. I can put in the dates column, and then close that off. And I'm going to bring it down to this one here so we can have a look at what it shows. So you see here that obviously the very last value of December 2019 was 105. So let's go and have a look at that. Let's just prove that right. So the very last value was 105,953. Okay, so it probably, from a analysis perspective, it probably honestly is probably better in this context here. So we can compare. So this again is very similar to like the start of month balance, where we might want to compare our. This is, again, it's not sales, like a really good example here, but probably sort of like more inventory levels. So we want to see. You can imagine how inventory levels change throughout the year, and then at the end of a particular time period, like end of a year or end of a quarter, you have them at some sort of level. And you might want to see, okay, well, how did things track versus that end of year or end of quarter balance? Okay, so some good examples there. Some lots of other different ways that you can extract date type insights. It all comes down to having a date table, the model set up correctly, and then just figuring out what time intelligence function is going to deliver the result that you need. Okay, none of it is like practically difficult to actually implement. As you can see, none of the formulas are difficult. All you got to really know is what calculate does, and then what time intelligence function you need. Okay, and you can always use the IntelliSense as well when you're actually typing in formulas. Okay, let's move on, and we'll discuss two other interesting functions that you could potentially utilize at a time related as well. Okay, let's just review some more time intelligence functions, okay, that are going to be relevant to certain scenarios that you might find yourself in. Okay, so let's review dates between, dates and period, and date diff. Okay, now dates and period and dates between are quite similar functions. You can achieve similar things with these functions. Okay, so the way to think about these is they open up a time window for you, a customized time window in any particular context to calculate something. Okay, so it's not like date table where you can only go and compare from one period to another period. Here we can open up specific time windows. Okay, and a perfect example of this is rolling totals. So say you wanted to create like a rolling total. Okay, so I'm going to show you how you can do that with both these functions. Okay, so I'm going to go dates between here, and then I'm going to go calculate my measure, which will obviously total sales again. Okay, then it's asking me for an additional filter, some change to a particular context I want to work in. So I'm going to use date between here, another time intelligence function, and then it says here it returns the dates between two given days, right? So all I need to do is input the days that I want it to look at, and I can make them dynamic by inputting things like this. Okay, so I can go max date here, and I'm going to go minus 30 because I want a 30-day moving rolling total, and then I'm just going to put the dates column in again here, like so, and then just push enter. Okay, and then if we bring this in, you'll see now that this is a rolling total. Okay, and it's actually easier to see if we create a visualization out of it, which I'll do. So you see, I'll turn this into a line. So you see here that it gradually moves up and then sort of stabilizes a little bit because it's now actually reached those 30 days and is now a rolling total. Okay, you could also do this using dates and period, though, which is just slightly different syntax. So I'm going to go rolling total dates and period. Dates and period is also something you use quite really for like a moving average, which I could probably show you actually. So we've got calculate total sales, right? And then instead of dates between, we're going to go dates and period here. Dates and period. Okay, so just think of time window. So you see here returns the dates from the given period. Okay, so I'm saying start. So I'm just getting my dates column. The start date is today. So to do that in the current context, I just need to go max date. Then I want to go minus 30, right? Days, and it gives me all these different options. Okay, so this again is quite a versatile function. It has lots of different windows or time windows you can open up depending on a variety of different things. Okay, depending on what you need. Okay, so this should, in theory, create a very similar result. So you see here, yeah, it's exactly the same. Okay, so it's doing a very, very similar thing. I can drag it in like that. Okay. Now, you could also use dates period like this. Okay, it doesn't have to be using calculate. It could be using an iterating function and moving averages. Okay, and we'll call this one 30 day. Okay, so you could use it like this. So I'm going to use average x here. I'm going to use an iterating function. Remember, with an iterating functions, we don't have to only put physical tables. We can put virtual tables. And what dates and period does is it creates a virtual table of dates only for a specific amount of dates, or the dates that you specify. Right. So I'm going to use very similar logic to what I just wrote. Right. But instead of a rolling total, it's going to be a moving average. Okay, so I'm going to go max date, and then I want it to be a 30-day moving average, like so. And then I need to tell it what to actually average, and then I'm going to go find total sales, and then just push enter, and then drag this in. And you'll see now that this is actually calculating a 30-day moving average for me. Pretty cool, right? And so if I drag this into my visualization down here, it's obviously pretty small because it's not showing. So maybe what we should do here is let's create two visualizations so I can show it to you. So I'm just going to get rid of these two. So you can see here that how it is probably best to look at it like this. So we now have our totals, and then now we have an average, and you can do that with the dates and period. Okay, so another easy way, and think about what you're trying to do with moving average. Again, you're trying to open up a time window, right? And dates and period enables you to do that from or based off any specific day that you want. Okay, and you can make it a 10-day moving average or 7-day moving average or whatever. Okay, the last function I want to show you here is date diff. Okay, this is just a really simple function. Basically, it enables you to calculate the difference between time really, really quickly. Okay, so one example of where we may need this is in our sales table. Okay, say for example, I mean, as I'm working through this example, I'm thinking I probably would never really do this because I don't want to add calculated columns in my fact table, as I always say. But just as an example, I want to show you, because what you could find is when you bring these data points into a table, you might want to work it out within a measure. So I might show you both actually. So I'll create a new column here, and I want to say diff order date to ship date. Okay, what's the difference? Okay, so I can just go I can go and find date diff. Right, and it says returns the number of units between the input two dates. Okay, and so I can say go look at the order date and the ship date, right, and then tell me what the day difference is. And you see here all these different things you can actually do by hour, by minutes, by month, etc., etc., etc. But I want by date, and then I can push enter, and then what that gives me is it gives me the difference between when something was ordered and when we actually shipped it. Now this is actually embedded into our report. Okay, so ordinarily we probably wouldn't want to do that, but for example, in here you might let's have a look. You might want to compare. So let's set something up. So you might have it. You might have your order date, potentially, you potentially could have this. You could have your order date and ship date like this, right? They could actually be from your table inside here, and you might also want to add the order number. Okay, so what the order number is, the sales table is at the order number granularity, so you know that you're getting every single order date and every single ship date here, right? So now that we've got these set up in the table, all I need to do is create a new measure here, and I'm going to just call it date diff example. Okay, I'm going to again use date diff here, and instead of just like inputting the column, what we need to do is we can do that. So we can go min order date, right, and max ship date. We know though when we input this into the table that the context is going to give us the correct, is actually going to give us the order date and the ship date on every single row, because these will evaluate on every single row to those values. Okay, the total would be different. The total will be different because of the context of the total. You see here that this 568 is actually taking the very first order we ever made and the very last day we've shipped something. So whether that is relevant is not really is debatable, but you'll see here that now we have the difference in time between all of these different orders that were made. Now think about how versatile this is depending on your data set. You could work out, okay, what is the weekly, how many weeks are there, is there a difference between the actual order date and ship date, and very quickly we can get to that answer as well. Okay, so pretty powerful formula if you're looking to do something like that, doing some sort of analysis like this. Okay, so pretty detailed one here. Again, a range of different ways you can use these functions, but we've really covered a lot of different scenarios for these functions, right? So let's just round off this section with some couple of practical examples around how you could utilize this. Okay, to round off this section, let's see how far we can sort of take time intelligence functions, or more so sort of like some practical applications of time intelligence functions. Okay, so I'm just going to build things up here. So usually you're going to be working with your dates context, right, initially. And what I want to do here is I'm going to, instead of using this filter here, what I'm going to do is I'm actually going to grab my my quarter and year filter. Okay, I'm going to turn this into a slicer. Okay. And so you'll see here as well that you might see it is that this is not in order as well. Okay, so you see here it's sort of by alphabetical order. So what I'm going to do here is I'm going to come over to my data table again, and there is actually a way you can filter this very easily. So I can just come and highlight the quarter and year column, and then what I'm going to do is go and find my quarter in year. So that's because of the column which is being built in here to sort this, right? Okay, I'm also going to get rid of this blank. This blank that sometimes comes up. It's more to do with the fact that there's actually data outside the range of dates here. So actually, why don't we just update this? I'm going to go back into the query editor. I'm actually going to extend these dates a little bit. So this is how easily you can do it. So instead of like having to recreate a new date table, I'm just going to come into the query editor, go to the advanced editor, and then I'm going to extend this out a little bit. I'm going to go to 2024. Feels so far away. Seems so far away. Okay, and then I'm going to go close and apply. See if that improves anything. Yeah, okay, so I got rid of the blank because of the fact that now our dates cover every single data point in the sales table, okay? And what I can also do here is where I might also bring in my year, okay? So I'll go filter by year. So this is how you could potentially set up your table, your tables, and instead of showing all the years, I'm going to also filter on this page, and I'm just going to say I want to see 2018, 2019, actually I don't want to see 2018, I want to see these 3 years, okay? And so that's going to drill down into more specific things for me, okay? Right. Okay, so now what I can do is I can click on, say, a year and then focus on a specific quarter. So now I'm only looking at like one quarter's worth of data. Okay, so what I might want to do, for example, is I might want to say, okay, well, let's first evaluate my sales, right? I might bring in my sales like this, okay? And then I realize I don't even have sales on that date. So what we want to do is let's go to 2020. Let's go to 2020. That's a better example. Okay, so let's go to quarter 3, 2020. Okay, and then I'm looking at my total sales on those particular days. Okay, then what I want to do is I want to show this as a cumulative total. Okay, I want to show this as a cumulative total so that I can then ultimately compare it to say sales of a different time frame. Okay, what do we first actually? We'll calculate up and we'll bring into this particular context sales of last quarter. Okay, so I don't know if we've actually calculated this one before. So let's do it again. So and try and think, okay, what function would we use for this? Okay, and very quickly just think, okay, the data X, I'm doing some time comparison. Okay, so I'm just going to go sales last quarter. I'm going to go calculate total sales, right? Total sales, date add, and just my dates column, and then I'm going to go -1 quarter, okay? And then I'm going to finish that, just go enter, and then I'm just going to copy this, right? I'm going to copy that. I'm going to drag this in to give me my last quarter results, and then I'm going to create another measure here, okay? And I'm going to call this one sales 2 quarters ago, okay? And instead of recreating it, all I'm going to do is change the parameter inside of there, and now I've got sales from 2 quarters ago, okay? And so now, if you can see, at the daily granularity, we now have time comparisons that we can make between different quarters. Okay, so if I turn this into a visualization like so, you'll see we can work out, it doesn't actually, this visualization doesn't actually justify this type of analysis. Okay, that's I guess what I want to show you. And so I'm going to show you a better way that you could calculate this, okay? Or you could showcase this data. And this is very, I would say this is how I would look to show any sort of time comparison. It's always better as a cumulative total, okay? So let's delete that. And I'm pretty sure we've actually created a cumulative total before, haven't we? So we've created cumulative sales, right? Okay, so another way you can actually find these is in the field section. You can actually start typing in cumulative sales, right? And we could say drag that in like that, and you'll see here it's calculating up the cumulative sales for what we need for. But remember that all selected, right? We only want to be doing the accumulation within the selection that we have made. Okay, now I want to show you how easy it is to go from here into cumulative totals of these two particular results, okay? Because we want to compare this cumulatively to this and to this, okay? So I'm going to go new measure here. And I'm going to go cumulative sales last quarter, right? All I'm going to do is I'm going to change the measure inside here. I'm going to say sales, I'm going to say sales LQ, right? And then I'm going to very quickly create another measure doing exactly the same thing. So cumulative sales 2 quarters ago. And then all I've got to do is change this measure again. I don't need to change the formula pattern at all. That's what's so good about these DAX formulas is how reusable they are. You can just literally copy and paste them, just like we are doing right now. And now if I drag these into my table here, you start to see that these results are now reflecting the cumulative totals of these daily results, right? Okay. So then check out what this looks like when we put this into a visualization. Okay. this now looks like a far more compelling visualization, right? Because now we can very quickly see, okay, well, what are our current cumulative totals here versus what they were, we've outperformed versus last quarter, but we've underperformed by the quarter before that, okay? And then what's seriously cool is, like, look how easy it is to move to the next quarter. All I need to do, or move to any quarter and compare the quarters, is literally click and change the original context of the calculation, because you've got to remember here that whatever I'm selecting here is changing what is inside the table, just like it's changing what's inside this visualization, okay? So this is what time intelligence and combining a lot of these techniques that we've gone through enables you to do, right? Practical insights, which are just amazing and so easy to so easy to drill down into, right? The ability to just utilize the model, the context, the changes of context that you can create via your model, and then overlaying that with a variety of formula techniques, including time intelligence, utilizing, calculating the filter function, measure branching methodology, all of those things overlaid enable you to very quickly find these really great insights. And your consumers are going to love it. I see it time and time again. Just be able to see, how quickly you can navigate towards different things is pretty phenomenal. And you got to remember, we haven't even really, we could do more here, right? We could show, well, what is the cumulative difference between this quarter and last quarter? We could branch out again, and so you're not restricted to just, just where we're at right now. You can do far more. Okay, so I think this is enough for the time intelligence section. I think we've gone into quite a bit of detail here. I'm pretty confident now that you've got a good handle of this. You've probably seen it's not that difficult. It's just about knowing which one to use and to answer which question you might have. Okay, let's move on. Okay, now in this particular section, I just want to do a bit more of a deep dive into variables and some of the nuances of variables, okay, and how they should be used within formula, and how you could potentially get confused of why certain things aren't working out as you believe they should. Okay, what I'm going to do, I'm going to create another measure group here, just so that we don't get these jumbled in with all of the other. Actually, no, sorry, I did the wrong one. We want to go and create a new table this way. Go into data, and I'm going to go variable examples. Okay, so this is going to land down here. Okay, so what I'm going to do, we're going to walk through an example, and I'm going to just show you what you could do with variables and where you might get tripped up with variables. Okay, now what I want to showcase here, you see here that we've got what is the current context in this particular table at the moment. We've got year, so we've got a year selection, and we've got a quarter and year selection. So basically, we're looking at this specific quarter 3 of 2020, and we've got our customer name, right? What I want to do is I want to calculate how many sales we are making for each customer in our top products, okay? And we're going to create some arbitrary amount of sales for our top products, right? So let's do that. Hopefully, maybe you're trying to visualize what formula we might use here. So I'm going to go sales. I'm going to go customer sales of top products. We'll just name it. Pretty long name. We could probably refine it a little bit, but it doesn't matter. And then I'm going to go calculate total sales, right? Because we want to calculate our total sales, but we want to do it in a different context within the formula. Remember, that's what calculate enables us to do. I'm being repetitive here because I just know how important it is for you to just totally memorize the wording of that in your mind so that you do exactly the same thing. Okay. And then so what I'm going to do here is I'm going to go filter, right? I'm going to go filter products. Okay. And look through all of our products, and if the total sales of our products is greater than 100,000, right? Then we want to calculate out the sales of our customers, because remember, we've got a customer context here. We're adjusting the context here by total sales, but it's being adjusted on the products table now. Then we want to count up those sales, okay? So I'm just going to delete that column. And hopefully, just by me going through all of these really unique examples, right, you can start to see how flexible things could be, or how versatile things could be. I mean, I'm just inputting a very generic measure here, right? But you could slice and dice things up within your measures in many different ways. I mean, you could do it by profit margin, profit growth versus last month, or profit growth versus last year, or difference in sales from this year, from one year to the next, or one quarter to the next. It just goes on and on and on how variable you could create your measures and the calculations that you can do, and quite efficiently as well. If you think about it, like there's nothing really, once you understand this, there's nothing really difficult about this formula. Honestly, there's nothing hard. It's just about having a good understanding of how to incorporate all these things together. Okay, so let's have a look at the answer. So I'll just go enter, and I'll drag this in here. Okay, let's have a good think about what this is actually calculating though, because it is quite interesting if you have a really good think about it. Okay, so what is the current context of the calculation? The current context of the calculation is 2020 here, and then quarter 3, 2020. So we're looking at quarter 3. So you've got to remember that context, right? That context is being applied to our total sales measure inside of here, okay? It is not being applied directly, the customer context, right? The customer context here is not being applied to the sales, but it is being applied to this sales, okay, because of what this particular part of the formula is doing. This part of the formula is just going through, the filter iterates through a particular table, right? So we've gone through this before. It's iterating through the product table, looking at the total sales of each individual product and seeing if it's greater than 100,000. But that total sales amount is still actually being filtered by this particular date here, okay? So we're only looking at if it's 100,000 in this particular quarter, okay? Now, what you could do with variables, right, is that you could actually place this outside. You could place this outside of this measure, and you could put it in a variable, okay? So I'm going to go top product sales, right? Top products, and I'm going to add this one up here, okay? And then I'm going to go return down here. And then to simplify this formula, what we could do is we could just go top product like this. Okay? And you'll see now that the results are exactly the same, which is great. Okay? The results are exactly the same. Because this can be done before anything happens down in this particular formula. Okay? We can create that filter for products, or that additional context for products, and then insert it inside of our calculate statement. But the variable will evaluate before anything gets done down here. So it's almost like another layer to how the calculation engine works. The calculation engine works out what context we are in, right, for any individual result. Then it will evaluate your variables first of all. And remember, you can put a table function in a variable. Then it will go and work out your measure post there, which is under the return. Okay. Now, and you can do some things. You can take things even further, right? So you could say, okay, profit. We could say profit threshold, something like this. Okay, we can go and we can put 100,000 here, and we could then come in here and go profit threshold, right? And all of those variables will show up. So there's lots of different ways that you can play around with these variables, right? But now I want to show you where you might get a little bit tripped up. Okay. Say for example, okay, let's what I'm going to do. I'm going to delete all of this, right? I'm going to delete it all, and we're going to go back to this is a really key learning with variables, okay? Because you will get confused if you don't follow some best practices here. Okay, we're going to return back to how it was. Okay. Say for example, right? Say for example, you didn't want to look at the total sales just for this quarter because you got to remember that this quarter is filtered here. You actually wanted to evaluate through every sale from the beginning of time for each product. Okay, so for all of our data, you wanted to explore all of the sales, not just in any particular quarter or any particular selection that might be being made in the report, right? Okay. So to do that, this is how you would need to change your formula. You would need to change your formula in something like this. You would need to change the context of this total sales, right? You would need to go total sales, and you would need to go all dates, something like that, something like this, right? And what this is going to do is instead of this sales being determined by any filter here, now we've said remove any filter there and calculate all the sales up for each different product at any date in our data set, okay? And then work out if it's greater than 100,000. So now we're going to probably get a much greater. So you see here that these amounts, even though they're not exactly the same all the way down, they are pretty similar, right? Because a lot of products that these customers have bought have more than likely sold more than 100,000 across our entire data set. Because you think, remember, we've got about 8,000 transactions in our data set, so a lot of products are being sold, right? Okay, so now that we've incorporated this part here, right, you've got to remember that we're really evaluating some logic here now at every single row in this particular products table. Like we're doing some additional calculations, okay? But it's happening at every single row here in the products table, okay? So what we cannot do is something like this, where we might want to go all sales, right? We can't go and grab this particular formula out like here, right? And then say, add in the variable down here and go enter. You'll see now that these numbers, even though it's quite a minor change, these numbers are now exactly the same as these. They're exactly the same. There's no difference, and it's because of the way that this is being calculated now. It's being calculated not individually at every single for every single product in this particular context. Because this here, with using filter, is calling a row context. It's being calculated before anything is being done down here. Okay, and so this calculation is basically counting up all sales for everything. And so so as we iterate through every single different product here, it's basically inserting every sale here every single time. It's not uniquely looking at the product, because this is only evaluating once right at the start, whilst within the formula we're doing some iterating. So that when this is actually located, this entire formula is located down here, it's actually working away at every single one of those iterations. Okay, and so this is I want to round off this very pretty soon, because this is important stuff, right? This is important stuff. I want to go really dive into it so you understand it. Is that it is seriously important for you to understand when and how this is evaluated. Okay, this is evaluated differently than if you were to put it in a certain context within the actual formula itself. Okay. And that's something to really bear in mind. The other thing is you can't also do this. So you see here, let's change it back. Let's change it back. I can leave that variable in there. It's not going to impact anything if I'm not referencing it down here. So you'll see, check out these numbers down here. They will slightly adjust, right? Okay, so you see there's slight differences now. So you see here, this is 193, this is 171, this is 399, this is 299. So they were all the same before. The other thing you can't do here as well is actually lift this entire function up here as well. So I can't also go and do this because of the way this again will be evaluated up in a variable versus what it will evaluate down here. Okay, so if I go all sales now down here like this and go enter. Actually, no, it does. Sorry, that's my apologies. This actually does do it, because what we've done now. Sorry, I've confused myself here. What I've done now is we've taken the evaluation of say the iterating. We've taken the evaluation because we've placed the filter actually up inside of the variable now. Okay, so whilst before this was evaluating only once by itself, now it's sort of working within the table function and working through the evaluations at every single row in the products table now. So that evaluation is occurring properly now. Okay, so I think that's enough. This is a very long video. It's probably one of our longer ones, but this is just something I really wanted to highlight quite in detail, so that you could get your mind around this really unique nuance to using variables. Okay, because I'm trying to prevent you from pulling your hair out in confusion around why certain things aren't working. Okay, so it's about having a really solid understanding of what sort of context you are in within a formula. Okay, let's finish it and we'll move on to the next video. Okay, just want to go over a couple of other variables examples or ways that you can use variables. So let's just work through a couple. So say for instance we wanted to work out something a bit more precise. Like we wanted to work out how many customers, what their total quantity. Let's do something totally different. What is the total quantity of products sold but that had a certain margin above a certain level and went through a specific channel. Okay, so something quite specific like that. So we could ultimately get to this answer, say, if we had some sort of filters and slices that enable us to get there. But there might be a situation where you want to calculate something a bit more advanced within your formula, within a measure itself, and showcase it next to say your total sales, so that you could then ultimately run a comparison. Okay, and this is where variables can really help in simplifying things quite a lot. Okay, so let's just write it out in full, what it would look like in full first, and then we'll dive a little bit deeper into we'll rearrange it a little bit with some variables. Okay, so high margin quantities sold. Okay. I want you to think about how this might apply to something that you're doing as well in your own model, because I know you're probably not using, in a lot of cases, something as similar as this, but the couple of techniques, as I say, are always the same. Okay, so calculate. I'm going to go and find total quantity sold in this particular case. Okay, and then I'm going to say, okay, well, I want to filter. I want to go through all my different products. Okay, and I only am concerned about my products where I have a margin greater than 33%. Okay, then I want to have a look at all my products as well from my sales table. I want to have a look at all the sales where the channel is equal to export. Okay, so all of my high margin export quantities sold. Okay, and then I can just push enter, and then I'll bring that in and see what answer we get. Okay, so now we're looking at, so it looks like this particular customer, even though its total sales were 428, the high margin export sales were 15. And then what I could do is just to highlight, maybe this particular channel might be a good performing distribution channel that we're going through. And this way we can compare things, right? So we can look at what was the total quantity sold, and then ultimately we could say, okay, what is the percentage of all that total quantity sold? So these are the types of things that you can branch out into after going into more complex calcs like this, or with more complex filters rather. Okay, so what you can do, and this sort of follows on from the last video a little bit, is that instead of having it like this, what we could do is we could actually put this into variables, right? We could say, okay, well, we could go high margin products, right? We can make sure that we name things really well here, and I could come down and I could just grab this, and then I could say export channel, right? And then I could bring this into here as well. Okay, and then all I gotta do is go down here, go return, and then I can really simplify this quite a lot, right? I can come here and I can say, I can just start typing in my variable, I can find it there, just go tab, and then I can just go and find export as well. And you'll see here as I start typing in, the variable comes up as well. And so you can see here how you can simplify things and make it so much more intuitive for others who might be having a look through your model, right? So they can understand it's so much easier to sort of read this. Oh, okay, well, this is my high margin product, right? This is what we classify as high margin. Say they want to adjust this just slightly, well, then they can just come into here, make a slight adjustment like that, and see how it changes the results. They can also come in here and see, okay, well, there's my export filter, and then they come down here. It's just so simple and easy to understand. And then what you could also do is you could actually also write comments, right? You can put 2 forward slashes and you can say, this is our high margin filter, right? And then we can come down here, do the same, export channel only, right? And then we can come down here and write another one. This is calculating the net result of our best distribution channel, something like that. Okay, so you see how much additional color you can give to your measures by doing simple things like this. Okay, so these are sort of things that I want you to really have a good think about if they would improve your measures. I use them quite a lot really. I think that when I personally look at something like this, and I look at a model from a member in the support forum, something like that, I instantly can tell, okay, what this is doing, right? Instead of just think about maybe some of your measures you wrote initially, and they were just a whole range of different functions and parameters in the functions, and they're all, there was no formatting, the syntax wasn't right, etc. So this just makes things far more intuitive, and it's so much better for you, for others, and for anyone who might pick up your model in the future. Okay, let's move on to the next one. We've got one more video in the section that I just want to show you another way that you can utilize measures to bring lots of variables, to bring lots of other measures into one, and to really simplify what you're doing within your measure groups. Okay, here I want to just run through a way you can clean up your measures a little bit, okay? And it's actually a slight alternative to utilizing a measure branching methodology, okay? But I want to make it quite clear when you would use this rather than when you would use measure branching, okay? Or when you would use, you would try and create really simple measures, build on top of those, and then build those out again, that's measure branching, right? You could also clean up your measures and actually have less measures by actually consolidating measures all into one measure by using variables instead. Okay, and I'll just run through a relatively simple example. You can get far more complex than this, but I just want to show you a relatively simple example to let you know what I mean. Okay, and to give you the exact scenario where I would probably do this. Okay, say for example you're calculating something really unique. Okay, really unique that you think you will likely not require any of the intermediary calcs ever again. You'll only ever require them for this one measure. Okay, if that is the case, then what I would do is I would not use measure branching. I would just place the calculations in variables. Okay, so what I'm going to do is you see here total sales by ship date. Okay, say for example I never really I don't think I'm ever going to need to calculate total sales by ship date again. Okay, I don't think I really need this as a separate measure, but I do want to calculate total export sales by ship date, and it's going to be the only time that I calculate this up. Okay, I need to use this the methodology used inside of here to calculate up the export sales by ship date. Okay, so I'm going to go export sales by ship date. Okay, so ordinarily using measure branching, you could just go total sales. You could say you could start typing in ship date like that, and you could go filter sales channel equals export. Okay. What I just want to try to highlight here is, say for instance, you never need to use this methodology in any other measure that you're going to create, okay? And it's more sort of like an intermediary calc, okay? Well, what I would do in this particular case is I would actually place it in here so that I didn't have to have that intermediary measure sitting inside my model because it's just not required. It's only going to be used once. It's only going to be used to actually get to this calculation here, these export sales. Okay, so what I would do here is I would actually calculate, I would do this. I would put this particular formula in here. I'd say total sales, right? Total sales, because total sales is fine because, we're using it in multiple different things. And then I'm going to go use relationship, right? And I'm going to go dates, and I'm going to go ship date. Okay, so that's basically, this particular formula is basically what is down here, okay? And then I'm going to change this to ship date sales actually. Okay, and then I'll push enter. And so now I'm looking at export sales by ship date, so a very different calculation. And ultimately, if I'm not using this measure at all, I could theoretically now delete this measure, right? Because I've now rolled it up into the only measure that I really care about, this intermediary calc. And then it simplifies things in my field section and it allows me to have less measures. Okay, so that's really the only instance where I would do this though, okay? The only instance where I would do this. If you are planning on creating lots of calculations by ship date, you might want to do some time intelligence by total sales by ship date, you might want to do some averages, you might want to do lots of variations of things, right? Well, then you wouldn't do this because you would want to branch out from this particular measure many times. But in the example we just went through, I'm saying, well, what if you didn't? What if you only really needed this to calculate this? Well, instead of placing this inside of here, like creating a measure that looks sort of like this, right? I would place that into a variable, like I've done up here. Okay? Okay, so I think I've gone through that. I think I made my point. So just another good thing to think about with variables. Okay, so I think, and we've also now covered off all the main other nuances I wanted to cover with the variables. But really start using these, start practicing on them, and then I think you'll become more and more comfortable with how to use them very, very quickly. Okay, let's move to the next section. Okay, so now we're going to, in this particular section, going to go over virtual relationship. Okay, it's going to be a pretty short section. I just want to give you a really good overview of how and when you would use this. Okay, now let's have a look at our budget table down here. Okay, in our model, you see here, this I've cleaned up my model quite a bit here as well, and I really recommend you do this. You know, I've just set all my measures to the side here, so they don't take up any real estate from my core model, and then I've got some supporting tables down here, just situated down here. Okay, what we need to do is we somehow need to integrate our budget here into our model. Okay, but you'll see that there's no relationships here at the moment. Okay, so let's just have a look at the budget table. You'll see here that we have our budgets by city and we have our budgets by year. Okay. Now, we may think, okay, well, we have a city here, which is a region, and we have a regions table, right? We also have our year, which is great, and we have our dates table, which has a year in it as well, right? It has a year column, okay? And you might think, well, I should just drag a relationship from here down to here, and I should just drag a relationship from here to here, okay? This is where it's, in my view, a much cleaner option to create virtual relationships rather than actual physical relationships, okay? Because if you think about the granularity of these particular tables, the granularity of the dates table is every date, okay? Not the year, it's every date. And when you're creating physical relationships, what you want to do is you want to create a relationship from the level of highest granularity, which is the date. You want to link that up to a corresponding column inside of a fact table, okay? The same as the region. Let's have a look at regions as well. You see here that the granularity of our regions table is actually by suburb here. It's not by city. City is a roll-up column, basically, of all of the suburbs we have. So, for example, Auckland here, right, is probably referenced multiple times in this particular table because there's multiple suburbs in Auckland, okay? And so what we could potentially do, and what I don't really want you to do, I don't recommend you doing, is this, okay, grabbing a city and dragging it down like this, right? Because this is creating a relationship. You see here that this relationship is the wrong way around, okay? It's actually from the budget table up to the regions table. Sometimes it could turn into a many-to-many relationship where you could have two arrows going in either direction, okay? Let's have a look at the year as well here, okay? And I'm going to drag this down into my year here, and we'll see what relationship that brings up. Okay, so you see here, this relationship has cardinality many-to-many. This should only be used if it is expected that neither column contains unique values, okay? Now, what you just don't, this is my point here. This is not how I would create these relationships, right? I would create these virtually. I recommend to create these relationships virtually, and you can do that with a function called treat as, okay? And that's what we're going to go over in the next video. We're going to go through an example of how we could ultimately link up results in this particular table and filter it by these particular lookup tables in a virtual way, in a measure, rather than in a physical way with a relationship, okay? We're going to create the filter within the measure itself using this particular function. And then by doing that, what we can do is we can then compare results in this particular table with results in this particular table, even though it doesn't have relationships like these tables do. So you see here the regions table is linked up to this particular table, the regions table is linked, the dates table is linked up to this table physically with a relationship. But what we're ultimately going to do is we're going to be able to compare these two tables or data with these two tables together because of what we're going to do within a formula. Okay, so the next video, we're going to do just that. Okay, let's go and create these virtual links, okay, these virtual relationships. We're going to use a function called treat as to do this, okay? And you're going to see also just how much cleaner your models can be when you create these virtual relationships, okay? I'm not saying here, just as a bit of a reminder, I'm not saying to create virtual relationships instead of physical relationships. You should always use these relationships when they make sense. But in this particular example with our budgets, as I described in the last video, it doesn't make sense because it's not, there's no link between the highest level of granularity in the particular regions table here and also the dates table, okay? So creating this virtual one makes a bit more sense. Okay, so let's go through this example. I'm just going to delete these here, okay? Then what I'm going to do is I'm actually going to grab my city dimension and bring it into a table, okay, so we can actually see each individual city. Okay, I'm also going to create, a different, let's create another measure group here, and we'll call them budgeting measures, right? We'll call it budgeting. Okay, hopefully as you create these measure groups as well, you're seeing that it's quite, it doesn't take long to create these things. You can do it pretty quickly. And then now we've got budgeting down here, and I'm just going to whip in here and create a measure. And first of all, I'm going to create this measure, which I'm just going to call total budgets, right? Okay, total budgets. And I'm just going to keep it really simple. I'm just going to go sum here, sum budgets. I'm going to go and find those sales budgets, right? I'm going to bring it in. Budgets, take budget table and sales budget column. Okay, I'm going to go enter, and let's just clean this up a little bit. Okay, and then I'll drag it in. Okay, and check out the results we get here, right? Check out these results. We're getting exactly the same result for every single city here, and also nothing changes when we select something in the year. Okay, this all again comes down to the context of the calculation, right? You've got to remember that we are counting up our sales from our budget table here. There's no link at the moment to the region table and to the dates table, and so that's why we're getting these results here, because it's basically just summing up. It's just summing up everything in the budget table on every single row because no natural filtering is occurring. Okay, but what we can do here, is we can create that natural filtering in the formula. Okay, and that's what we're going to use treat as. Okay, so I'm going to say I'm going to go and I'm going to call this one. Let's call it our revenue budgets. Okay. I'm going to go calculate, because we still need to use calculate here to change the context of the calculation. I'm going to reference my total budgets measure. I'm going to branch out here. I'm going to go down to a new line, and I'm going to use a function called treat as, okay? The information here is a little bit confusing, I would say, but when we go through the example, you'll see that how reusable this is. It says treats the column of the input table as columns from another table. So that doesn't make sense. For each column, filters out any values that are not present in its respective output column. Okay, so hopefully you are as confused as I am by reading that. It doesn't really make much sense, okay? Honestly, I read it even now and I think that really is helping no one, okay? But this is how you use it. You go treat as, and then what you want to do is you want to use the values function, okay? You want to use the values function, and you want to input the column from your lookup tables first, okay? So think about the top of the waterfall. You want to type in that particular column. In this particular case, we're going to go regions, right? We're going to go and find the city column in our regions table, okay? Then after that, I'm going to input the column from my budget table, okay? I'm going to input it, and I'm going to go and find the city column in the budget table, okay? Then I'm going to close this off. Check out what happens to the results once I do this. What's gone wrong there? Something hasn't gone right there. Let's have a look. I would have done wrong. Silly me. I haven't even brought that measure. Remember, that is not actually the measure. That total budget measure is still this. Oh man, I laugh myself sometimes. Okay, so revenue budget. Okay, so you see now, we are getting our budgets are now being filtered or now being sliced and diced by our city dimension. And our city dimension is coming from the regions table. Okay, pretty cool, right? So now virtually we've basically drawn a line between city and city here. And now we're doing all that filtering within our table. Okay, so what I'm going to do, I'm going to get rid of this total budgets. I'm going to compare my budgets here to sales. Okay, I'm going to compare to sales because that's ultimately what we want to do, right? So I'm going to grab my sales in here. Now check out what happens. Check out what happens here when I start changing the date. Okay, I'm going to change to 2021. You'll see that nothing is changing in here. Nothing is changing in my revenue budgets, but my total sales is changing. Because remember, my total sales is going to read that the context has changed by my selection here. But the revenue budgets is not, because there is no relationship between this date table and our budget table. So think about what we need to do here. We need to do something really simple, basically exactly the same as to what we just did. Okay, and then check this out. Check what you can do. You can actually create another virtual relationship here. Okay, so I'm going to go and grab my year column from my date table, top of the waterfall, and then I'm going to go and reference the year column from the budget table. Okay, and then I'm going to push enter. Okay, now if I change years, check out what happens. You see that revenue budget disappears because we only have budgets for 2020. This is our 2020 budgeting information. Okay, and so now this particular initial calculation, the budget calculation we are doing, is now being virtually filtered by these particular dimensions inside of our model. Okay, then what you could also do is, and what I might do is I might say, okay, let's actually create some variables here. I'm going to go and simplify this even more so people can really understand what this is, because a lot of people won't know what treat as is. It's quite a unique function. And then I'm going to go year link, something like that. And then I'm going to add this up here, and then I can just come down here, place return, and then I could very easily just go C-link. I love how the variables come out in IntelliSense. And then year link, like that, push enter. Okay, and this does exactly the same thing. It just reads a little bit cleaner. Okay, right. Okay, let's end the video there. I think you've probably got the idea now. This is a great technique. Hopefully, I made it really clear when you would use this. So let's move on. Okay, really quick video here just to round off this section. I want to compare the treat as function to the use relationship function, okay? Now, you might think, oh, why can't we just use the use relationship function here? Well, because the use relationship function works with inactive relationships. Basically, you can turn on an inactive relationship by utilizing that function, right? Okay, but it makes a lot more sense in the scenario we worked through earlier, because the ship date down in our sales table, the ship date column, right? If we just jump to there, the ship date column, right? It is a date, like it's a date, and then if we come to our date table up the top here, the date is the highest level of granularity in our date table, and so it still makes this is what I would just deem a normal relationship, and so we still want to create a line here, but because we can only have one active relationship, we want to have an inactive relationship, okay? And instead, even though they are quite similar data types or column types of data, okay? And then it makes sense for us to use relationship here, because that is a more optimal way to then go and turn on this particular relationship. In the example that we just went through before, it makes a lot more sense to use treat as and virtual relationships, because if we look at the regions table again, the regions table and the city column within the regions table was not the highest level of granularity. The suburb was, and the suburb is what is related to the index here, right? So this index here is what we linked up to our sales table, because our sales table had an index column for each individual suburb, okay? And then city was a summary column of our suburbs, right? And so that makes more sense for a virtual relationship, because there's no natural relationship that could occur there. The same occurs for the year column inside of here, right? The year column is not the highest level of granularity, the date is, and so there's no natural relationship that can occur there, no one-to-many relationship between the date table and the budget table, and so it makes more sense to do a virtual relationship there rather than any type of relationship, including inactive relationships, okay? And what you might find in your data when you're trying to do things like this, or dealing with tables of data that have a different granularity to your lookup tables, is you might have some totally different scenario. You might be dealing with, say, months and years or quarters or something of that nature, right? And you just need to use exactly the same technique, just adjust the parameters in which you are trying to link up your tables by. Okay, right. Let's wrap things up for this particular section. Hopefully you enjoyed going through this one. This is a very unique idea and technique to use inside of Power BI that I really like to promote and market, because I think it just cleans up your models just immeasurably and makes it so much easier to understand what ultimately is happening here and what is going on. Okay, let's move on. Okay, right, in this particular section, we're going to go over some advanced table functions that you can use, okay? And before we do that, I just want to, again, highlight the scenario where you would use this, okay? And how you can ultimately work out and test what your virtual tables might be doing. Okay. So what I'm going to do is I'm just going to just show you just as if I'm creating a measure here, right? And I'll tell you where it's very, very common to input these virtual tables and use these table functions. Okay. So the first place you would use it is table functions example. Where you would use it in, quite regularly is in iterating functions. Okay. So say for instance you're using the function sumx, right? Wherever you see table, wherever you see this, right, you can put a table function. You can create a virtual table and manipulate that virtual table in a variety of different ways, okay? So you don't have to just put physical tables. And this is where things can start getting really interesting and advanced analytics can be created, because manipulating these virtual tables is where you can quite intuitively write a formula, efficiently write a formula and find some advanced insight really quickly, okay? It's this manipulation of virtual tables, okay? So really key thing to think about and to really spend the time to dive into, okay? Another place where you do something very, very similar is within the calculate function, okay? So where it says filter, I want you to also think that this is where we can place virtual tables, okay? Where we can, in other words, manipulate the context in which the formula is evaluating in, okay? So those are the two main places where you will be using these table functions and using them extensively, okay? Because there's many reasons why you'd use them. One I just mentioned for advanced analytics, it's also a way to optimize your formulas as well if they're working really slowly, because there's ways that you can refine the table that something iterates through. So instead of iterating all the time through a really detailed sales table that could be millions of rows long, or utilizing virtual tables and manipulating those virtual tables, you could be actually only iterating through a smaller subset, and that's ultimately going to make your measure run faster because of the less iterations and less calculations, intermediary calculations that DAX is having to do for any particular result, okay? Right, we're going to keep it very practical in this section of the course. We're going to just cover each different function, but run through some examples of when you might use it, and also some alternative ways that you could calculate similar things. A lot of these table functions, by the way, some of them that you might come across, there are multiple ones you could use to get the same result. Okay, so don't get too caught up in that. I found that the performance from one to the other is really quite small. You know, it's nothing to be really concerned about. So it's whatever you become most comfortable with. I would suggest. Okay, let's dive into it. Okay, let's first dive into the add columns function. Okay, so it's a way it's a table function that enables us to create virtual tables. Now, remember when we went over some of the initial table functions like filter and values, etc. We dived into this section and we created a new table. Okay, now I'm going to recommend to do this as well, so you can try and understand how these particular table functions work. Okay, this is the best place to do this within Power BI. Okay, so let's work up a example here. We'll go add columns example. Actually, let's just call this table function example because we'll use this for all of the different ones here. Table functions examples. Okay, so what add columns enables us to do is it basically allows us to add columns of information to other columns, okay, just like the name suggests. So let's have a look at it. So basically it returns a table with new columns specified by the DAX expressions, right? So what we can do is we can utilize a column, a dimension we might have in our lookup table, and say, for example, we want to bang on some measure that we've calculated as well. We can bring it into the table. Even we can bring it into a physical table or a virtual table without it actually really existing in the table itself. Okay. So what we can do here is I can go something like this. I can go values product name, right? Actually, I'll go into this line here. I'll go values product name because I want this. I could have put a table here if I wanted to, but I just want the product name, right? I just want to list it. And what values is it creates a one column list of unique values. Then what I want to do is I want to add some columns here. Okay. What I want to do first is I want to add say what are the profit margins for my particular products, right? And remember, we've created a profit margin measure, so I can place that inside of here. Okay. And then I can round it off and I can go enter. And so what this is going to do is it's going to give me this customized table of my profit margins and products. Okay. And remember that these profit margins were like on a third or fourth measure branch that we did. And so it's pretty cool now how we can then start integrating these things in together if we want. Okay. And you've got to remember that this also is, even though you might think, well, why don't we just add this as a calculated column to our products table, instead of doing this. But you've got to remember we're going to ultimately do this virtually within measures. Okay, this is just a location where we can see how we can actually generate these virtual tables. We can actually see the tables we're going to generate in the measures. Okay, and you can do more here. You can say, okay, well, let's instead of just that, we could actually add another one. So we could say, okay, well, let's also have a look at our quantity sold as well. Okay, and then I'm going to go quantity here, so total quantity sold, and I can round that off. Okay, and then that's going to generate a different table like that. Okay, so that is essentially what add columns is going to do for us. Okay, then let's say we added it back into here. Okay, into a measure. Okay, this is where it gets kind of interesting. Let's why don't we should we create let's create another measure group, I think. So I'll go into data and I'll go table functions. Right. Okay, and I'm going to add a measure here. I'm going to add a measure in here. I'm going to say we're going to calculate up. What can we do with that? We can calculate up. I guess we could do high frequency sales. High frequency sales. We'll call it that. I think we'll go high frequency sales, something like that. High frequency sales. Okay. So then what I could do is I could go sumx. Okay. You could use calculate here as well, but I'm just going to use sumx because I sometimes like doing this because I just think, okay, well, sumx is an iterator. It's going to iterate through every single row in the table that I place into it, and I'm going to place this virtual table using add columns. Okay. I'm going to go add columns. I'm going to go values product name. Right. Then I'm going to basically, remember I'm generating this virtual table within the measure. I'm going to say profit margins here. Okay, then I'm going to go profit margins. And I'm also going to create another column for quantity, right? And then I'm going to go total quantity sold here. Actually, just type in quantity. You see, I'm really using the IntelliSense a lot to make it a lot quicker. Okay, and then check this out. What I can do here, okay, is I can now reference these columns within my expression part of SumX, okay, to enable me to create some sort of calculation that I might want, okay? So remember, we've got some context coming from here, but then there is also context which is going to be derived from this virtual table, because we're going to iterate through every single row in this virtual table, and then we're going to do some evaluation at every single row. And what might that evaluation be, right? What might we do here? Well, what we could do is we could go if profit margins, and you'll see here that this table icon has come up with profit margins. This is actually from my virtual table. It's actually figured out that I've referenced it in a virtual table. If my profit margins here are greater than 32%, then I want to calculate up the total quantity sold, or the quantity, which is what I reference here. So you see here, this virtual table is picking up my quantity, otherwise equal to 0, okay? So basically what I'm doing is I'm calculating up my quantity sold here if my product margin is above a certain level, and I've done it by referencing this virtual table, okay? I'm going to press enter, and drag that in. So now we're seeing how many sales we are saying are of that high frequency nature at that particular, in each particular city, okay? If we compare that to the total quantity sold, let's bring that in. So you see here, it's a slight difference, okay? We might want to have a play around in terms of how you might want to use it, but this is really sort of the logic that you can use now inside of wherever you see a table, okay? You can adjust things up a little bit more, so this is just one example. Okay, so let's move on, and we'll dive into the summarize function next. Okay, let's have a look now at the summarize function. Okay, so we've had a look at add columns. Let's now see what summarize does. Okay, so I'm going to go summarize. And so what it does is it creates a summary of the input table grouped by specified columns. Okay, grouped by specified columns. Okay, so what you can actually do here is very similar to the add columns function. Okay, very similar. So what I could do is I could say, let's have a look at values I want to create. Instead of like, I could just reference a table actually. I could just say, okay, well give me the regions table if I really want it. Okay, and then add something onto that. Right. Add onto it something that makes sense, okay? But I'm not going to do that here. What I'm going to do is I'm going to say, well, I want to create a column derived from the sales table, right? I want to create a column which has my products, right? My product name, and also by channel, okay? So remember, these particular dimensions are from totally different tables, right? So we're looking, by referencing sales, what it enables me to do is it enables me to start bringing together all of the details from related tables and columns to that particular table. And so what I'm doing is I'm going to create a table here of every product name broken down by every single channel, okay? Then what I can do here is I can then move on to creating custom columns, okay? And I can say, okay, well, I want to have a look at the, maybe the export sales. I think we've already got a measure for that, right? Export, oh no, we won't do export sales because that's also, that's one part of the channel. So we might want to do, let's have a look. We've got a measure here for high revenue sales, right? So we'll just go to high revenue. And I'm going to type in my measure high revenue sales right here, and then I'm going to enter. And we can do more of these. I'm just going to push enter, and let's have a look at what it does for us in our table. Okay, so you'll see here that if I do break down like this, that all of the products now are broken down by each individual channel, and then within those we've broken down and had a look at what we are classifying as high revenue for those particular channels. Okay, so we'll have a look at what that high revenue is as well. You could just use total sales, or you could use any measure here. This is just an example, and let's have a look at what that high sales measure was. High revenue sales. So basically, this was looking at transactions. This was looking at transactions that were above, say, $20,000 in total. Okay, so just a small addition to what we might ordinarily do. I mean, what we could do is we could say, okay, well, we could, in this particular example, in our physical table, we're just running through an example, we could compare it to actual sales very easily, but we don't need to do that. This is just laying out how you could ultimately use this. Okay, so now in this new table feature, I'm able to view what we ultimately might be doing inside of a measure, right? Inside of a virtual table, inside of a measure. Okay, so we come back into here. What I'll do this time is actually just copy this, right? Okay, so what I could do here is I could come in here and I could say, we'll just go summarize example. Summarize the example here. Right, and then I can go SumX again. I could use AverAgeX, could use whatever. Then I'm going to copy this particular table in here. So now it's becoming a virtual table here. And so you've got to remember, for every different city now, we are going to iterate through after this context is applied. So you've got to think, okay, we're going to iterate through every single sale that has occurred via the city, and we're going to iterate through all combinations of product name and channel within each different city. And then what we might want to do is we might want to say, well, if high revenue is, well, we could just go like this. We could literally just go high revenue like that. Okay? We could just do that. And so basically it's going to calculate a similar calculation as what we had before, but now we're basically just calculating high revenue. We're calculating it in a different way. Okay, and we could also put other logic in here, like we could say, well, if high revenue is less than a certain amount, or if high revenue is higher than a certain amount, or if high revenue of the past, compared to last month or last year wasn't of a certain value, then we could say we want to include it and we don't want to include it. So this just goes on and on, the different variations that you can have for this. Okay, and I guess I want to reiterate here how you can manipulate things by referencing columns from the virtual table that you're placing in the same measure. Okay, it's just a matter of just playing around and thinking about what you might need. Okay, so this is another good way to utilize this. Let's also just go through. I want to show you one thing down the bottom here, the total. Okay, so what is happening in a total? Okay, think about the context of a total. There actually is no context, because the context within the table, within the rows here, are happening at every single row based on the city that we have in this particular table. But when it gets down to the bottom here in the total, there's nothing. Okay, so what is going to happen, remember the formula is exactly the same, there's no difference. What's going to happen here is in the total, we're going to literally iterate. We're going to iterate through every single row in this virtual table. So every single combination of product name and channel, we're going to iterate through it. We're going to also calculate every single combination of those what the high revenue sales are. Then we're going to calculate that high revenue sales at every row, save it into memory, and then sum it up. And that's how we're going to get the exact total for our high revenue sales. Okay, so hopefully again from me like talking through it, a bit of repetition, it's becoming quite clear, what you do inside of iterating functions and how now you can start manipulating things around utilizing these virtual tables and table functions. Okay, let's move on to the next video. Okay, now I want to show you something quite tricky, which will hopefully blow your mind even more. Okay, you can reference table functions within table functions. So, and if you think about that more broadly, when we have these in measures, we can place virtual tables within virtual tables. Okay, so it can hopefully, hopefully that is expanding your mind in terms of what's possible, right? Is that you can create unlimited manipulations of your tables because you can literally combine these virtual tables together. Okay, so let's have a look at an example. Okay, so what I'm going to do here is I'm going to go filter. I'm going to type filter. Check out what the first parameter is in filter. It's a table. Okay. But that doesn't mean that you have to put a physical table in here. It's just like SumX. You can put a virtual table in here as well. Okay. And so what I'm going to do is I'm going to place this virtual table inside of filter. Okay. So this is a totally new table that doesn't exist in our raw data or anything like that. And then within here, I'm going to say, well, if all I've got to do, I don't even have to write an if statement. I'm going to say if high revenue is, this is basically what happens inside of filters. It's like a hidden if statement. If high revenue is greater than say 5 million, then I want to retain it. I actually want to retain that combination in this particular table. Okay. Then I'm just going to push enter. And now you'll see that we have a much more reduced virtual table. Well, it's a physical table here, but if we were to then go and place this into our measure, well, then we're going to only iterate over our best product channel combinations. Okay. And can you see, I mentioned just in the first video of this section how you can manipulate tables to optimize your measures to make them work quicker. Well, think about how you can use this sort of technique to be able to do that. Okay. So instead of having to work through millions of rows of data for some sort of calculation, well, you can combine these table functions to somehow reduce the subset of data that you might have to iterate through in one of your formulas. And that's ultimately how you might make things more efficient and speed things up inside of your reports or the computation inside of your reports. Okay, and this is just one way. This is just one way to do it. There's many different ways that you can combine lots of these different things. You just have to have a really good think about how these might be applied, and also how these might be applied within measures, which will have some sort of initial context associated to them. Because that's the one thing that's different inside of here when you're using measures is that you've got to say comprehend what the initial context is. Whilst in here there really is actually no initial context because we're just creating a brand table from scratch. But you've got to remember here we've got 2020 selected. We've also got some city context, so that is going to impact what sort of results are applied here for every single calculation which is happening individually in this table. And this also could be a visual, by the way. It's just better to look at things in a table to truly understand what the results are returning. Okay, so just wanted to highlight that. Let's move on and have a look at some other really interesting table functions. Right, let's now have a look at the cross-join function, okay? Basically what the cross-join function enables you to do is it enables you to basically bang two tables together, okay? Just have a think about that for a second. Returns a table that is a cross-join of the specified tables, okay? So check this out. We can create or use, we can input physical tables here, like a product table, and we could also input virtual tables in here. We can reference virtual tables within this table function, or table functions within this table function, okay? And we can sort of create combinations of columns or tables that don't exist in our raw data or don't exist in our databases or something like that, okay? So for example, I might want to get combinations of every single, let's say, every single product for every single month of the year, right? I want to get a table, like I want to showcase a physical table here, which has one column for every product, but I want to see every product for every single month and year, okay, that we have in our date table. Okay, so what I can do there is, remember, I can create a table, I can place a table function here, so I'm going to go values, right? I'm going to go values product name, okay, and then I'm going to go comma, and check out this. Let's say, well, you can put another table here, so I'm going to again go values month and year, okay, and grab it from the dates table. And the interesting thing to note here is, remember that these two tables in our model have absolutely no relationship to each other. The product name, the product table is a lookup table, and the dates table is a lookup table. They're on our top layer of our waterfall, and so they don't have any relationship to each other. But what we can do here is we can bang them together to create the basically to create a relationship so that we can see them within one table. And you've got to remember, this is just me showing it to you physically. Ultimately, this might be what you want to iterate through virtually within a function, like within SumX or AverageX or an iterating function. Okay, you might want to iterate through a combination of your product name and month and year. Okay, and then you might want to say, okay, well, for this combination, I want to evaluate. Okay, I want to count up how many products had sales in any particular month above a certain level. Okay, so let's actually do just that, right? Let's actually calculate just that. We could do it in here, by the way. We could do it in here. We could say, well, filter cross join. So you see here, I'm referencing a table function which has table functions in it within a table function. I'm going to say calculate if total sales will only show me the sales, the combination where sales were above, say 25,000. Let's have a look and see what this returns us. Okay, so it has changed just slightly, I think. Let's actually go high number. Let's go 100,000 and see if that changes the table more. Let's go a little bit more, I think. Let's reduce it right down. Okay, so now there's only 200 results here when initially there was maybe well over 1,000. Okay, let's see if I can type even one more. Okay, so now we are looking at how many products and months, so combinations of products and months had sales over 500,000, and there was only 138 combinations of those. Okay, And it's an interesting insight, right? One that would be ordinarily quite difficult to discover. Okay. And so what we could ultimately do here as well is we could bring this over into a measure and see how it might work within our measure. Okay. So we'll go over here, we'll say cross join example. Okay. And in this particular example, what we might want to do is we might want to find the min. Let's actually find the min date or combination of product name and month and year for so we're going to calculate up all the sales for all of those combinations, right? We're going to calculate and we're doing this by city, right? So you got to remember there is some context from 2020, we have some context from city, and then within this particular context, we're going to iterate through every single combination of product name and month and year. We couldn't do this any other way because remember that there was no table with these in it. We're creating this virtually. We're going to evaluate, well, what was the total sales for all of those combinations, but then we're only going to return the sales of the min result, okay? And so I'm just going to push enter, and I'll drag this in, and so you see here that was this was the min result from this combination. We could also, just have a look at max X, right? And have a look at that. And so now that's the max month and product combination in each individual city, okay? Because you've got to remember here, there is no such context from city, but in here, there is, and the year, of course, and the year. That context is being applied to this total sales amount here, and then also, and not so much here, the year is filtering this part of the formula, so we're only looking at 2020 here, but this product name isn't being filtered by anything because of where it's located in the model. It is located in the lookup table level, so the context here is not impacting it, the context here is not impacting it, okay? So you see how the context in a measure can impact like very different parts of the formula, and you just have to be really aware of that. It's so interesting, right? I find it quite fascinating. The reason why I do find it so fascinating because it enables you to quickly go and find like so many different insights so fast just by using the right combination. All we have to do is go to 2021 here, and now or 2019, and we can quickly see, okay, what was the high combination of those particular sale months for each product there as well. Okay, I think we've gone into that enough. Really interesting one. Hopefully you enjoyed running through that and can see how you might apply it yourself. Okay, here I'm going to quickly just go through the row function as well, okay? It's not something that you'll use that much, honestly, but it's just a good thing to know just in case just to have it in the back of your mind, just in case of the very rare occurrence where it might be useful. But I want to show you how it can be done. So what it does is it returns a single row table with new columns specified by the DAX expressions. It doesn't have to be DAX though, by the way. It can actually be just typed numbers, which is what I'm going to show you here. Okay, so what you want to do is you want to create. You basically just want to write out your table. That's essentially what you're trying to do here, right? Okay, so what I'm going to do here is I'm going to say I'm going to go row. I'm going to set something up for the next video as well. I'm going to go groups here, okay? And I'm going so this first column I've called groups. Within that column I'm going to create the group called top, and then I'm going to create a new column called min. So basically when it says name, that means you're creating a column name. And I'm going to say, okay, well let's just put this as 0, and then I'm going to put a max here of 1. And then I'm going to close it off. Okay, and check out what sort of table this creates. Okay, so it creates that one row table of information. Okay. So as I say, it's honestly not something I have used in any significant way in a lot of the sort of general development or reporting work that you might do, but it's a good one just to have in the back pocket. There might be a very rare occurrence where this sort of solution might make a bit more sense, okay? And what I'm going to do in the next video, I'm just trying to get back to it, I'm going to show you how we can actually combine it in a slightly more useful way with another table function, okay? So in isolation, it probably isn't so useful, but in combination with other things, it potentially is, okay? And so this is where you have to have a really good, you just have to sort of just expand your mind on how these table functions can ultimately be used. Okay, let's move on to the next one, and you'll see exactly what I mean. Okay, now we're going to go over the union function, okay? Think of union as another way to place one table on top of another, okay? So anything that could be classified as a table, you can place anything one on top of each other, okay? You can place one on top of the other, okay? So we'll just find union. So returns the union of the two tables whose columns match, okay? So your columns have to match, okay? And so what you could potentially do here is you could say for instance, your lookup tables and your fact tables don't, they might have like a similar dimension, but the lookup table doesn't have the full data set that your fact table might have, okay? Union is a perfect way to use this to create virtually a full set of unique values in your entire data set, okay? So it's kind of like an error handling situation there, okay? But ultimately, you want to try and avoid that in your actual raw data as well, right? So I'm not a huge one for creating band-aids like that, but that's just an example of where it could be potentially used, okay? But what you can also do, and how I like to potentially use it, is I can use row in combination with union, okay? Think about that. So what I can do here is because union allows you to actually bring as many tables as you like together, like this, right? All you've got to do is make sure that the column names are exactly the same, okay? So that's what I'm trying to do here. And so what I can do with a technique just like this is I can create a really simple table, either physically here with this table feature or virtually, utilizing this technique, right? And not only that, if you think about how you could use this virtually, well, you could even have the inputs in here become dynamic as well, because instead of having hard-coded numbers like we're going to have here, you could have measures or you could have parameters or something like that. And so you can really create a fascinating, dynamic, self-created table utilizing a technique like this. Okay, so I'm just going to change a few inputs here. I'm going to say, okay, let's go 0.8 here, and then we'll change this to mid, and we'll change this to bottom, like so. And then I'm going to go 0.25, and then 0.8, and go from 0 to 0.25. Right, okay, so when I push enter here, check out how my table looks now. All I need to do is I need to change these, instead of whole numbers, I need these to be decimal numbers. Data type, fixed decimal. Oh, I need to also change this to 2, don't I? Let's see that. Yep, okay, that's better. So I'll go decimal number and then change this to 2. Okay, so now I have this supporting table, which I've generated just from functions, right? I haven't typed it in, I've actually just utilized table functions, and I've used the union function to bang these together, one on top of the other. Okay, then the key, I guess the thing here is that potentially you might want to use this virtually instead. Okay, you might want to create a bit more of a dynamic way to create calculations, and you can do it by utilizing this technique in a measure instead of in a physical table like this. Okay, so hopefully that's given you a few ideas. I don't want to go too much more into it because it's just really about the union function here, like what it actually does, what's the functionality of it, and so hopefully now you've got a clearer idea of what it actually does, and then it's up to you to work out where it might be useful for you. Okay, let's move on to some really interesting table functions that do something really unique, okay, and have a really special purpose, and that's intersect and accept. Okay, so we're going to spend a bit of time on these. Okay, I know we were going to jump into the intersect and accept function, but I quickly realized we need to first dive into the calculate table function. It's essential to understand this function because it a lot of times rolls up into being used in combination with intersect and accept. Okay, and the calculate table function itself is just a very important function because of its close relationship to the calculate function. Okay, calculate and calculate table basically come from the same family of functions. Okay, they enable you both to change the context within a formula. Okay, let's first have a look inside of here what it says calculate table does. Okay, calculate table evaluates a table expression in a context modified by filters. Okay, so you can place a table in here and then a filter. Okay, just remember that. Let's have a quick look at what calculate does over here. Okay, let's have a quick look at what calculate it says for the calculate function. Okay, if I go calculate like this, it evaluates an expression in a context modified by filters. Okay, so it does exactly the same things. All it does is calculate evaluates an expression, whilst calculate table evaluates a table first, and you can modify that table by adding additional filters. Okay, the other way to think of it, and the way I think of it, is this. Okay, I think of calculate as with calculate you are changing the context of the calculation. With calculate table you are changing the context of a table. Okay, and that's the thing to remember. Okay, within this table area here, this is a good way to test what we might want to do. Within this table area here, it kind of actually works like the filter function in a very similar fashion, right? So you see here we've got our sales table. This is about 8,000 rows long. Now, say for instance, I only want to have a look at where my channel is export. Okay, calculate table works in a very similar way, and you'll see that this filter actually is this filter is now being applied to this table, and we're only looking at export sales. So if you think about it, we are changing the context of our table here because we are returning. So instead of returning a singular result, which is what we do with calculate, here we're actually returning a table. Okay, and we are adjusting the context of this table by some sort of filter that we place in here. Okay, and this is as simple a filter as you can get. As you know, you can create really complex filters, just like we do with the calculate function. Okay, but instead of manipulating that expression, that measure, we're going to manipulate a table. And remember, the other thing is that this table doesn't just need to be a physical table; it can be a virtual table as well. Okay, so it can be adjusted in so many different ways depending on what sort of parameters you want to put in here. Okay, the best way to actually learn the calculate table function is honestly by just using it. Okay, just by using it. Learning this one theoretically really does you no favors. Okay, so we've got to just go through some examples so that we can truly understand what it is actually doing. Okay, so that's what we're going to try and do. Okay, so we'll come back into here and we'll create another measure, and I'll go calculate table function. Okay, so I'm going to show you a little trick here with what we can do with count rows as well. Okay, and actually, just give me 1 second. I'm going to put some additional filters here. I'm also going to add, just so I can get a good example for you, I'm going to add the month and year here as well. Okay, and I'm going to make this into a slicer, and so now I can actually dive into like very specific months. Okay, and I'll just find my table functions. Okay, so what you can do with count rows, right? So let's see, count rows is a really versatile function. It counts the number of rows in a table. Okay, well guess what? See table here? It doesn't need to be a physical table. It could be a virtual table. We could use table functions inside of here as well. So this is actually another good way to quickly check what your table functions might be doing. Even though you can't in a measure physically, you can't physically see the table, you could at least run some sort of testing that gives you a good gauge of whether the table is sort of the right size and shape for what you were looking for. Okay, so for example, say I wanted to work out how many products I bought or were bought in a particular city in a particular month, right? So what I could do is I could go values product description index. Okay, this is going to tell me how many unique products were bought in each different city, depending on whatever selection we have here, right? And because you've got to remember that we are referencing the sales table here because we know that the sales table is going to be filtered by the city context in this particular table. Okay, so if I go and drag this in like so, you'll see here that in Auckland in May 2020 we had 6 unique products sold. Okay, if for example I actually went products here, like I try to go product name, right, and try to get a unique list of product names, well, it's going to give me a different result, right, because of the filtering which is occurring in the model. This is not being filtered by any of the context being applied here. So that's why we need to use the sales table. Okay, and I'm going to find the product description index. Okay, what if I wanted to work out, instead of how many products were bought in this particular month, what about if I wanted to work out how many products were bought in the previous month, right? I'm going to show you how to do it. Okay, So instead of looking at it like this, and this is where calculate table can come in. Okay, so to get a table, because you're thinking, okay, we've got to get a table of, we want to find a table like this. This is a table, right? Remember, values enable us to create a table of a one column table of unique values. Okay, I still want to calculate up this particular table, but I want to do it in a different context. I want to look at how many products we bought last month in this particular city. Okay, because you see here we've got May 2020 selected. I want to see how many we actually were actually bought in April 2020, because then I can ultimately compare maybe between these two. Okay, so what I'm going to do here, I'm just going to put, this is another little trick for you. I'm just going to put those two forward slashes in there just so I can make that into a comment for now. Okay, and then I'm going to go calculate table. Sorry. See, it's asking for the table. Well, I'm going to go values, product description index, right? Very similar to what I had above. But check this out. I'm going to incorporate a time intelligence function just like we would have with calculate. I'm going to go date add, okay? And I'm going to put my date column in here. Then I'm going to go -1 month, right? Okay. But, well, first of all, hopefully you're understanding what is going on here, right? Okay. We are still calculating up this table, but we're now calculating up that table in a different context. Just like what we did with calculate, right? Where we calculated up a measure in a different context. In this case, we're calculating up a table. And then what I could do here is I could then wrap this in count rows, like so, right? And push enter, and then now down in this particular column here, we're going to see all the results change because now we're actually counting up the month before. Pretty cool, right? And then check out what you can do here. Okay, let's actually take this even further and use variables. Okay, I'm going to say, and so for my variables here, I'm going to go. This is products sold. Right? This is where I really like using variables for things more so that are more advanced like this. And I'm going to say products sold PM for prior month, and then I'm going to input this particular formula in here. Then I'm going to go return. I'm going to say what was the product sold minus the product sold previous month. And I'll just change this a little bit as well. So this is a very unique insight, right? And this is what calculate table enables you to do. Okay, now we're actually looking at the difference between the products we sold in 1 month in May 2020 versus the products we sold in the prior month. Pretty cool, right? Pretty cool how calculate table enables these really unique insights. And this is just literally one example. Okay, anything, just like all of the different examples you can use with calculate, and manipulating what the context they measure is calculated in, you do exactly the same with calculate table and manipulate what a table looks like. Okay, and then count rows enables you to find lots of other different insights that you probably wouldn't have thought possible, and be able to find them very efficiently. Okay, so hopefully you've got a good idea of calculate table. That's just one good example. We'll go through a couple more as in the next video when we finally dive into intersect and accept. Right, now we're going to go into the intersect function, okay? I'm just going to get rid of these two here. We're going to go into the intersect function and the accept function, okay? There's no real point for me to go into this section here because it doesn't represent well. They don't represent well in that particular section. You really need to just fundamentally know how they work within measures, okay? So that's what we're going to go through in depth there. Okay, so let's start with the intersect function and just work through Work through an example, okay? So let's find it. So intersect, okay? Returns the rows of a left side table which appear in a right side table, okay? So basically, within intersect, we can place two tables, okay? A left side table and a right side table, okay? If you looked at this function before you knew anything about just table functions in general and virtual tables, you would probably have no idea how to ever use this. But now that you know that we can input virtual tables wherever it says table, well then this type of function can open up so many possibilities. It's honestly unbelievable, okay? Because we can not only use a simple table function like values or like filter, we could also use cross join, or we could also use calculate table or any number of table functions that we have available to us within these two particular left and right tables, okay? So let's actually have a think about what we did last time with our calculate table, right? Say for example, and how that might relay onto here. So we calculated which products we bought in 1 month, right? And we compared them. Let me just jump over here. We compared them to the products we sold the previous month, and we worked out the difference. Okay, but in terms of what we basically did here, the key thing that we did is that we calculated up how many products we sold. Here, this naturally gave us the products we sold in each different city via the natural filtering that is occurring in our model. With calculate table, though, we changed the context of that table and got a list of products we sold in the prior month. Okay, but what if we wanted to compare how many products we sold in the current month to the same list of products we sold in the prior month, and we wanted to see which products we actually sold in both months, and not only which products, how many products did we sell in each different month? Okay, did we sell in both of those months? Okay. So let's have a look at it. So what we can do is we can say, okay, well, if we go, if we went, say, values here, values, product, now let's go sales, right? We've got to remember what is actually happening here in the current context. Okay, so I'm going to go sales, product, description, index, right? So you've got to think in this particular context, we are going to get a unique list of each different product we have literally sold, okay, for each different row and for each different city, okay? What we're going to do here, though, is we are going to compare. I want to compare lists. I want to compare the list of products we sold in this selected month to the list of products we sold in the previous selected month, okay? Now I'm going to use calculate table to enable me to do that. So I'm going to go and grab the product we sold last month by utilizing exactly the same techniques that we did before, okay? And I'm just going to go 1 month here, okay? I'm just going to leave it formatted like this because that's fine in my view. So instead here, what we're going to do is we're going to get one list of the products in this month, and then we're going to get one list of products, a unique list of products, remember, because that's what values creates, for the previous month, okay? Then what's going to happen is we're ultimately going to get, with intersect, a one list column. We're going to get a one list column of unique values of the products which appeared in here and also in here, okay? we're going to return the rows of the left side of the table, so it's going to keep the rows of the left side of the table which appear on the right side. Okay, so if a product from this current month appears as a product in the previous month, then we're going to retain that product, and then we're going to just get one list of those retained products. Okay, now we can't just have intersect here. What we need to do again is, if we want to see how many of these products there are, we need to go count rows like this. Okay, and then I'll push enter, and then I'm going to bring this into our table. Okay, so if we want to compare, let's do a bit of a comparison, right? Let's do a bit of a comparison to we'll go values. We'll just go values function here. So we'll go count rows, values, sales, product, index. Okay, so I'll bring this in, right? So this is how many products that were bought in each different city in this particular month, right? This is how many products were bought in this month, but also in the previous month, because we've compared this list to this list inside of intersect and returned the ones which have appeared in both, and then we've counted them up. Pretty cool, right? Okay, let's have a look at the intersect function. Okay, what I'm going to do, I'm going to copy this because the intersect function is pretty similar. And if I just do a comparison to these two measures we've got in here, you'll see. It's the accept function. The accept function, okay? Okay, so check out what the accept does. Accept returns the rows of the left side table which do not appear in the right side table. Okay, so it's basically the reverse. Okay, so let's have a look. So again, it's the left table and the right table. And again, we're going to compare the list here, and we're going to compare the list here. But basically, we're going to only return the products that do not exist in here. Okay, so let's push enter. And so theoretically, if you think what the answer should be, it's going to be the difference between this and this, isn't it? Because we know what ones were in both, and now we need to know which ones aren't in both. Okay, so we've compared those two lists and said, okay, well, only two now in Auckland were in this list, but we're not in this list. Okay, and this is always going to add up to how many we sold in total for that particular month. Okay, so hopefully you've got the idea here. Okay, there are quite a few situations where you might use this, and one is one you will definitely find in the advanced analytics course, and that's customer attrition. Okay, it uses this exact technique because we need to compare how many of our customers say bought in one period and had not bought before, or say bought in this period but didn't buy for another 6 months or something like that. And so this is using very, very similar techniques to this, using either intercept or accept, enables us to go and do that really great customer attrition, new customers, lost customers, all of that great analysis. And you can do it quite efficiently if you just know what fundamentally is happening with all of these different functions that we're using. Okay, this is that sort of analysis, and the analysis that you can generate with combinations of these functions. You used to have to spend tens of thousands of dollars to get that sort of analysis, but now you can write it quite efficiently, utilizing calculate table, utilizing the intersect function, utilizing the accept function. All of these great functions enable you to seamlessly do this sort of analysis now. Okay, so let's run off there, and we'll move on to the next one. Okay, just for these last few videos in this particular section around table functions, let's just really focus in on some other ways that you could create virtual tables, okay? As I've said a couple of times in the course, there are many ways you can achieve the same thing, okay? And with these coming up table functions like summarize columns, generate, and group by, you can achieve similar things in other ways by utilizing the functions which I have mentioned previously, okay? Like add columns and summarize. They do similar sort of things, okay? Which one you use is totally up to you. It's what you become most comfortable with, most familiar with. Personally, these last three I don't use that often, okay? I usually can get what I need using all of the functions that we've talked about up until now. Okay, but that doesn't mean that you shouldn't use them. I'm just saying that I personally don't use them that much. But it's still worth understanding how they work, okay? Because there could be a very unique situation where utilizing these could be important in your data scenario, and you want to be able to call upon these functions if and when needed, okay? So let's first of all go over summarize columns. Now, summarize columns, let's have a look. It creates a summary table for the requested totals over a set of groups, okay? To me, that is actually not a very good explanation. Let's just have a look at what it does. So you just got to think it's creating a table, and it could be creating a virtual table inside of your measures, right? Okay, but I'm just going to show you here how you could do it within the table area, so you can see what the end table actually looks like, okay? And so what I'm going to do here is I'm going to group by product. I'm going to go product here, product name. I'm also going to group by my channel like this, and then I can also create custom columns here. So I can just create a custom column called sales, and then I can reference my total sales measure like that, okay? And then push enter, and so we can see exactly what it's done, right? It's created a table for us to iterate over potentially in an iterating function, or use it as some different context within calculate. So look, just another way that you can generate something like this. And you as you'll remember, you could use a summarize function to do exactly the same thing. You could use the add columns function to do the same thing in a lot of cases. Okay, there are very small nuances to these functions, but they're really not that notable. Honestly, like you will never really run into them or have to know them. It's to do with really the context in which certain measures are calculated in. But honestly, I just wouldn't worry about it. I wouldn't go too in depth here. It's just not essential. And then of course, you could ultimately, again, you could place a filter here like this. You can place this particular table function, this virtual table inside a filter, and then you could go, well, I want to utilize, you see here, that's called sales, but we've also got a table called sales, which is not good, but you see here this table here is recognizing that we've just referenced it in the table above, and we can say, okay, we only want to look at the ones that are higher than, say, 600,000, something like that, right? Push enter, should have put it in bracket there, and then that will update for us, right? 6 million. Okay, so you see here that is now, the table is much smaller because we're now looking at the breakdown in for each different channel, for each different product, okay? So that's the summarize columns function. Hopefully you're now familiar with that. Let's move on and we'll have a look at the generate function. Generate function. This is another table function. It does, again, a relatively similar thing to other aggregating functions, but it just does it in a slightly different way. Okay, so check this out. You'll hopefully recognize, first of all, that within generate you can place two tables. Okay, the second table expression will be evaluated for each row in the first table, returns the cross join of the first table with these results. Okay, so it's actually quite similar to the cross join function, but it enables us to aggregate things up that might not be in our raw data, might not be in our raw tables. Okay, and we can formulate these tables either physically, like we are doing right now, or virtually within our measures, inside of the array functions, inside of calculate. Okay, so that, repeat that number of times now, but it's really important. Okay, so what I can do here, and because it's a table, remember I don't have to put a physical table in there, I can put a virtual table in here. So I'm actually going to put summarize in here. Okay, I'm going to summarize my products by product name. Okay, so I want to bang my product name together with my cities. Okay, so I'm going to jump to my regions table, and remember that these two particular functions, or these not functions, two particular columns don't really actually have any relationship at all, right? They don't have any relationship at all, because they are both lookup tables up in the top waterfall layer of our model. Okay, and then I can say, okay, let's put revenue in here, and then because in summarize you can actually by itself you can create a virtual table, and so I'm creating two virtual tables here, which I'm going to bang together with another virtual table function and generate. Okay, then I'm going to go total sales like this. Okay, and then enter. Okay, and what this does is it actually shows me all of the different combinations, right? Okay, of these two particular dimensions, product name and city. And you'll see as we move down here, you'll see here that these are all 0 because there was no sales. Okay, I can go descending, and then you'll see that this is now looking at a combination of all of these product names and cities together. Okay, and then we could ultimately iterate through this, or we could put a filter around this as well. We could go filter so and so, just like I showed you before. Okay, so this is again just another way that you can aggregate things up. Okay, so have a good think about how this could be useful. I mean, ultimately you might be able to do this with just cross join as well, and then you can utilize cross join and add columns. And you can get a very similar thing. So look, there's many ways to the same outcome, and this is just another way to do it. Okay, let's round off the section with one more table function we can use, group by, which is actually quite an interesting one. So we'll dive into it, and then we'll round off the table functions, the advanced table function section. Okay, let's finish off here by going through the group by function. Okay, now again, this group by function is just another way to aggregate things up. Okay, and to be completely honest with you, I have rarely used it. Okay, but you could use it. You could become very familiar with its use, and you could be happy using it in many different ways. Okay, but from my perspective, I like to really focus on the things that make a big difference, and this is why this particular function is actually the last one in the section. Okay, there's a reason why I've done these in a particular order. Okay, but there's no harm in learning all these different things. The more across all of the different nuances to these functions you can be, the better off your development learning curve. The faster that you'll move up the learning curve of DAX in its entirety. Okay, so let's just run through an example here. So I can put a table in here. I'm actually going to put a physical table. I'm going to group by something here. So what I'm going to do is I'm going to group by my products. Okay, my product names, and I'm also going to then jump across to my regions table and group them up by my city as well. So basically, I'm just creating what we did in the very last video. Okay. But then within the group by function, you need to put some really interesting syntax. Okay, so I can go and put revenue like this, right? Very similar to what we've done in the past. But then you can't actually go. It's different. You can't actually go total sales like this, right? It will return an error. Okay, you have to have this very specific syntax here, where you have to use some x, and then you have to use something called current group, right? And then to check this out, access to the subtable representing current group and group by function can be used only inside group by function. Okay, so there's a specific function that you can only use within the group by function. Okay, seems bizarre, honestly. And then you can't even reference a measure in here. You have to actually reference, say, a column in a table. Okay. And let's round this off, okay, and then hopefully this should come out. Okay, cool. So now we've got a table of a combination of our products and of our cities, right? Again, these are from two tables up in our lookup table layer, so they don't really have a relationship, and we've generated a table with them in it. Now, I mean, I guess hopefully you can see why I probably don't use this that much, is because I can achieve exactly the same thing with something a little bit more simple and intuitive. Like this just requires some additional logic that can be more easily done in other ways. Okay, why they have so many different combinations of these, I don't know. It's probably because historically, the calculation engine worked one way, then they made some optimizations and then created different functions that were better. That's probably the most logical reason why that would be the case. Okay, so what we can do here, I'll just show you one example back over here, just to finish things off. What we could ultimately do here is this, okay? So let's just set something up inside here. I'm going to just get rid of all of these, right? And go to a city, and I'm just going to grab my product as well. I'm just going to grab the product name, okay? Then what I'm going to do is I'm going to grab my customers, and I'm going to make a table of that, okay? And then what I'm going to do is I'm going to create a new measure here, and we can use the group by function, okay? You'll see a use of this particular function. You could, honestly, as I say, you could find this using other functions as well, but this is just one way you use it. Okay, so what I'm going to do is I'm going to say city products sales, okay, and then I'm going to copy in my group by function there into the variable. Okay, so you remember this is going to be we can use this as a table function within another function, and then I'm going to come down to here, right? And I'm going to find the max. I'm going to use max x here, okay? And I'm going to go city product sales, and then I'm going to reference the revenue. So here I'm going to reference this column here inside of this particular iterating function max x. Okay, I'm going to bring it in so we can have a look at it. Okay, and we can work out what this is exactly showing. Okay, so the key here is to first identify, as always, what is the initial context of the calculation? The initial context of the calculation is May 2020 on the date. Also in here, the initial context of the calculation is the customer name. Okay, so after those contexts have been applied, then we are going to work through this particular table. We're going to iterate through every single row in this specific table. And remember, this specific table is a combination of product names and cities, okay? But it's only for product names and cities which have some sort of sales incorporated into them, right? Well, actually, in this particular case, it's not, because we've referenced the product name and regions table, these are actually on the same lookup layer. So we are actually though it's not going to matter in this particular case because ones that don't have sales are just going to return blanks or zeros anyway. But we are actually going to iterate through every single product and every single city combination within this particular formula for every single customer because these just aren't filtered with an actual context coming from here, okay? Because these are directly from the lookup table layer themselves, okay? Then what we're going to do is we're going to work out what the revenue is for all of those combinations, and then we're just going to return the top revenue, okay? And that's how we get the max X. So this is the max revenue from a city product combination for a customer, okay? And we can double check this by actually clicking on the customer. So say I wanted to place some additional filtering on the customer, right? We can then look at the customer's specific transactions in each city and each product name, okay? And we can see here that this is the highest one here. So we go down to another one. This is the highest particular sale for that combination for that customer. And we go down here with 47, and that's the highest one there as well, okay? So again, a pretty interesting insight that we were able to achieve relatively seamlessly if we just knew and we just know what sort of combination of formulas to use. Okay, I think that's enough. We've really done a deep dive into table functions in this section, so I think we'll wrap it up and we'll move on to the next one. Okay, now we're going to dive into some ranking functions, right? I'm just going to do a bit of cleaning up here. I'm also going to create another measure group. I'm just going to go into data, and I'm going to call ranking. I'm just going to call it ranking. We'll go through a few examples here because these ranking formulas we're going to go over in this section really open up this new realm of analysis that just honestly you just couldn't do this before in Excel or any other tool that I know of, and you can do it so efficiently. That's the fantastic thing. Okay, and so I think by running through some examples, you'll quickly see and know what I mean. Okay, and you'll also start seeing me like really combining a lot of the ideas we've talked and discussed about. You know, things. You know, it all starts with context, measure branching. Then we're bringing in table functions here and manipulating table functions. You know, we're gonna start incorporating all of these sort of things in with ranking, and you can create some really good visualizations, some really good analysis that you just honestly probably never even thought was possible before. Okay, let's just start simple though. Let's have a look at RankX. Okay, RankX is basically your core ranking function. Okay, so let's just create a new measure inside of here, and we'll just have a look at what we can do with it. Okay, RankX example. Okay, and I'll just go RankX. Okay, and it's asking me for a table here. Okay, what I'm going to do first is I'm going to get us the wrong result, and then I'm going to tell you why we need to change it. Okay, so what I'm going to say, because basically look, we've got a list of our customers here, right? I want to rank our customers. Okay, so I'm just going to put say my customer table there, right? Okay, then I'm going to put total sales. I want to rank by say a measure. I'm just going to use my total sales measure here. Okay, don't need anything in this value area. Usually, you honestly don't ever need anything in that value area. And then I'm going to go descending. Okay, and then I'm going to go enter. And what I will do is I'll compare it to our actual total sales so we can have a look at it. Right, and I'll just delete this. Okay, so my ranking measures are up here now. Okay, so if I bring this in, you'll see here that we get this weird result. We get this weird result of 1 for everything, right? It all comes down to the context here, okay? What you need to do with RankX is you actually need to remove, say we want to rank customer name here, you need to remove the filters or remove the context coming from the customer table, okay, to then go and actually do the ranking. Okay, so how do you think you do that? Hopefully you're thinking straight away, well, all, right? Because all is the remove filters function, okay? Or remove context function, okay? And then if I push enter now, what's going to happen is I'm then now going to get the rank of all of my sales, okay? So that's a really key thing just to have a think about, right? Is that you really want to be thinking, okay, well, how can I get the context within RankX? Because what RankX is actually an iterating, it actually does iterating, because you can see that by the X on the end. So what we need to do is we need to iterate through a table and then rank based on that, okay? The other thing to note within RankX is you have to be very aware of what the measure is actually calculating. You have to really understand what context is the measure actually calculating for me. The measure here of total sales is being dictated by what we have inside of here, right? It's being dictated by the context which we have in our report page, by the filters that we might have, okay? But it's also making sure, though, that it's working out the sales individually of each different customer so that it can then ultimately rank them in the customer context, okay? What's good about RankX is that you can manipulate both these parameters quite a bit. You can adjust the context in which total sales is calculated. Maybe you actually want to actually rank the customer based on what their sales were last year. Okay, you could ultimately change the context within here using calculate, or you could just calculate that in another measure and place it inside here. You could say, okay, well, show me what my sales were last year, the same period last year, right? Because what's sitting behind here is probably that same period last year function, time intelligence function, or date function, and I could rank very quickly by that, right? And you'll see maybe that's because there's no data actually. Let's see if I go to another month. Yeah, okay, there's actually no data, but in that particular corresponding in May 2019, so that's why it wasn't working. But you can do numerous different things within this particular section here. I like to keep things simple, and I like to create my measures like anything more advanced, maybe in a measure by itself, and then input my measure here just to simplify this area a little bit. But look, at the end of the day, it's totally up to you. Totally up to you how you ultimately use it. Okay. One of the easiest and cool ways that you could utilize this particular function is this. Okay, let's just do one really quick example here. So I'll just change this back to sales, total sales. Okay. Is we could ultimately say we only wanted to see the sales of a certain number of people, right? Well, we could do this. We could say RankX example 2, right? We could say, well, if the RankX example, the first example we did, was, and you could also write it out in full if you really wanted to. You could also put it in a variable if you wanted to as well. If and so this again is just like totally up to you. It is less than or equal to 5, then we want to show total sales. Total sales. If not, we want to return blank. Okay. So it's a really simple way to create this sort of calculation. If I drag this in, you'll see now that we're only seeing the top 5 sales now. Okay. And if we were to put this into a visualization like so, right? And we got rid of everything in between here, you'll see that total isn't right, by the way, but that doesn't matter if you're putting it into a visualization like this. We now are looking at a dynamic top 5 because I can change the time, right? And it's going to change the result in that particular visualization. And it's only going to show the top 5 because I've said return blank otherwise. And because of the blank, it's not going to return a value. Okay, so I think that's all for a bit of an intro on RankX. Hopefully you're sort of getting the idea around the context thing. We've repeated it many, many times. I think initially you probably thought, oh, this context, this is easy. But it becomes a little bit tougher as you move on, right? And you start moving into slightly more complex formulas. Okay, let's move on to Topian. Okay, now we're going to go over Topian, okay? When you initially come across Topian, I would imagine that there is generally a little bit of confusion, okay? But Topian is a ranking function. But the big difference between RankX and Topian is RankX returns a scalar value, what is called a scalar value. But Topian returns a table, okay? It actually returns a table of results. It's a virtual table, okay? And so we can test that within here, okay? So let's create a virtual table using Topian, okay? And we can see here, returns a given number of top rows according to a specified expression, okay? It can also return a bottom number of rows. You just have to turn it from ascending to descending, okay? So, for example, we want to see the top 2. Actually, we'll go top 5 and see here table. Remember, table doesn't have to just be physical. We could put a virtual table in here. But what I'm going to do is I'm actually going to put the products table here. Okay, we're going to order it by the total sales. It could be anything. You could use any measure. I just use the same one just for consistency. Then we're going to order it by descending. Okay, and then I'm going to push enter. Okay. So basically, what it's done here is it's gone and found the top 5 products based on their sales, and it's returned a virtual table of those products. Well, here it's a physical table because we're actually inputting it in a table. But we want to do this, and this is where the real power comes in on Topian. We want to do this virtually within measures. Okay. And it can enable us to do any number of great analysis, like really advanced analysis, really, really quickly, if you want to do anything around ranking, right? Okay, so let's jump back into here, and I'll show you a few examples of how this could be used, and how you might find something really interesting. Okay, say for instance, I want to count up how many sales have been attributed to my customers, but they have come from the top N products, right? So I only care about the top products, how many we're selling to us, what our customers are buying of our top products, okay? Or how many sales each customer has made of their top products. Okay, so like the top 5 products, how much of those sales are attributed to all of their sales? Okay, so let's do that in here. Okay, so I'm going to go let's go top 3 product sales. Okay. Okay. Now, got to think. We need to count up sales here, right? And we need to only count it up in a adjusted context, okay? Or with some additional filters in place, right? Because we have some context already applied here via the slices, also via the customer name column here. So we need to use, say, an iterating function. We could also use calculate. It would do exactly the same thing. I mainly prefer SumX or iterating functions. I just like the way that you can input virtual tables inside of here, okay? Which is exactly what we're going to do. Okay, so I'm going to come down to a new row and I'm going to go Topian. Because remember, within that table area, you can put Topian, which is a table function. Okay, I'm going to say top 3. And I only want to look at my top 3 products. And I could also go actually product name here, values product name. This is exactly the same because the product name granularity is the highest granularity in that particular table. I could then say, okay, well, I want to order by total sales. So I only want to look at my top 3 products based on sales. Okay, based on sales. And I want to do it descending. Okay, then I want to put in my total sales here. Okay, because I want to count up my total sales. Okay, and then push enter. Okay. Let's have a look at it inside of the table. Okay, so what this is showing is it's saying, okay, think about the initial context. It's basically this particular month and this customer here. It's saying go and find all of the products that this customer bought, but then only return the top 3, okay? Only return context for the top 3 based on their sales. Then when we know those top 3 products, iterate through those top 3 products inside of SumX, work out what the sales were for those individual products, count them all, save them into memory, and then SumX will sum them all at the end. It'll sum them up all at the end, okay? But what's cool here is we could say, okay, well, here are our top 3 products by sales, but what about if we want to have a look at our top 3 products by, say, profit margins, right? And then count up the sales for our highest margin products. Well, it wouldn't be top 3 products, that would be top 3 product margin sales, something like that, right? And I can push enter. And you'll see all of those results will change because now we're looking at a different product set. We're looking at our high margin products, not our products by sales. Okay, and you could also change this, right? So instead of total sales, it could be anything. It could be total profits. Maybe we want to look at the profits of our high margin products, right? And we can have a look at that, and then we could compare these products profits to our overall profits, for example. Okay, so pretty interesting formula technique, right? And there's numerous different ways you could use it. Okay, you could also use it. You could also get exactly the same thing by going like this, right? By going total profits up here inside of calculate, because Topian, just like any other table function, it can adjust the context of the calculation inside of calculate. Okay. It will calculate exactly the same way. Okay, it's totally up to you how you ultimately use it. Okay, I'm going to round off here, and then we'll go into some more examples and just run through how you can use this in other ways. And we can get pretty advanced. I'm going to show you like how far you can really take this. Okay. Okay, let's just briefly go over some other small nuances to the ranking functions, RankX and Topian, okay? Just things to be aware of, and just other ways you can use it as well, because there are so many different cool ways that you can utilize these functions, okay? So the first example, we're going to use just RankX, okay? And we're going to make things a little bit more complex here, okay? So what I'm going to do is I'm going to just get rid of that, and I'm going to bring in our first RankX formula that we use, right? As simple as it can get. This is just sort of ranking each customer, right? Each customer by their sales, okay? So we can actually get the rank, okay? But what happens? What happens if the context changes for this particular function, okay? Because there's a little bit more going on here, it's not as easy as just utilizing, say, total sales, which will adjust for the different context, okay? So what I'm going to do is I'm also going to bring in, I'm going to grab something from our products table, right? I'm going to bring this into here, and now have a look at what is happening to our RankX. It's really actually not producing anything meaningful for us. It's meaningless, basically. It's returning a value which is totally inconsistent with what we actually require. And that's because of the context change in the calculation and its interaction with this particular iterating with the rankx function. Okay. So if we actually wanted to create the rank, the true rank of our customer name product combination and sales, we're going to have to change up what we have inside of our rankx function here. Okay. And so let's do that. I'm going to create another function here, another measure, sorry. And we'll call this rankx example 3. Okay. Now the key here is we need to change the table in which we have inside of rankx. Okay, we need to change the shape of the table that we're going to iterate through to then go and do this ranking, right? Okay, so let's have a think about how we could create this table, because we've just been through the table functions, the advanced table functions section, right? The easiest way, in my view, is that we theoretically need to bang two columns together, right? We need to bang the custom name column and we need to bring in the product name column and we need to bring them together, okay? So in my mind, what would be a perfect function for that would be cross join, because that's what cross join does. It returns a table that is a cross join of the specified tables, okay? And within cross join, we can put table functions in here. And so what I'm going to do is I'm going to go and use a function called all, remove filters, because you've got to remember, within the first rankx function we looked at, we needed to remove the filters that are coming from the particular table in which we're trying to represent this ranking result, okay? And so I'm going to go cross join, because we need to do some internal ranking within rankx. We need to go through every combination of customer name, product name, look at their sales, and then rank them, and then return the result, okay? So then I'm going to go customer name like this, and then I'm going to go all product name, right? I'm basically going to recreate what is in our table, but I'm going to remove all of the context that is coming from it, okay, by using these all functions, okay? Then I'm going to go, I don't need a value. Actually, no, we do need an expression, sorry. So total sales, so I'm going to do it by sales, right? And then we don't need a value, and I'm going to go descending, okay? And then push enter. Okay, now if I drag this in, check out what that ranking is doing, okay? It's now ranking as per the actual sales. And that is purely because we have adjusted our formula for the context in which it is operating in. Okay, we're now iterating through the correct combination to get the ranking for this context. Okay? So that's a pretty key concept I want you to really, really understand well, okay? Because rankx can confuse you like no other function can. You'll be stuck on rankx forever going, why am I getting this result? And it's because of this, okay? It's because there's so much that rolls up into understanding how rankx operates, and that's why I've left it down in this part of the course, because you need to understand everything before. You really need to understand how table functions work to be able to achieve what you might need, okay? Okay, let's move on to another example here, but we're actually going to do a top-end example, okay? So what I'm going to do is I'm just going to get rid of these, okay? And I'll show you ways that you can use top-end. Okay, I'm going to go grab my region here. And I'm going to bring in my city. Okay, so at the moment, we have our city and customer name, some city and customer name context. We also have a monthly context as well. And then our sales are being broken down for each of those. Okay? The natural filtering is creating this calculation for us, or these results for us. Okay. What if I only wanted to see the top 3 customers? I want to create a table that shows me the top 3 customers from each different city. I don't really care about anyone else. I only want to see the top 3. Okay. And I want to see it dynamically so that when I click to a different month, I'm going to see the top 3 all the time. Okay. Here's how you can do it with top N. Okay. So we'll utilize, actually I'll just get rid of total sales from there. Okay, and I'll call this one by what it is. We'll go top 3 customers per city. Okay. What I'm going to do is I'm actually going to use calculate here, because I want to calculate up total sales. This is the way you can think of it this way. You could also use Summix as well, but I'm going to use calculate. I still want to calculate up sales, right? That's the way to think of it, but I want to change the context in which I calculate it. Okay, so what I'm going to do is I'm going to go top N. I only want to see top 3. Then within here I'm going to go all customers. Okay, I'm going to remove the context coming from the customer, right? Because we need to iterate through the customers in each different city, okay? We need to iterate through them to then go and work out their sales, right? And then only return the top 3, okay? And then I can just go, we probably want to put descending, right? Okay? And then you would think, okay, well, this should probably work. And then you just go enter, okay? This is not actually going to work, by the way. We have to do one additional thing, and I'm going to explain in a second. You see here that it's actually returning totally random results, okay? It's actually returning like the total sales of all customers, I believe. Or maybe the top, it's returning the top 3 customers' sales in its entirety, okay? But what I want to do here is I only want to show those individual customers and their individual sales, okay? What happens inside of here is we're removing the context coming from the customer, okay? But we actually, within this formula, we need to bring it back. And this is a really interesting use of the values function. You know how all removes filters? Values can actually bring it back. They can actually bring them back within formula, okay? Pretty tricky, right? It's another great use of the values function, okay? And so now, check out what happens to that result. Now that I've brought that customer name context back within the measure, after it was taken out in top N, we now are seeing only the top 3 of each, right? In a visualization. And then we could ultimately, we could come in here and we could create some data bars just to juice up the visualization a little bit. But it's pretty cool, right? And this is dynamic. This is a totally dynamic calc. And so it's just going to, and so maybe from a practical sense, how could this work? Well, maybe you want to go and issue discounts to your top customers, right? Or you want to do some special marketing to your top customers, or you want to offer rewards to your top customers in each different store location or each different region that you deal in, okay? This is a way to really quickly go and find those particular customers, or it could be salespeople even. You're rewarding salespeople, giving bonuses to people, etc. And if you think about it, like, look, there is some a slight nuance to it, right? In terms of you have to just understand how to bring the bring the context back within the formula. But think about how simple this formula actually is if you understand it. Okay, so it's just amazing how quickly you can find such a great insight and how quickly you can showcase it in a visualization just by writing something that has 3 lines of code, right? So it's just about truly really understanding how these actually work. Okay, so I think that's all. These are just 2 different ways that you can use it, 2 interesting ways you could use these functions, and hopefully now you've got a good idea of the differences, the real difference between rankx and top N, again, how you can use it in a few different ways. Okay, right, let's finish off this section and we'll move to the last one. Okay, so the idea behind this particular section in the course is just to go through some more advanced examples so you can see how you can start combining a lot of the ideas that we've discussed. I know that a lot of the course has been a little bit theoretical. I've tried to make it as practical as possible while talking through the ways that the formulas calculate in a lot of cases, or the functions calculate. But this is where we can just start combining all those ideas, right? And that's the key. That's the trick to really creating good analysis inside of Power BI, is to create these combinations of formulas that enable great insights, okay? And as I have mentioned a couple of times in the course already, there's almost unlimited ways that you can analyze things, right? You can start with a very simple model like this. I mean, this would be classified as simple, but honestly, this is all you really need in a lot of cases to do anything great. You can start with something that looks as intuitive as this, and you can really branch out into some great analytics, some just very, very advanced analytics. It's incredible. It's absolutely incredible. And so that's what really I wanted to showcase to you in a little bit more detail than what we've done in the past, okay? In some of the preceding videos up till now. Okay, so let's dive into it. We've got a few examples here, and we'll just talk through them as we go. Okay, in this particular example, what I'm going to show you is how we can compare different data over different time horizons, compare them on against each other. Okay, and I'm just going to change things up a little bit here, and we'll just build up from scratch. We've done it for a relatively similar scenario in another example, but this has just got a slightly different twist on it. Okay, and I just want to show you how we can do it. Okay, I'm going to build it up from scratch, so you can see all the different various ways you could ultimately calculate it. So I'm just going to create another measure group here. So you see I'm creating lots of different measure groups. I'm just going to call these advanced examples. What I would recommend in terms of this is the names I'm giving these particular measure groups are not ordinarily what you would have, right? Your measure groups need to be like really intuitively named. They want to be grouping time comparison measures, ranking measures, moving average measures, etc. Okay, but I'm just doing it like this just because I'm just trying to break out my measures so we can easily reference the ones I'm looking at in a particular tutorial. Okay, so basically what I'm going to do first is I'm going to set up my table. Okay, and again I always recommend setting up tables to see what results to compare results, right? To actually look at the results and see how they're calculating is really, really key. Okay, and then I'm going to bring in sales again, but it could be anything. It doesn't have to just be sales, or it can just be any calculation you could ever want, any core measure I like to call them that you have already generated. Okay, and then what I want to do is a quick bit of time intelligence, right? Because I want to compare information over time. Okay, so I'm going to create a new measure here. And I'm going to create this quickly because I'm going to show you how you can do it too. So I'm going to go sales last quarter like this. I'm going to go calculate total sales, and I'm going to use my trusty J add function minus 1 quarter. Okay, simple time comparison function. Well, I've already actually got one that's named this, right? So I'll just call total sales last quarter. Okay, so we've already gone through some examples here of that, right? Okay, so I've got total sales last quarter. Okay, let's just clean this up. And then I might want to go, okay, let's have a look at my sales. My sales from the last quarter, from last year. Okay, total sales last year. Well, instead, because we're analyzing them quarterly here, right? I'm going to change this to year. Okay. So we've already done this calculation before, okay? Then I can bring this into here, and now I know that I'm comparing to the prior year. I don't think there is actually information for every single day in that prior year, so we'll probably have to go to 2020 here, quarter 4 2020, okay? So now I've got daily information for every single quarter, right? I've got daily information, but if I turn this into a visualization, it's really not going to show me much, right? It's not going to show me too many interesting insights because it's just too busy a chart. Okay, so this is where cumulative totals come in, and they're an essential thing to use when running some sort of time comparison analysis, okay? So what we want to do in this particular case is we want to create cumulative totals. Okay, now we've created the cumulative total pattern before, but let's review it because it's a really good one to review. Okay, so we can quickly reuse it over and over again. Okay, so cumulative sales, I'm just going to go calculate sales, right? Then I'm going to go filter all selected, and if you use the effective use of tab is really key here, right? Because it can enable you to quickly write these functions, like very quickly write these functions if you know what you're meant to be writing. Okay. And you'll find that there's similar patterns to these, so you can really get used to them quite quickly. Okay, so I might change the name of this to cumulative revenue, I think, just so we don't get have any repeats, because it doesn't allow you to name two measures exactly the same. Okay, so now you see here, this is the cumulative result. Okay, now I don't need to do anything tricky here. All I need to do is copy what I've already got there, paste it in here, and then change this from total sales to total sales last year, right? Or last quarter, because I want to compare last quarter results and also last year results, right? Sorry, this should be cumulative revenue last quarter. I'm going to change the name. Okay, and then I'm going to do one more. I'm going to go cumulative revenue last year, and then I can just go sales last year here. Okay, so I'm just grabbing the same measures that are in our, actually this was total sales last year, wasn't it? Yeah, it's the same calculation. We're just repeating the measures, which you shouldn't do. You shouldn't be repeating the measures. I'm just redoing this from scratch to show you, okay? And you see here that I just literally copied and pasted. What I did was I went copy and paste, and now I have the cumulative calculations, right? Okay, and so now that I've got these cumulative calculations, well, I can turn this into a pretty interesting visualization, comparing things over time. You know, I love how easy this is now. I just create the cumulative total. It's just incredible, right? And so now I have a really interesting cumulative total that is dynamic by date, right? I can click a different date. Maybe I'll go to 2021 because that gives us a bit of comparison, right? And I can see how things change, okay? But we don't need to stop there, because what we can do is we can place even more filters on this, right? So say, for instance, we're looking at all sales here, right? Well, what if we want to just look at particular regions? We want to look at particular cities, okay? And so I might want to create a visualization that looks like this. So I'll just grab my profit, we'll put it into a visualization. And that's actually a bit too busy, so I would never use a visualization like this for data that is that busy. So what I would probably do is turn it to this, right? And that makes a lot more sense. And then what we can do now with these cumulative totals is that we can now dive specifically into individual, so check that out. So we're looking at all of those different results from all of these calculations here cumulatively, but then we're able to place this additional filter over our city to see how we performed per city. We could also multi-select. I'm just holding down control here, right? I'm just holding down control so we could aggregate things up slightly differently. So now we're looking at our top 5 cities in this particular quarter, for the current quarter, top 5 cities by products in this particular quarter. Then we're comparing our sales for those 5 cities versus our sales last quarter and our sales in the last year, same quarter, okay? So just the insights are just incredible, right? And how quickly you can get here. I mean, that's what I'm trying to showcase to you. If you can combine a lot of these techniques, this is the type of stuff you can do, and you can do it very quickly. I mean, this is going to amaze anyone. It's truly amazing how quickly you can get here. Okay, so that's I just want to show you this example again, or a similar one we've done before, just to reiterate, and how you can extend things. Oh, actually, before we run off here, I'll show you one other thing, because you don't just have to end here. What you could also do, and I like doing insights like this as well. So let's look deeper into these particular results here, right? Let's look deeper into them. And what I can do is I can say, okay, we'll compare. Let's compare this, the cumulative. Let's create the cumulative sales difference, right? And so what I could do is I could go cumulative sales. Currently, the cumulative sales minus, or cumulative revenue, we'll keep it the same, right? Cumulative revenue minus the revenue last year, the cumulative revenue last year, right? Okay, so I now have that as a measure, and so I could bring this down here and add that into the. So now I'm able to see, so we need to forget about the dark blue line here. We basically want to see how we are performing versus our sales last year, and we're actually diving into it a little bit deeper so we can see, okay, we ended out on top for this particular city, even though most of this particular quarter we were behind. Okay, and then same for the city. I mean, the data discovery is just amazing. It's just amazing. It's really amazing. Okay, let's move on. That's a good example. Let's move on to the next one. Okay, so I've just rearranged things a little bit in our report, and I've created a table with our data, okay? And we're going to go over how you can utilize count rows in some really unique ways, okay? Because if you think about count rows, it counts up a table. It counts the amount of rows in a table, okay? So let's have a look at the very simple form of that. So I'm going to find total transactions here, okay? So we've got total transactions, and let's have a look at this particular measure. So you see here that count rows is just counting up the sales table. But you got to remember, for each different result, the sales table is going to look different, right? So that's how we're getting how many transactions happened on every specific day, okay? But what's great about count rows here, right, is you can put in a virtual table, and you can put in really complex virtual tables to find like the most unique insights you could ever dream of, okay? So we're going to do just that. So I'm going to go new measure here, and I'll just start creating a measure. I'm going to go count rows with virtual tables, okay? So let's just go count rows. So it's going to count the number of rows in a table, and as we know here, with table, it doesn't have to be physical, it can be virtual, okay? Now, when we start combining all of the things we've learned prior up to this point, right, you can really dive into some just fascinating insights, okay? Say, for example, we wanted to calculate how many of these transactions were actually for our top 5 products based on those product sales, okay? So I only actually want to count up how many of the transactions went to my top 5 products, okay? So think about what you need to do there. You need to do some sort of ranking, right? You need to do some sort of ranking to enable us to, for every single row here, remember, we want to calculate up how many were just to our top 5 products out of all of the products that we have, okay? So some sort of internal ranking needs to be created here, okay? And guess what? That internal ranking can be done with the top-end function, because the top-end function is a table function, okay? But that's not all. We do need to do a little bit more, okay? What we need to do first of all here is we want to count up the sales table, right? So think about like what the total transactions measure was. So just counting up the sales table. Well, we still want to count up the sales table, okay? But we want to do it in a different context, okay? Because that sales table is going to be manipulated by our internal ranking that we're going to create for that products table, okay? So hopefully this is bringing up the function we need to use here. Calculate table, right? Because we want to count up the sales table, we do want to, but we just want to do it in a different context, and that's what calculate table enables you to do, okay? So I'm going to put my sales table in there. And then here, within my filter area of calculate table, this is where I can adjust the context of the sales table for my internal ranking, okay? And that's where top end comes in, okay? Because top end is a table function, okay? And it enables me to change the context of a table, or change the context of a calculation as well, okay? And so what I'm going to do is I'm going to say, okay, I want to only look at my top 5 products, okay? So I'm going to go all here, because I want to have a look at all my products, and I want to rank it by total revenue, okay? So I'm going to put total revenue in here, or total sales is fine, total sales, and then we're going to go descending, okay? So what this is enabling us to do is we're still going to basically count up sales table, but now only for the top 5 products, okay? So let's just go enter. And let's bring this in here, see what results we get. Okay, so you see how now we're seeing how many of those transactions were just for those top 5 products. Okay, but one thing to note here that is a little bit of a trick is what context is this total sales being evaluated in? Okay, this total sales is being evaluated in this particular context right here, right? So we're actually only ranking the top 5 products by each individual context for each individual row here. Okay, so you see here that in on this particular day there was 5 transactions. Well, it's highly likely that there was actually only 5 products bought on that day, 5 unique products bought on that day. Okay, and so what we need to do here is we need to actually adjust the context of this total sales, because say we just don't care about the day. We want to look at all sales. So we're looking at the overall ranking of products across all of the sales that we've seen so far, or we've seen in our data set, okay? And so what we need to do there is inside of here, we would actually need to go total sales, all dates. We need to remove the filter from the dates here so that we're actually looking at all of the sales through time, okay? Instead of just the sales which are happening across in a particular context, okay? So it's quite interesting, right? This is quite interesting. You could also, and this is where all selected could come in. Say, for instance, you wanted to rank the top 5 within just the selected time frame. Well, you might go all selected instead. Okay, so you're just looking at that particular time frame. But say you wanted to look from the beginning of time, so you're looking at the overall rank in its entirety for each product. Well, then you just go all like that. And you see how those values are now changing, right? So that's all I wanted to show on this one. So another really cool example, and just venturing further and deeper into virtual tables, which are just where things can just get super advanced and super interesting from an analytical perspective, right? These sort of you might think, I'm hoping you don't think this is too complex now after going through this course, but definitely I'm hoping you're seeing here by going through this, especially this example, is how advanced, like how unique the insights are that you can generate using formula that isn't that long, isn't that complex. It's like just about understanding all of these key fundamentals and bring them all together. Okay, I think we've done enough on this example. Let's move on to the next one.